moving on. I'm moving on. Got nothing left to say. Let's be on my way. Best of luck. I'm moving on. I'm moving on. I got a new love. He runs for miles. 67 fastback. Oh, it's just my style. We're headed down, down, down the road. Just enjoy the show. Watch me as I go. Shut up both ways before you cross me, baby, 'cause I don't break for boys. I'm moving on. I'm moving on. Got nothing left to say. Let's be on my way. Best of luck. I'm moving on. I'm moving on. I'm moving on.
Welcome, you're watching Formnext News, brought to you straight from the Frankfurt fairgrounds with the latest and upcoming stories from the world's leading exhibition on all things additive manufacturing and the next generation of industrial production. My name is Shristi Mangalpal and these are today's top stories. Formnext hits the fairgrounds running in 2022 with about 800 exhibitors, with companies hailing from 33 different countries, about 60% of which are based outside of Germany, making the fair an international celebration of the art of 3D printing. Let's begin with today's headlining industry news. Waller's report usher in some welcoming news. Additive manufacturing now accounts for a whopping $2.4 billion in revenue in the field of medicine and dentistry. Adorning this year's exhibitor stalls should therefore be 3D printed applications in the field of orthodontics and implantology. Next, Stratasys Limited have signed a definitive agreement to acquire the additive manufacturing materials business of Covestro AG. The company will expand its differentiated materials offering in stereolithography, DLP and powders, supported by a broad IP portfolio, offering more full solutions to customers and accelerating next-generation materials development. The acquisition will include R&D facilities, activities, global development and sales, teams across Europe, the United States and China. The purchase price is reported to be approximately 43 million euros. Covestro has been a key part of Stratasys' third-party materials ecosystem, and the acquisition will benefit users using multiple Stratasys 3D printing platforms. Stratasys is already a distributor of Covestro Somos resins, and they are already available for Neo and Origin One 3D printers. Now on to some news from this year's partner country, France. France Additive reports this year France reaches a record as the top 6 market for additive manufacturing, with a volume of around 500 million euros and double-digit growth rates, making the nation one of the most vital partner country and the focus of this year's Formnext 2022. This year, France is also making waves with its cutting-edge product innovations. French exhibitors will be present, among others, at the Formnext French Pavilion in a special area in Hall 12.0, C33. Exhibitors this season have brought along exciting product reviews. Let's have a look. Lectra GmbH is introducing its latest 3D printer with multi-nozzle technology that increases the productivity of the FFF printing process without higher speeds or nozzle diameters. The patent-pending multi-nozzle technology of the Lectra FX7 Pro achieves a productivity increase of up to 300%, states the company. One-Click Metal is set to expand the application possibilities of its LPBF printer with 2 additional modules. Company sources say the new lab module enables the flexible use of different powder materials without the need for a time-consuming material change of the entire system. It is particularly suitable for small powder quantities, research purposes, and the classification of materials. The second expansion is the heating module that adapts the temperature of the building plate to the conditions of different materials and components, thereby reducing residual stresses. With its new XM300G series, the US company Exact Metal hopes to make metal 3D printing both more cost-effective and decentralized. The series features an independent single, dual or quad laser system with 100% overlapping print zones. Today, Formnext's young entrepreneurs and innovators shine under the limelight. The additive manufacturing community produces a large number of young companies year after year. In order to give these startups a voice in circles of established players, Formnext has organized the 8th edition of the Formnext Startup Challenge. In addition to new, creative and viable business ideas, the topic of sustainability shall play an important role. Hence, for one of the nominees, the AM Ventures Impact Award shall be up for grabs. The winners will each have a dedicated exhibition booth and will present themselves at the Formnext Pitchnext event on Tuesday, 15th of November. The winners of this year's Formnext Startup Challenge have been announced. Photosynthetic from the Netherlands, Lattice Medical from France, Rivelan Robotics from UK, SpearQ from Italy, and Alpha Powders from Poland. The AM Ventures Impact Award also went to Lattice Medical. To meet the winners and jury, visit the Pitchnext event live on 15th November from 2 p.m. at the AM4U area in the hall 11.0 D72. On to the event highlights next. What's in store for the upcoming Formnext days? At the AM4 panel, Formnext brings together female powerhouses in 3D printing. Top women from several industry applications and major players, such as in aerospace, oil, gas, transportation and hydraulics industries. Presenter Sven Kraus shall applaud our female role models in an interactive panel discussion. You too can join them in Hall 11, Level O, D72. Tuesday shall have several short but in-depth presentations, one of them being a cooperation with the VDMA Working Group Additive Manufacturing. The talks shall be on machine connectivity and machine integration. Get a glimpse of the live event from 10:40 to 11:20 a.m. at Hall 11 D72. Celebrating past laurels, organizer Crib has partnered with Formnext. Together, they look back on 10 years of Permundus Challenge and present the decade's highlights. All award winners since 2012 have been cordially invited to present their prize-snatching exhibits to the specialist audience and to report on how their ideas, their products, and their business model have developed. Check out 10 glorious years of Permundus Challenge at Hall 12.1 in stand C01. With these top stories adding wind to our sails, I wish you a successful fair day ahead in the Formnext arena. Don't forget to follow us on our social media platforms. You'll find the links below in the description area. Until then, stay tuned and keep thinking three-dimensional.
Welcome to Formnext 2022 and welcome to the AM4U stage here in Frankfurt at Formnext. And welcome here, my dear guests. We are here in the morning talk, and I'm very happy to have Petra Harburger here with me. Petra is president of Mesago. Then we have Sascha Wenzler. I'm very happy, Sascha, to have you here because Sascha may be the most well-known face here in the exhibition halls. Sascha is vice president of Formnext.
Good morning.
And I'm really happy to have Sven here, Sven Krause. He's my co-host here on the stage, and I'm very happy that you will be host here for a lot of lectures and presentations here on this stage, and I think there will be very, very much interesting news and insights which you will bring to the audience. And then we have Alexander Chisek. He is here with a very special project. Later more to that concerning that project. Alexander brought here some news to us with some very interesting and important topic. But starting with our host, Petra. Petra, what does it mean to you that we are now and right here in the exhibition?
I think it's just so wonderful to be back. As an exhibition organizer, you know, it wasn't so normal for the last 3 years, as everybody knows. And yeah, it's just always this sparkling, great feeling to be in the halls again, to hear this buzzing. And Sascha and I, we just met for breakfast this morning, and we walked here, and this excitement rises while coming here. And then when the doors open, it's just like, yeah, I mean, this is our passion, this is what we love, and we want to bring people together, and we just look forward to doing this in the next 4 days.
It's a very, very, the time is very consuming right now because it's not the only exhibition you're running.
Yeah, it's true. Actually, we had a very successful SPS last week, which is on automation. It was staged in Nuremberg, and I just said at Mesago we always have this exhibition marathon as our 2 biggest shows are in the end of the year. But I mean, what's nicer before Christmas coming, having the 2 nicest and biggest events successfully, and then going into celebrating a little bit and then into the next year. So I think this is just wonderful, and it just keeps you up on this high level of, I think, adrenaline when you're here and seeing all these smiling and anxious faces, actually.
Yeah, perfect. Sascha, you and your team organized a really comprehensive framework program. What can you tell us a little bit? What is we cannot cover everything for sure, but can you tell us a little bit about your highlights? What is there that you're very interesting most?
Yeah, so it's at the moment, or for this edition of Formnext, I think the most comprehensive side event framework we ever had, because we always had a kind of mission, creating not only a show floor where square meters are relevant, but creating a space for a community. And therefore it was also very important for us as organizers to support and create platforms for know-how transfer. So we have a lot of content side events running. Many of them are here on this stage, are transmitted live and hosted by you guys. And many more are in the halls. So we have.
Can say some examples, please?
Yeah, we have a special show for building and construction, for example. Then, together with our honorary sponsor VDMA, we have a user case area especially dedicated this year to the OPCUA platform. So it's machine-to-machine communication, and that's highly important for the community, because additive manufacturing grew up, it's very mature. So now we talk and we show a lot of highly industrialized topics. And furthermore, we have a partner country, France, this year, and the whole Wednesday is dedicated to France with a French program. So there are a lot of sessions and lectures going on in France. We have a new format, it's called Deep Thought. It's also taking place here on the stage. And in Deep Thought, with keynotes, lectures and discussions, we concentrate very deeply in a technical topic, also in this industrialized framework. So these are some of the, let's say, technology highlights. And then for sure we have, and Alex knows this perfectly, we have the Startup Challenge running since many, many years, right from the beginning of Formnext, with the Pitchnext event, supporting fresh and new companies, joining the market, coming in the market, and presenting here to all the audience their abilities. We have a best of 10 years per Mundus Design Challenge, because additive 3D printing and design are very familiar, and you can create a lot of beautiful things by creating them in an additive way. So all these things are happening throughout the show days.
Sven, you're covering a lot of sessions for the whole week, and can you give a slightly overview about what you will host here on stage, or what you know that will be interesting for the visitors?
So it's super difficult to pick out a highlight, honestly, regarding the program over the next 4 days. We kick off today with a super exciting panel from Women in 3D Printing, heading over to the just mentioned Pitchnext event with our exciting startups here from Formnext. This year we have 20 pitches, so it will be a marathon, as Peter said, but in a positive way. And there's so many panels and experts' insights to come. So it's really hard to pick some out. My personal highlight is the stage, and that we're doing this in this intense form this year. This is my personal highlight.
Okay, Alexander, as I mentioned earlier, you are here with a very special project. Maybe we come back later to some other topics. But at first hand, I would like that you give us an insight about your project. What is it? Or maybe we begin. What is your role in additive manufacturing? That we know who you are and where you are coming from.
I'm Alex. I'm CEO of 3Mind. 3Mind is a software which enables on-demand manufacturing. But I'm not here in this role, actually. I'm here to present something else. I'm not sure if we can show one slide which I brought. There is one important thing on the slide. Exactly. So for everyone who wants to have a little bit of fun and also do and support the Ukrainian community, they should scan this QR code. So what we have observed in the last couple of days is that, months actually, is that many of the community members got together to help in a difficult project and a difficult time. And we saw the same during COVID. However, now during the war just next door, it seems that the stakeholders which are involved in supporting humans and their need are much more getting together. So this is one difference which I have at least observed. And with this cooperation with many different companies, it wouldn't be enough to mention all of them. Those logos over there on this slide, this is just an example of many more contributors. We got together and we decided that we want to produce parts which are missing. So we basically executed the concept of on-demand manufacturing in a very harsh environment, because we had to do it very quickly. And so what happened is that, first of all, well, we raised some cash to produce parts, but we also produced around 40,000 parts. That resulted in over 30 documented life savings, and also 8 critical surgeries which need to happen very quickly. And what we want to do at Formnext, and thank you by the way for supporting this initiative, is to fundraise for this purpose. So if you scan this QR code, you will end up on a platform where you can auction some items, and all the proceeds from this auction will go to this good cause, this charity.
Cool.
A lot of business people are very concerned about, being too much political. You did not have that impression.
Well, it is not about politics in the first place. In the first place, it's about saving human lives. So the parts which are produced are medical parts. A very interesting thought, by the way. During COVID, there was also a need for medical parts, but then also during COVID, we ended up in this certification roller coaster. And during war, everyone forgets this problem. However, you still want to make sure that the parts we produce, for example, we produce the tourniquet, which basically the function of this part is to make sure that your wound doesn't, that you don't lose too much blood when you're wounded. And we still wanted to make sure that obviously whenever a soldier or a civilian uses a tourniquet, then that it works and doesn't break. So a company from Warsaw, Signis, did a couple of test prints. They tested it in real life, and then we, were sure enough to just say, okay, this part is good enough to ship it to, to Ukraine. So again, for me, it's not political. For me, it's about the human aspect of this crisis.
Can you tell us a little bit about the donation project? What can a user or a visitor, when he scans the QR code, what will he discover? What will he find there?
Right. So once scanning the QR code, you will end up on an auction platform where you will see a couple of very, very cool items. We have 3D printers, we have materials, we have a Woolers report, we have a subscription to the AM Power online course, and a couple of very, very cool other. My favorite one is, I think, sunglasses, 3D printed. Once you're there, you can just purchase or auction on those items, and if you win, first of all, you get the item, but also all the proceeds without any processing costs will go directly to support the good cause.
Did you already had a chance to look at that project and to scroll through the different items?
Yeah, so we were in content I think since a couple of weeks. So it's like Alex is saying, it's a very human project. And just yesterday I received a tip to exchange the glasses, so maybe I do the ones which are printed from the auction and not just go in a shop for printed glasses. So yeah, it's a good combination of AM and human aid.
Petra.
And if I may, just sorry, one more thing, because you asked, is it political or not? I think, right now we have this urgent problem of helping people in Ukraine, but I hope that, together within the Formnext contact, that's just a little bit of a seed which I want to plant, is maybe we can do it every year, and hopefully not for Ukraine, hopefully for other people in need.
I think it's an attitude thing as well, and I think this is exactly what we're here for, bringing people together, and this also, it helps AM, but this, I think it's wonderful to be able to use the community also to do humanity and to help that. So I think this is very nice, and I hope that we go, and the auction will really raise a lot of money that goes directly there. That would be wonderful.
Alexander, you mentioned the printed products. We have two products here on stage, actually. Two nice examples, and I wonder if somebody from you would take one of these home to furniture your own home. Here we have a table over there. Results of Mike Doberak of 3D printing startup Big Rep in Berlin with a large format FDM printer, and he said that the challenge was to develop shapes which show that they were produced using a digital manufacturing method, but that they are also functional and useful. And I'm very happy that we have this piece here, because it combines a lot of things we are talking about on the exhibition here. So not just making a product, but making a product in a different way, in another way. And I think that's what your donation project says as well. You were starting very, very quickly, or you had to start very quickly, so to get to the people very fast, right?
Exactly, yes. As to your question about would I have it at my home, we have it in the office, exactly the same table. At home, I have to negotiate with my girlfriend, but and also to the other point, we have some items from Big Rep on the platform as well. So please have a look. Maybe you like something. But the aspect which you just mentioned, The important part of it is that with AM you can produce very fast, and parts were just missing. So the concept of on-demand manufacturing, it's not only something which AM started and is successful in delivering, but it's also something which sets a trend for other production technology. So, for example, we see customers who say, look, this on-demand concept could be applied also for other production technology. So this is where we are setting a trend as an AM community, I think.
Yeah, and we have really difficult times. So it's not only the war in Ukraine. When you take a look on the planet, what happened the last 3 years, it was a crazy situation. We had the pandemic. We have severe supply chain disruptions. We have lack of material. We have still the question of climate change. So it's just, it's a century topic and it's still not solved. So we have many, many problems around the planet and increasing problems. And also, in my opinion, AM cannot solve these problems overall, but additive manufacturing, and that's what you will hear from the, for example, from the TCT conference. Just to two people talk on a booth with when the companies discuss and their customers, AM can bring a part of a solution, or AM can create. When you use AM in an intelligent way, it can create at least some new ways of manufacturing goods, of thinking of new products, of rethinking supply chains, of dislocated production. So all these advantages of additive manufacturing are able to give at least little or a part of the answers to all of our today's really relevant problems all over the world.
And I think, Alex, what you just said is so important, is this different approach also to do things and to do it fast and not to maybe plan for years, because I think we don't have any more time to plan for years sometimes. And I think this is also something, it's a mental change maybe also a little bit, and this approach that came through the AM community, because the overall production and this help now is so instant and so spontaneous. I think this is something lots of people can learn from, because as I said, I think it's an attitude to really just see the problem and to try to solve it. And maybe not perfect right away, but to help, and then you improve.
Well, I think there are a couple of aspects to your point. So first of all, let me give you my observation. So we see companies investing millions and almost billions into, first of all, their logistics, their warehouses, but also into predictive maintenance, and still downtime happens. And downtime is so expensive, right? So I see, the ability to produce on demand is just an addition, to the insurance package, let's say, if you want. To make sure that your production line is running. Now, to get to the point that you can produce on demand, you can produce a part on demand, you have to invest a little bit of energy, right? So this is the let's say, upfront cost which one needs to take, which is related to qualification or requalification. And it doesn't apply only to AM, but because AM is having this feature of producing producing fast, yeah, you have to requalify your parts sometimes, right? Which is painful, but many industries go into that direction anyway.
But when we are talking so much about the Sven, about the advantages, did you recognize it in an upgrowing market for the exhibition as well? So do we have more exhibitors here, or different kind of exhibitors?
I think definitely we did see a great development during our Formnext history, I would say, yeah, starting from really having more the core of the, I would say, AM community who really do additive manufacturing, but I think now coming into this more industrialized way and application, there's so many now doing, for example, in the post-processing parts, we just saw, people looking at surfaces, improving them. So I think this is something we really see, that the AM community grew. Yeah, not only the core, but everybody who has to do with specializing and doing really final parts that work.
Exactly. So it's not a discussion about a printer or an AM machine alone. So it's about for a customer, on a customer point of view or a user industry, it's about manufacturing solution. And that's exactly what happened over the last years in the additive manufacturing industry. This shift towards manufacturing solutions. And also it's not a discussion anymore, do we produce parts on a conventional way, or do we choose to make them additive? Because now everybody understands, hey, additive is a puzzle part in a manufacturing environment. And you need to find the right place where to put it. And then you can also, you gain the benefits out of it, you can create the business cases, and therefore we see here, and for this year you asked, we right now have 802 exhibitors on 4 show floors again, like in 19, it's nearly the numbers of 19 with 855 going back, but last year we were also happy to host the more than 600 companies in very difficult pandemic times. So more and more companies are also entering this industry, showing their technologies to create surfaces on parts, to control the quality of parts, to color parts, to separate parts, or in the pre-processing, weighing, measuring, quality control of the material.
So if you look at the process chain, you really cover the whole process chain from the visitor's point of view. When the visitor comes, can he find from the first beginning to the post-processing everything, every step?
Yeah, that's what we created. Also, it's a very deep core of the concept for Formnext. So it's just right. Beginning with the idea, how to bring an idea to a final part, you need a lot of steps. And these steps are covered on the different stands from the companies showing these technologies.
Sven, you had a question earlier, but I think it was not concerning the process chain.
No, it was rather an advantage that we see here with this project that Alex just mentioned, and Peter, you as well, the topic of regulation was falling aside. And this is something I really would appreciate if we still push the limits, that regulation goes faster, because sometimes I feel like AM is limited or challenged by regulations all the time, and this hinders the breakthrough. And I would be happy not only having crisis to cover that, but to get in the positive situation that we sometimes get faster to a product, because whatever we see in AM is solving problems, and most of the time the main challenge is then regulation and bring it to the market, especially medical. If you think about orthopedics, I mean, this is really a pity that we need like 5 to 10 years of regulation instead of bringing the products directly to the market and see how they help right up front.
Alexander, is the regulation the only topic in getting what hinders us in getting faster to the market, or do you see other aspects as well?
I see other aspects as well. Regulations are important, but I also think that what is important is to first of all have the trendsetters, so the forward-looking companies which go ahead and set up some standards, de facto standards. And secondly, it's important also that we have followers. One very cool example which I want to mention today is from the railway industry, which I think is setting a trend and creating a market, actually, if you want. For example, Deutsche Bahn will, from all trains which are bought after 2030, Deutsche Bahn will ask the suppliers to provide spare parts until the end of the lifetime of the train. If the supplier cannot provide the spare part, then the Deutsche Bahn will ask for the digital twin. So that is forcing basically the suppliers to be able to produce parts on demand, probably with additive technologies. And for me, it's creating a market.
But there you have the regulation topic as well, because you have a lot of security issues when talking about train applications. So that may be a problem there as well.
I think it's the question and the answer. So yesterday we attended the ASTM Standards Forum, for example, where the standardization and norms specialists from Europe and from the US met to talk about creating joint standards for additive manufacturing. And these standards, also when we are sitting in a train or we are boarding an aircraft, I think everybody of us wants to be quite sure that the parts used in such technology we are sitting currently in are quite perfectly certified and have the quality they need. So it needs to be done faster, but on the other hand, it needs to be done because the certification process is necessary for industrial way of manufacturing the product. So, and it's happening. But like all things, especially standardization needs more time than we would wish to have everything faster on the street.
Yeah, but as you said, Alex, I think you need the ideas first, yeah? And you need the innovation. You need somebody who has a great idea, and then you start. Usually, you have these first movers, you have the followers, and then usually through scaling, you get into this standardization thing. Yeah, beforehand, it's more of an idea, and bringing it to life is important. And so you need both of it. Yeah, you need this. I always say this. I don't think I've ever seen any exhibition or any industry even I know that has been so innovative, that where there were so many people really look at the startups, how many people come up just with great ideas. And I think this is also the spirit that you feel here, which I love, and I think we like it all the time. That is, in comparison, as I just said, we had the SBS last week, and if you look at automation industry, it's just a completely different mentality there than it is over here. And I think this is essential to really have people who have great ideas and also who want to change things, who really are burning for really doing this. And I think, this is part of the success story.
Yeah. And if I may just very, very quickly add, because we talked about regulations on one hand, but at the end of the day, it was about the quality of the part. You mentioned the example of the plane. I think that, yes, we need regulations to make sure that the part is certified and is well done, but it's also a big area where technological solutions can come in, right? So that's the beauty of our industry, that we are basically playing on a green field, and with technological solutions, we will be talking about OPC-UA later today, with ensuring that the part was produced as planned. That's kind of where this industry goes, and the learnings from this industry can be applied also in other industries.
Yeah. Sasha, one sentence concerning the industry sectors. Can give us a brief insight about where the visitors will come from? Do you have some numbers from the recent years? So do they cover more automotive or more mechanical engineering, or the air and aviation sector? Can you give us some numbers?
Yeah, so a large portion of visitors historically come from aerospace, from automotive, from medtech, medical technology, from the dental field, and from mechanical engineering. These are the big five. But now, like Alice just mentioned, additive manufacturing can be used not only in the product, but in nearly every manufacturing environment on the right place. So we have a lot more industries joining additive manufacturing or discovering additive manufacturing. Therefore, just one more event, the Discover3D Printing Seminars, because our mission is also to encourage new or smaller or medium-sized companies to come in touch with the technology, to use AM and to discover the advantages. And there you have building, construction, the white goods, so many more possibilities, application possibilities joining.
And we will see most of them here on stage. So that will be a very interesting week, I think we have ahead, and I'm very happy to have you here. I wish you a lot of success with your project, and a lot of money for the donation. I hope it will really run fast and high. Dear visitors, I only can encourage you, the audience, to support all these projects with all your might. But now I would say let's start into a trade week together. And after a short break, Sven will again be here on the stage, and I think he will welcome some interesting women in 3D printing.
Great.
Wir selbst als interner Jobshop für 3D-Druckbauteile haben uns als zweite Säule den Druck von konturnah gekühlten Formeinsätzen auf die Fahnen geschrieben. Wir haben seit Jahren entwickeln wir diese Prozesse dafür und wir setzen diese konturnahen Kühlkanäle dann ein, die Werkzeugeinsätze dann ein, wenn wir irgendwo einen Vorteil sehen. Also entweder wir sind qualitätsseitig wesentlich besser, wir können besser temperieren, wir haben vielleicht auch eine Zykluszeitverkürzung, aber vor allem ist es der Qualitätsaspekt, der uns da treibt. Und der Vorteil hier bei uns ist, wir haben die eigene Konstruktion für unsere Warmumformwerkzeuge im Haus. Wir haben unsere Warmumformfertigung in Münster, die wir beliefern mit solchen Teilen. Und das ist eigentlich der entscheidende Fall. Wir können auch die Werkzeuge selbst erstellen. Wir erstellen die Werkzeuge selbst, setzen diese Teile dann ein und erproben mittlerweile sehr erfolgreich Werkzeugsegmente, so dass wir in einen Standardprozess jetzt gekommen sind, wo wir solche kritischen Werkzeugbereiche sehr früh schon identifizieren und dann mit unseren Schnittstellenpartnern ins Gespräch gehen für 3D-Druckeinsätze.
Wir stellen keine Bauteile, keine Sichtbauteile her. Der Steckverbinder, der verschwindet nachher irgendwo im Automobil oder in der Werkzeugmaschine oder irgendwo. Aber die Oberflächen sind natürlich Thema. Wir müssen auch sehr, sehr maßhaltig sein. Und in puncto Qualitätsansprüchen, da entscheidend oft die konturnahe Temperierung über überhaupt die Machbarkeit, überhaupt über die Herstellbarkeit. Und da kann die additive Fertigung mit konturnaher Temperierung eben ganz, ganz stark weiterhelfen. Wir arbeiten schon seit vielen, vielen Jahren, setzen wir Formeinsätze mit konturnahen Temperierkanälen ein. Es liegt halt eben in unserer Firmen-DNA, dass wir eben technologisch mit vorne mitspielen. Teile die sehr im konventionellen Spritzguss sehr viel Einfallstellen erzeugen würden, wo man wenn man die Wärme nicht homogen rausbekommt, und da sind wir eben mit konturnahen Temperierungen sehr viel besser unterwegs.
Think something new under the sun. You can't take back them things you already done. No. You blame things that you do on somebody else. No. But they all see is you need help. But still you try so hard to cover up your games. Just thinking, don't nobody see that all this time, it ain't nothing changed.
2022. For those who have missed the morning talk this morning, my name is Sven Krause, and together with my nice colleague Frank Jablonski, we will be happy to guide you through the program of this year's Formnext here at the AM4U stage. This stage, here we bundle different formats that all have one thing in common. We want to deliver you the most condensed and exciting insights possible into our industry, and at the same time leave room for exchanging ideas in a very relaxing surrounding. In addition, we have official events like the Pitchnext event with its award ceremony that will of course be held here at the AM4U stage. The whole setting is framed by various Formnext TV formats, including the morning talk you just have seen and after work, which are rather dedicated to the more generic topics of our industry, while on the other side we add expert insights and panels where we delve deeper into specific topics. The whole thing will be rounded off by original sound bites and impressions of our fair and the exhibition. Let me personally apologize in advance if I repeatedly start my presentation with the following sentence: we are now coming to another highlight here on the AM4U stage, because honestly, because in the end, this is exactly what it will be. And speaking of that, we will of course start the fair with a highlight, because our first speaker is none other than the president of Women in 3D Printing, Miss Christine Mulherin. Since its founding in 2014, Women in 3D Printing has evolved significantly. What started as a humble blog profiling women in AM has transformed into a global organization that not only highlights the role of women in our industry, but actively pushes for greater equality and diversity in the industry and provides immense support to its members. Today, Women in 3D Printing is made up of a community of over 23,000 members across the AM world, which means really the world, because we are talking about chapters in 36 countries at all over the 6 continents. Christine, who is joining me soon, who is CNO and founder of AMCube, is heading the organization for quite a year now, and I'm super happy to welcome her here on stage. Christine will bring us up to speed about the organization, as some things have changed. Looking forward to her speech. But before I let Christine start and ask her to come on stage, one very important remark for you at the screens. If you want to ask something, that belongs of course also to you here in the audience. If you want to ask something regarding the content presented, please do not hesitate in doing so. Ask your question that you can put in the comment section of our live streams, and I will get them here live on my monitor to ask them to the presenters. So keep your keyboard available. I'm looking forward to bringing your points here to the stage. No further ado, no further remarks from my side. Christine, it's a pleasure to have you on stage. Please come to the stage. Big applause for Christine Mulherin. The stage is yours. Thank you so much.
Thank you very much. Hello, everyone. So I'm thrilled to be here. Sven did a little bit of my presentation for me already, so you're going to hear a little bit of repetition. But I'm Krista Mulherin. I'm president of Women in 3D Printing. And I'm here to give just a really kind of brief overview on what Women in 3D Printing is. I think a lot of people are familiar with our happy hours. A lot of people are familiar with our panels, one of which you'll see here in just a few minutes. But the organization is so much more than that. So the original mission of Women in 3D Printing was to close the gender gap in additive manufacturing. But over the years, since we have grown to, this organization, as Sven mentioned, is over 23,000 members, we've realized that it's so much more than that. And really, what we want to really drive the organization forward with right now is to support an industry that's more representative of the world in which it operates. And what that means is, we really want, to reach out to the LGBTQ community. We have, various different kinds of diversity that really is much more than just women-based. So that's the direction we're going now. That's something we kind of decided to go with just at the beginning of this year, and you'll see a lot more around that coming up. So what is women 3D printing? So Women in 3D Printing was started 8 years ago by Nora Touré, who is here in the audience. And she started it as a blog. Since then, the first chapters were in Paris and San Francisco, and then it has grown from there. In 2019, when the chapters were really starting to grow, I joined as an ambassador for Portland, Oregon, which is where I'm from, and then became a member of the board and president just last year. So we looked at it as a strength in numbers. So we have now, and this has been a really, just since this summer really, we've grown, we've added another 25 chapters just since this summer. So there's 104 chapters in 36 countries. We have 137 chapter ambassadors, so a few of the chapters have more than one ambassador, which we're trying to encourage a little bit more now so that it's not quite as much work as it can be. We are an all-volunteer organization, so we all have day jobs. And so we have to work together, obviously, quite a bit. We're on 6 continents, obviously, except for Antarctica. And then just this summer, we've implemented some regional directors and area managers. And again, that was to kind of spread out the workload. So we now have regional directors for the US and Canada, Latin America, Middle East and Africa, Europe, and Asia, APAC. And then within those, each one of those have some area managers. Some of the new area managers that we've added that I think are really interesting is we have an area manager now in East Africa, where we have a chapter in Rwanda and Kenya. We have an area manager, obviously, in the Middle East, where we have chapters in Jordan and UAE, among others. So it truly is a global organization, and we're really, really excited about that part. Okay, so we'll go through all of these. What is women in 3D printing? I'm going to go through each of these in different slides, so I'm not going to repeat them here. So this is our chapter program. So this is kind of summarizing what I just said. So we have chapters across in all of these locations. Anything with an asterisk has more than one chapter. And as I said, I've already kind of covered where these different regions are. One of the new ones as well I missed is Peru. That one just came up about maybe a month ago, and that's pretty exciting as well. And then these are the regional directors. So as I mentioned, we have Ruba. She's one of our new regional directors. And Myra's been around for a couple of years. Alec's been around several years. Same with Haley Ann. And then Elena is our new regional manager for Europe. Okay, so getting outside of the panels and the happy hours that I think most people know us for is we have 2 big programs. We have the DEI program and the Next Gen program. So the DEI program is, there's a lot of aspects to it, and it's definitely something that's still growing right now. Right now we're in development on a toolkit, which is intended for executives, trade show managers, and as such. And it's, as you can see, it's about inclusive language and training. Things like, as well, we want to try to start to implement things like nursing rooms, potentially daycare, things that, would be more, I know of people who've actually brought their babies to Germany this week, and it would be nice to have some facilities that can support that. We also have the annual Diversity for Additive Manufacturing report. That's something that Sarah Gerke writes every year, and you can check out more information on that on our website. So the Next Gen program is also something that we're growing right now. Both these programs are in kind of a stage of growth. What we've been doing so far is we have quarterly panels, and a lot of these we refer to as the Meet the Stars program, and it's really to give the up-and-coming next generation an opportunity to speak, to get their name out there, and also get a little bit more exposure. We do have the annual mentorship program. I was a mentor last year, and just for the record, as with all women in 3D printing events and programs, it's open to everybody, not just women. And for that example, when I was a mentor, I had a young guy up in Canada that was my mentee. So it's open to everybody. So don't think you have to be a woman to do any parts of our events. We will be doing a new one this coming year with the application program opening or ending in July. We also have 2 career fairs. One career fair in the summer, and then one in the winter that is associated with our TYPE conference. At the TYPE conference, it's the 3rd day, and we do 2. We do 1 3-hour block geared towards EMEA, and then 1 3-hour block geared towards North America. So that one we have usually about 300 potential candidates attend, and I've personally as well had people reach out to me and say they actually did find a job through that career fair. So those are really exciting for us. So the TYPE is our annual conference, and this is, we're putting all of our energy to this right now. So TYPE is the first all-women speaking conference in the industry, but we definitely, again, we welcome all to attend. TYPE stands for technology, industry, people, and economics. And the idea behind that is most events you go to, most conferences you go to in the industry are really about technology and industry. But we really wanted to have a little bit more of a human-centered focus, and so that's where we integrated in the people and economics tracks. It is a global conference, which is kind of necessary with our reach, and so it's a virtual global conference, and we do it over about a period of about 36 hours. It's pretty exhausting, but we need to extend through all the different time zones. So we have major blocks for EMEA, APAC, and as well as North America, or the Americas, I should say. And then I mentioned the career fairs. So looking forward toward 2023, we have a new platform coming out called HiveBright. We're very excited about this, and it's really intended to kind of bring everybody together on a single platform. I think it's something similar to LinkedIn, but not really. It's much more than that. We're going to start, all of our events will be planned there, so you'll be able to go onto HiveBright and see where any event is in the world. So if you travel to a certain city for business, you can always go on there and see if anything's happening. It has a database to highlight speakers, female speakers. So women speakers who want to go get their name out there can submit their names to be in the database, and then also companies and events can go search that database to find speakers when they need speakers. And then also we do have a job board that's associated with that will be rolling out. All of this is going to be rolling out in the new year. So recently, we just implemented as well an advisory board, again, in the interest of making the mission more about making it about the world in which we operate. We wanted to get a little bit more of a better cross-section of what the industry looks like. And so we made a really big effort when we built this advisory board to make sure we touched every kind of corner of the industry that we could think of. Terry Wohlers, a lot of people know, he's an industry veteran. And then we have Maddie. She's more of a next-gen sort of person. She's in her early career. So we wanted to make sure we got across everything. Mina is in the HR. SJ is an engineer, as is Addie. And then obviously Melissa Orm, who is going to be on the panel here just in a few minutes. So everything we do is free of charge. So all of our happy hours, all of our events, TYPE as well, all of it is free of charge because we want to be able to reach the largest, broadest audience possible. So the only way we can do that is through our corporate members. So big thank you to our corporate members. I think I saw Worth over there. So thank you. And if you're interested in being a corporate member, obviously reach out to me. Same thing with being a sponsor of TYPE. So that's the brief summary. Hopefully you got to see a little bit more insight in terms of what we're doing. We're more than just a group of people who meet for drinks in the afternoon and throw in an occasional panel. But with that said, we do have a panel coming up here now. I'm really excited about this panel. We have a series of serious industry leaders talking about what to expect from additive manufacturing in 2023. I'll leave it to Sven. I think he's got introductions for everybody, but in the meantime, you can see who's up next. So that's it.
So, okay. We go on. Yeah, that's perfect. Great, thank you. So if you would like to join me on stage, then we can start with the just mentioned panel. So we skip the break. Great to have you here. Please have a seat. So in the next 40 minutes, ladies and gentlemen, I will have the opportunity, as Christine just mentioned, to talk to senior managers from the industry about the current agenda in their companies and, of course, about their personal outlook for the upcoming year in the AM industry in 2023. I welcome here on stage to this panel Christine Mulher, you just have seen. Christine, good to have you here, founder and president of AMQ. Then we have Angeline Gros, 3D printing technology lead at Shell. Angeline, great to have you here. Then to my left, we have Melissa Orm, just mentioned in the presentation of Christine. Melissa, you are Vice President Additive Manufacturing at Boeing. Good to have you. And then we have Stefanie Brickwede. Good to have you as well. Head of Additive Manufacturing at Deutsche Bahn and as well Managing Director at Mobility Goes Additive. Stefanie, good to have you. And last but not least, Valera, good to see you again. President and CEO at Hydro. Good to have you. So, Christine, I mean, you just have been on stage, but let me ask you the first question, if you don't mind. Before we get to the individual companies and their current project, a question for you. As you are consultant with AMCube, and you are consult companies in their strategic positioning, etc. I mean, the upcoming challenges are quite heavy, in my opinion. What are you currently recommending to your customers regarding the things that are in front of us?
I mean, I think it boils down to something really simple, and it's specificity. I think we talk about it a lot in the industry. You know, there's the 7 different types of additive manufacturing, and within those, there's a lot of subcategories. And I think, you know, the key is to be focusing on where each one of those has a very specific application. And I see with the startups that I work with, very often I'll ask them, okay, well, who's your target audience, or what's your focus? And they say, everybody. I'm like, well, that's not going to work. So it's really about narrowing things down and finding what your specific niche is. It's something very specific to the additive industry. So I think people are a little caught off guard at first, thinking that you can apply these technologies to everything, but that's not the case. They're very specific, application specific, and I think that's really the key.
Very good. So focus, focus, focus. This is basically the message. Angeline, at the last Formnext, I remember very well, we had a very exciting discussion on the use of 3D printing in the gas and oil sector. But today with you, we are lucky to have somebody who can report live from the field, firsthand, how additive manufacturing is being used. So what are current project and probably application that are you using at Shell, and what is the importance of AM perceived in your company?
I would say at the moment we are quite excited to actually be working to scale up additive manufacturing in the form of digital inventory for spare part, shifting the mindset of the oil and gas, traditionally, buying just in case to stock up the warehouse, towards the on-demand, just-in-time manufacturing. And now actually knowing that there's traction to do this at an industry-wide level collaboration. So that would be the foremost. And then secondly, I would say a lot of the effort is looking into growing new application areas, which supports our ambition in the energy transition with hydrogen, with carbon capture concepts. These requires new solutions, so we are partnering with companies to develop new solutions together.
Sounds very good, but we definitely come later back to the point how it's perceived. Stefanie, Deutsche Bahn is launching a major modernization campaign, which is highly appreciated, and is investing heavily in, sorry for that, I was traveling yesterday, but I was quite happy, and is investing heavily in new trains and the rail network. Is additive manufacturing already been used in this modernization phase, or do you rather focus with your project on other areas at Deutsche Bahn?
So right from the beginning, we focused on printing spare parts, and our first step was to print spare parts we couldn't get our hands on anymore, so in the obsolescence field. Then we moved it forward to print tools, jigs, and fixtures. Usually you do this the other way around. So. And now we are going the next step, and that is bringing additive manufacturing in the procurement of new trains. And that is really interesting because now we're designing the tenders for the next high-speed train generation, which will hopefully come into operation 2031. So we still have a way to go. But there, for the first time, additive manufacturing will play a major role in designing parts and also going into a digital warehouse logic.
That's fantastic. Alex mentioned it this morning, mentioning this like approach from Deutsche Bahn, and I'm super happy because this is kind of pushing market-wise our industry the right way. I mean, so you get well positioned at Deutsche Bahn. We come back later to that. Melissa, at Boeing, I was able to see one of your presentations already, and I'm looking forward to the Deep Thought event where you will have an expert insight. So you have already had an impressive journey with additive manufacturing at Boeing. What is your current focus, and how do you see the near future of additive in the aerospace sector?
Well, okay, at Boeing, we use additive in any way that we could add value to the company, and that could be with tooling and fixtures and jigs and research prototypes and wind tunnel mock-ups, but also with metal flight-worthy hardware, and that's difficult, because it has a really arduous certification process because of FAA, EASA. So where we're going, I mean, we're really looking at using additive manufacturing in ways that can differentiate the end product, the satellite, the helicopter, the airplane, instead of optimizing a part. We're looking to use additive manufacturing to change the architecture in ways that only additive can. And two more things we're focused on is sustainability. And that is to quantify the sustainability trades. So for additive, I see there's like two separate ways in which we have sustainability benefits. And one is in the actual operations and printing, and there's certain trades for certain situations, but not always. And then in the actual design, where we can create things lighter weight, streamlined, where we can really make our airplane use less fuel, for example. So we're looking at that. And the third thing is really in the spare parts, and what's very important to me is creating a framework for certification rapidly for spare parts to make sure that they're high quality. We don't just slap a part together. We make sure we know what the requirements are, we satisfy the requirements, we certify them, and we're able to deliver them quickly.
Very good, thank you so much. Valeria, how did you go from a family business to being part of a desktop metal group, moving from conventional hydraulics to additive manufacturing? Because this is quite rare. Can you tell us what doors it has opened for you?
Yes, thank you, Sven. This is my reply.
Okay.
This is small, it's a valve made with binder jetting, so a 3D printed valve. And I can say this is the reply, because now we are able to design parts with a lot of benefits, from the lightweight to the compactness to the integration of multiple functions into one, but in a mass production. So not only prototypes or small volume, but also mass production. So just let me give you some back information, because the company Hydro was founded by my father 40 years ago. And this year we celebrated our anniversary in the conventional manufacturing of hydraulics components. So a very standard family-owned business. But a few years ago, we discovered additive manufacturing. At the beginning, we used this technology to make tools for the conventional manufacturing. But more and more we understood the potentiality of additive. We were completely disrupted, and we start to design parts, so final product for additive manufacturing. So we introduced metal 3D printing. We were quite crazy at the time, because we were a small company and the investment was quite huge. But myself, my colleague, all the people in the company were able to see the big benefits, because we were not only making new parts, but also changing completely the supply chain and the traditional way of doing business. So we are now able, with especially new technology like binder jetting, and we took this technology from Desktop Metal Group. We joined the Desktop Metal Group last year, and now we are really able to think about mass production, because valve and hydraulics components are made in, hundreds of thousands parts per year. So not only few parts, maybe like other sector. But now we can see the reality in the technology and the big benefits that we have every day in our business.
Great.
Yeah. For sure.
That's what I expected, that the first negotiation would start right away. So talking about reality, Stefanie, we talked this morning already about regulations and safety, and in your case, you're looking very much on spare parts that probably might not exist any longer for the existing trains. In the future, you may secure that by implementing that the supplier has to deliver a lifetime basis. So what is actually already used? I'm always keen on hearing what kind of spare parts are there already, some printed for the Deutsche Bahn that are in use in our trains?
Yeah, in fact, a lot. Yeah. So we started with a hook hanger, and meanwhile we've done more than 80,000 parts in more than 500.
Sorry.
All good, all good. No problem.
Sorry,
Just water.
It's good that you're so impressed by that. So we've printed more than 80,000 parts in 500 different use cases and using also quite a lot of different technologies. And just recently, we also explored concrete printing for a station bench. So we've done really a lot. This ranges from very small plastic polymer parts until big metal parts belonging to the braking system. And those parts, of course, have to undergo a very high level of certification. And that is what we have to prove from part to part. And within the network, MGA, we try to overcome this logic and to establish standards so that we can scale up much faster in the whole industry. And therefore, 7 European railway companies are working together with the suppliers and industry. So this is just one example.
So you're kind of setting up standards up front in order to speed up the regulation process afterwards. Christine, is that sometimes an issue that if you are consulting new companies, especially looking at the coming years with energy crisis, etc., and they have to have really a marathon energy in order to overcome regulation topics? Is that a topic in your consultation?
Not as much. I think with the companies I'm working with, is the one thing I always talk to them about is looking at the low-hanging fruit. Things that are going to not be as highly regulated. There's a lot of applications in the AM space that don't require, jigs and fixtures obviously being the obvious ones, but even end-use products, things for robotics and things for that. Different applications don't require quite the stringent regulations that you'd see in aerospace and transportation.
Very good. Angeline, I remember last year we were discussing things like you are on an oil platform and then you can print your spare part on the platform. Is that something already in place, or?
We are exploring some aspects of this. Of course, that would be mainly then still in the non-critical application area. I think for oil and gas, the spare parts that we keep are for critical operations. That's the reason and the main drive. And the reason in the past to stop them was the long delivery lead time associated to the manufacturing of these spare parts. But I think with additive, there is a possibility, and we're already seeing the shift in movements in some of our assets moving towards actually taking bold decision that with overhaul of pumps and other equipments, not to keep the spare part, but rather work proactively with partners that allows the component to be delivered on time. And I see also proactively, we know in order to increase the scope and diversity of spare parts that we need for application in the oil and gas, we need to take on the challenges with finding solutions in AM for items that can perform in high pressure, high temperature, cryogenic applications, and even sour service. What I see very encouraging is that in the recent conferences that I have been attending, peers in our industry, but also academia is coming forward with solutions. And I do see that this is something that will really accelerate the adoption. Once we know that the quality is established to produce the part repeatedly and reliably for the oil and gas sector.
Very good. One last question to Melissa before we enter a short advertising break, by the way, that's coming in. I mean, when I thought about AM and especially what Angeline mentioned, like spare parts printing on the spot where they are needed, I mean, aerospace would highly appreciate that, I imagine, because airplanes would run faster again. So if you have a broken airplane, I don't know, in Bangkok, Thailand, and you can print spare parts there, is there a move towards this, or would you say due to the current status of AM, like missing applications, this is not?
No, there is a move toward that, and it's not just commercial airplanes, but it would be fighter airplanes. That's where it's most important to get those airplanes that are on the ground back in the air. And certain parts are easy, right? Certain parts that are non-critical, there might be a cap of a cover that's broken or something. But for the critical parts, this is where we really need to create that framework for certification. And so we're working on that with Boeing, where we have, we're developing a method where we can do the engineering and send a build file remotely that's, and encrypted, and so it's blockchain secure, not alterable in transit. And the idea, however, we couldn't just send it to any printer. It would have to be a pre-qualified printer to make sure that the qualified process machine material is used. But this is something that we're definitely looking to, and we call this our secure print solution.
Would be our bright future. So we are doing a 3.5 advertising break. We keep on going talking, and we will see you in 3.5 minutes. Thank you so much.
Dahin zu kommen, dass wir solche großen Werkzeugsegmente mit Kantenlängen 390 mm drucken können, prozesssicher über mehrere Tage auf der Maschine, mussten wir zum einen die richtigen Werkstoffe aussuchen, zum anderen aber auch Prozessparameter für die Maschine entwickeln. Dann haben wir eine Sache nicht angesprochen, natürlich diese gesamte Bearbeitungskette, die danach folgt, also die Wärmebehandlung abzustimmen. Ich muss eine Wärmebehandlung durchführen. Das war damals, als wir angefangen haben, noch ein ganz unbeschriebenes Blatt. Mittlerweile gibt es schon öffentlich zugänglich auch die ein oder andere Quelle, wie es auch gehen könnte. Und für uns war das aber eine Herausforderung damals. Also wir haben 2005, vor mittlerweile 7 Jahren, damit ganz explizit bei Audi angefangen. Seit 2010 ja auch mit dem InnoCut-Projekt, mit dem Fraunhofer IWU schon an dem Thema gearbeitet. Und das ist eigentlich jetzt so die Essenz, dass wir sagen, wir haben diese Entwicklung so vorangetrieben, dass wir zum einen kostenseitig, aber auch in reproduzierbarer Qualität fertigen können, unsere Einsätze, dass uns das dann der Serienbetreiber, der Serienwerkzeugbetreiber dann auch abnimmt.
Vom Produkt her geht es darum, ja hochwertige Oberflächen zu haben, beispielsweise Glanzoberflächen mit einer sehr homogenen Ausstrahlung, also einem homogenen Brechungsindex. Und das heißt, für das Werkzeug, das dem die Form gibt, am Ende auch eine optimale Temperierung am Ende beispielsweise im Spritzguss, um dann auch diese möglichst gute Oberflächenabbildung ohne, sag ich mal, Unterschiede im Glanz abzubilden zu können. Im Werkzeug dann wirklich, wie kann ich Sachen abbilden, die ich heute noch nicht abbilden kann mit konventionellen Verfahren. Also beispielsweise, wie kann ich eine Temperierung, also eine optimale konturnahe Temperierung abbilden, indem ich beispielsweise einen Kühlkanal-Layout verwirklichen kann, das ich gar nicht bohren könnte. Also ich kann ja nicht um die Ecke bohren, ne? Aber manchmal wäre es gut zu sagen, ich könnte um die Ecke bohren, ich habe einen Kanal um die Ecke, um dann genau diese Stelle optimal zu temperieren.
To create the perfect dance step, I must invest both creativity and passion. But beyond that, what counts is my determination for absolute precision. And this is the resolve I bring to the AM community in order to rethink and change vehicle concepts.
Welcome, critics.
So, ladies and gentlemen, welcome back to our panel discussion here with senior managers from the industry, and we are talking about the outlook of 2023 and current projects in AM industry. Angeline, you mentioned academia, new trends that are coming up. Yeah, very interesting things. What have you seen so far? And one question additionally, are you cooperating with academia? Because this is sometimes the challenge they have to find industry partners. Is there already a cooperation in place?
Yes, well, we do believe in partnership, and I think we are stronger together in actually pulling the experience and knowledge together. So a lot of the work that we do are in partnership with companies that work in the AM spectrum. In the universities, we are also having some small collaborations. This is happening in Singapore, in India, and we join a lot of what you call industry forum, where they are using AM applications. Some of these are actually even extending beyond the oil and gas application group. So, because we believe that the knowledge in understanding how material properties work or specific demanding condition, operating condition, do exist also in other industries. So there's a lot of exchange that happens in the background to do to gain knowledge in this area, but also to actively publish them where possible.
Very good. Speaking of networking, I mean, with all the activities Women in 3D Printing is doing for the network, it's quite fostering, right? Is there a business coming out of Women in 3D Printing as well, or corporations, where you say we work together because we met in a cluster, or?
Yeah, I think definitely. I think there's a huge amount of that. And again, that's another reason why we want to really encourage everybody to attend our events, not just women, because it is about networking and it is about connecting with people. And it's about giving to people different opportunities. And I think a lot of our events, you do see a lot of new business ideas that come out of them. I mean, I think some of us here have even worked together as a result of that sort of thing.
Awesome, very good. Melissa, I need to ask that question, and don't get me wrong. What is the perception of additive manufacturing inside your organization? I mean, you're a very traditional company. I mean, you're one of the two biggest aerospace companies in the world. How do they perceive your work? Are they smiling at you, or are you... Don't get me wrong. I mean, what is the current perception in your company?
Some people are smiling at me. Let's put it that way. No, at Boeing, additive manufacturing is viewed as a strategic priority. So I'm quite lucky in that sense that I have support from the highest management at Boeing. And we've already demonstrated where we have cut lead time by a factor of 10 on certain projects. It's a technology that can solve problems in architecture. We've made parts more durable. We know when there's traditional brazed components and they fail, the additive monolithic part will be more durable. Cost, and some really innovative parts. So we're really looking at additive to the future to create those innovative designs that will give Boeing that competitive advantage.
Very good, very good. Talking about future, Stephanie, what do you expect in 23 regarding AM? How is it changing? What are the, let's say, the challenges and the trends you are expecting for next year in your field?
So in our field, I think a lot of more suppliers, not the big system house, not the big OEMs, they already know what additive manufacturing means. But the smaller ones, they have to understand what that means. And I always tell them, either you do that or we do it. Yeah? But you don't want us to do it. So start. And I really hope also by this initiative I just described that we are bringing it into the procurement process of new trains, because we are not a train constructing company, so this is a big difference to Boeing. We are just an operator. But this will hopefully lead to a mental shift. And additive manufacturing is not a technology project, usually it's a change management one. And also from the experience of the network, it does not matter whether it is a train company or an energy provider or a hospital, it's always the same. You have to overcome some thoughts, you have to tell people what they can do with that. But at that point, they understand that they can really change a lot. And I really hope if I take a look at Formnext this year, there are more technologies coming up, printing rubber or doing serious production. Machines are getting faster. Hopefully the quality level will increase. Yeah? All those machine producers know what I'm talking about, but this is still one of the hurdles. And yeah, so everyone's really working on that. And I really think that we can make another step. And what definitely helps, and this might sound a bit strange, what helps is the war. So we really had to face again interrupted supply chains from one day to the other. And this will not stop. This will just be on different fields. It will not be a pandemic, it will not be a war, it might be something different. But I think most company leaders now understood that additive manufacturing might also play a role in that and help to overcome some problems concerned by this point.
But that's very good that you're mentioning the future and the crisis as an, let's say, enabler and fostering partner in a very negative way, but in this case positive for the industry and the development speed. Valeria, if you're looking at the future now, high energy prices, one crisis after another, and you are a producer, here are some customers, what are you expecting for the next year and how are you facing it in your company?
Yes, for sure it's challenging, the future. And for additive manufacturing, I hope I will see more trust from the industry because as the other, we are working in a very conventional manufacturing, so hydraulics is very conservative. But due to the different challenges that we have, people are more open. And we are always working to open the mind of the people, to share know-how, to share experience, because this is probably the key, to help people to understand what are the benefits of using additive manufacturing, because the change is always hard, especially for people, technical people or people from the operation. But if they can understand the benefits, or sometimes they are forced to change something because like the supply chain is not working in the fine way. At that time, we are ready to support the people to introduce additive manufacturing on different level, from the design, that is probably the first step, just to start from the designers and change the way how they are designing the parts, to the production and post-processing and qualification. Because as the lady knows, the qualification of parts is essential to guarantee that the part will be installed on the fields and will work fine for maybe 20 years in the future.
Very good, very good. Yeah, challenging time, Angeline. You are undergoing, let's call it a major transformation. Let's put it that way, Achal. I mean, you are screwing at every corner in order to change the whole company because you need to, due to the future. What is then your role as additive manufacturing? Do you have an impact on this major transformation? Do they consider you as an important part of this transformation?
I think AM certainly is one of the technologies that will help support Shell in the Powering Progress journey, and particularly in the energy transition. I want to tap on to the earlier message that AM transformation is also a human transformation. I often say that my role in Shell, apart from the technical as well as a stewardship on strategy, is very much about being an ambassador for AM, both internally within Shell, but also externally, because we need to get the knowledge out there, and the transformation, if we want to make an impact, needs to be an impact within the industry collectively. So AM is being used. Of course, we are actively shifting our mindset to move towards digital inventory, which will reduce the physical material consumption. We are bringing in the concept of also finding ways to take scrap from our existing facility and using that scrap to regenerate into powder that can be used for spare part to reduce the burden of having to mine virgin material. I think that's important. Apart from that, I see for us taking a leap also to utilize the development now in other technology. I think additive manufacturing has a lot of connection to growing emerging technologies in the areas of blockchain, digital twin. I see the data that we create at the moment can be harvested and used in a very effective manner to particularly gain confidence and hopefully reduce the amount of inspection and qualification needed to actually find a repeatable and a structured way to reduce the burden of parts qualification and quality. I'm particularly excited next year also in the fact that we would be working in collaboration with our peers in the industry as well as other companies to look actively into repair. Because repair is also for us a way to extend equipment and asset lifetime without having to put in excessive investment to buy new material And I think it will bring also a strong sustainability angle in being able to do so. And we are looking into the robotics combination with AM to do ability, to have the ability to do even repair in subsea conditions. So very exciting development that we're looking forward.
So we're still talking about additive manufacturing
Yes.
parts. They're going to be repaired. That is
Yes.
really quite an important topic. I mean, with Stephanie, Angelina, Melissa, we have big customers here, and you are driving the topic. Melissa, from time to time, you have the feeling, as you are one of the biggest customers of new suppliers, new innovation, etc., that it's too slow, and you want to push it, or are you pushing it?
In terms of the technologies,
Yeah.
no, I mean, there's always, I mean, I don't think that we need to have new, I'm not waiting for the new innovations in terms of more lasers or bigger or, so forth. What I'm looking for is, and they're getting better, machine manufacturers to make sure that the parts that I get out of their machines or to machines are repeatably, reliably the same, right? On a micro level, micro scale. Right, and so when I say I want to see it industrialized, it doesn't mean that we take 3 random machines and put a conveyor belt. That's not industrialization. I would really want those 3 machines to have the same bill of materials and to make sure that I get the same performance out of them. So that's what I'm looking for, and it's not necessarily other things I'm looking for are not necessarily a technology play, but really at Boeing we're working to connect our factory, right? So we already have the digital thread 50% connected, 54% we measure. This includes when we stream our files to suppliers. And we're really working on archiving this data, putting it in a standardized format, so then we can then use our machine learning algorithms, our artificial intelligence, our data-driven models to feed back, into that end-to-end value stream. So really, it's a digital play as well as a quality play is what I'm looking for in terms, and then with my own engineers, our own engineers at Boeing, to really create those innovative designs where they overcome that hesitation due to fear of risk.
Yeah.
Right? And so
understandable, by the way.
Right. And I 100% agree. So all of us here have to do our homework to prove to them that we understand how to mitigate that risk, that we understand additive from a basic science point of view, and that we know that what we're getting out is repeatable, reliable. We need help with our machine vendors here as well. So that they can design for additive in really innovative ways without having that plan B, well, I'll just machine it if I'm not comfortable, right? Because if you have that plan B, you haven't optimized for additive, right?
I mean, this is the main challenge for the 3 of you. Christine, we have 3 really large entities here, companies here on stage. We have Hydro, very innovative. You have a broad view over the whole industry, and with women in 3D printing, even more. Would you say, what are the main drivers? Are it rather the larger companies by their need or by their demand, or are it rather the startups with their new concepts, or who is the main driver in our industry? What would you say?
Who's the main driver? Oh, I think I want to kind of follow on what Valeria said earlier about the collaboration, and that led me to think about the real competition, like companies within the AM space. I don't think of any of us as really competitors, because we all have to work together to build this industry. Our real competition is that lack of knowledge and getting those people over that fear factor. Getting those people to think differently than injection molding, think differently from MIM. And so one example is I'm working with another consultant industry, David Tucker, to bring to the United States next year a series of workshops. And what we want to do is we want to help kind of educate those people. So you look at any big company out there, you always have right now, you have people, and they say, you have the CEO, and they say, we need to be an additive. And they say, you go figure it out. And they point to this guy, and he has to go figure out how to get them.
It's like a fancy topic.
Yeah, exactly. And so we're targeting that guy that the CEO says, you need to go bring this to our company. And what we want to do is a series of workshops, and we're going to do a traveling workshop series where it'll be one, the first one's going to be in Detroit, the next one's going to be, in Austin, something like that. And the whole idea is it's a hands-on workshop to think about how to implement AM into your company from a business case point of view, as well as from a design innovation point of view. And so if you have those people who are trying to bring AM into their industry, if they can really wrap their heads around those two things, I think that you have a higher likelihood of success of actually implementing it in a new company.
Thank you so much. We can do some sort of clarification right here on stage because we have the first question and it's for you, Angeline. So what parts or components can be produced using AM? I mean, this would be the first step to show the people what kind of applications do we
So
see.
one of the first use case we have in Shell was in pump impellers. And since then, I think back in 2019, at the end of 2019, we have already 50 different parts in operations in the company. They range from the first pump impellers, we've done many of these, to valve trims. In Shell, we printed a full valve, although we did not put that in service. We have also done items using wire arc additive manufacturing, such as a mechanical sealing clamp, as well as well plugs. So I would say the list is actually a lot more extensive, and I'm happy to provide information through the various conferences that I attend as well.
Very good. Before we come to the end of the session, is there any question from this audience, not in order to integrate you? If you have a question, please let me know. Probably have to shout in because I look to the ladies all the time. But if there's one, please feel free. So qualification, I've heard in your speech, Christine, you're doing a lot in women in 3D printing to do more qualification, to explain more about AM. So how did you, it was your father that brought you in, but how was your interest raised? Let me put it that way.
The qualification is for sure a good topic. Also, we discovered what is qualification using additive manufacturing, because in our conventional business of hydraulics, the level of qualification certification is different. Because thanks to additive manufacturing, now we are working in other sectors like oil and gas or aerospace. So the qualification is an issue. And at the beginning, when we started, there was also a lack of standards. So we were involved in different groups working to writing the guidelines and the standard.
Yeah.
I can say now there are the most of the sector have, especially oil and gas and aeronautics, they have some standard as reference. But it's an issue for a company, especially a small company, to have a high system of quality management and to reach the qualification. So we worked a lot, not only making, papers, documents, but also to changing the way, the procedure, the way of thinking of our employees, because it's a new mentality, and it's really necessary to change the approach. But after a long journey, now we are qualified from different as a supplier of different end users, and it's a good journey, but really, really interesting.
But still not over.
Not over.
Probably the last question to Christine quickly. If it comes to upcoming staff for companies in the AM sector, we all have a lack of qualified people in all industries. Doesn't matter what you're talking about, but especially if it comes to AM and the companies you consult, are you experiencing the same, and is it getting worse?
I mean, I think we're all expecting this skills gap, right, that was been talking about for several years. I think that's all starting to really come to a head right now. And I'm really happy to see there's a lot of organizations out there that are working on bridging that skills gap by implementing things in the US, at least, that you see already in the UK in terms of apprenticeship programs and just skilled tradesmen. And focusing more on the junior colleges and the apprenticeship programs to get those people to fill that skills gap. I think we've got a lot of people in university, and we've got a lot of great programs developing in the universities that are specifically targeted towards AM, but we're missing that more in terms of the hands-on manufacturing skills that I think we're all going to experience a lot more in the coming years, and I think that's where the focus really needs to be.
Great, thank you. I mean, the clock is telling us the truth. No more advertising break. Thank you so much. You exactly met my expectation in a positive and in a negative way, because I would love to go on hours and hours with you talking. Thank you so much. I wish you a lot of success here for the exhibition, a lot of good experience, good connection, good networking, and of course for your companies as well, a lot of success. It was a pleasure having you. We are handing over to some highlight clips, and then after that I will hand over to Frank, who will take over and come up with the next expert insight. Thank you so much here on stage.
Thank you.
Thank you.
Thank you.
Step into the light, I'm alive, I can see your love shining. You put it on the inside, so no matter where the darkness, you been shining like lightning. I surrender, you fight my fight. Darkness ain't ever gonna take my life. I'm so give you my praise, that's right. I'm so give you my praise, that's right. I'm so give you my praise, that's right.
Wir haben halt generell das Problem, dass wir ein bisschen unterscheiden müssen. Der Werkstoff, der gut für das Herstellungsverfahren ist, sprich für die additive Fertigung, der sich gut verarbeiten lässt, um Formwerkzeuge insbesondere herzustellen. Und die Anforderungen, die zum Beispiel der Einsatz dann an den Werkstoff stellt. Gerade Stähle, die einen relativ hohen Kohlenstoffanteil haben, können später mal hohe Festigkeiten, hohe Härten zeigen, aber lassen sich schlecht schweißen in der Regel und lassen sich dahin schlecht für den Prozess qualifizieren oder im Prozess verarbeiten. Von unserer Seite gehen wir anlagen- und prozesstechnisch ran hauptsächlich. Also das Thema Temperatur, Vorheizen der Maschine im Bereich 500 Grad dann mit hohen Vorheiztemperaturen zu arbeiten, hilft dem Problem entgegenzuwirken, eben Rissbildung aufgrund der hohen Abkühlraten, die wir im Prozess haben. Es sind andere Sachen wie Mikroligieren, sowas, das heißt minimale Werkstoffkorrekturen im Prozess oder vor dem Prozess möglich.
Wir haben auch ganz bewusst eine Auswahl getroffen und auch ganz bewusst eine Materialauswahl getroffen und auch die Maschine mit der Trumpf-Druckprint 5000, mit dem wir eben diesen hochwertigen, auch den Standard-Werkzeugstahl 1.2343 verdrucken oder drucken können, der auch in der konventionellen Welt sehr verbreitet und sehr akzeptiert wird. Wobei die Reise ganz klar auch dahin geht, die geht weg von diesen Standardwerkzeugstählen in der additiven Fertigung. Das finde ich wichtig zu bemerken und es ist auch richtig, das zu tun, weil die additive Fertigung, die muss nicht mit den konventionellen Stählen oder Werkstoffen konkurrieren. Hier ergeben sich auch in puncto Werkstoffen völlig neue Möglichkeiten.
Welcome to our expert insight short presentations. These expert insights have been prepared in cooperation with VDMA Working Group Additive Manufacturing. And our topic for today is machine connectivity and machine integration, a very important topic in all areas of the industry. And I'm very happy that I have two experts here on stage. Bas de Jong, he is COO of 3YourMind, and Mathieu Roche, he's Marketing and Technology Manager of AddUp. And we are starting right now into the presentation. The two of them brought us. And Bas, the stage is yours.
Thank you. Yeah, welcome everybody. First day of Formnext. Good you made it out here. Yeah, I will kick off the presentation. We all know this picture. It's been a while ago, but traditional supply chains are unstable. This is the example. Also, COVID that hit us is an example of that. And it's not working. Oh, there, yeah. So this traditional manufacturing, yeah, it's unstable, and that is why there's a rise of on-demand manufacturing. So what we are already seeing right now is that 80% of enterprises started adopting this on-demand manufacturing. It's not only additive manufacturing, it's also other technologies. And yeah, it's also part of digitization. The whole strategy of digitization is starting now. So more than 8% of the stock is digitized in the next 10 years. Imagine that. And the total market value, it's an astonishing 250 billion. That was already analyzed in 2021 and growing. So what we have done at 3YourMind, we've made on-demand manufacturing made easy. So we start at the beginning to find the best use cases for 3D printing. Before you can start, yeah, you need to find the use cases, and with that we have 90% time reduction in part screening. After that, it's the second step. You need to qualify the parts. Once you found them, you need to move them towards production. There's a qualification process. Also, what is very handy then is that you can connect your digital inventory that we've created of qualified parts to connect them to suppliers. And I will give some examples later on that you will reduce also a lot of time there in the connection. And of course, and that is what we are working on now with all of our customers, is to track production quality, which is a very important link here. It reduces errors and also include the missing information. Let's go. So, machine connectivity. Why are we talking about this? What we hear from our customers is that they can, yeah, produce faster and also ensure the quality. So imagine you have a platform where you have your digital inventory, you connect them to your own locations, to your own production capacity, and also to your suppliers. You can always see the fastest option to produce. So that is one very important element of that. And also you can produce decentralized where you need them. And what is very interesting, and that is also, I think, the vision that we have and the step beyond, is the better quality. So the connected machines, and AddUp will move on to that also later on. Yeah, they measure the process and document all the quality information. So you can get a lot of information how to meet the part requirements and also ensure end-to-end traceability, and feed that information back into the digital inventory to also improve your design process, your pre-processing, your post-processing. This is a customer quote, so it's about increasing efficiency. That's why we're all here in this industry, of course. This is a quote of Ford. Before that, they didn't have any software to help and no machine connectivity, and they did everything by hand. So yeah, you can imagine it's not really optimal. And now what they're doing, yeah, they integrate everything, scheduling, optimizing, they decrease the emails, and also this way they nearly doubled the production. So that's a really great step. And with customers like this, we are also working on creating all the integrations of all the data to feed it back and also improve the quality. Thank you.
Thank you. And now we go straight on with Mathieu.
Hello everyone, very excited to be here on stage today. So I'm Mathieu Roche from AddUp company. We are a French company specialized in AM metal machines and parts. So we have a dual identity. We're both producing machines. That's the way we started back in 2016 with first technology, which was PBF, and we have added a new technology in 2018, with a DED. While we were producing the first parts for our customer, we identified that we had the opportunity also to create parts for them. And now this is really also a big part of our business, being able to produce parts for every single customer which we have. In the end, our mission is to help the industrialization of the AEM all over the world. So as I said, we started in 2016 based on the experience of our two owners, Michelin and Fives. I guess everybody knows Michelin pretty well. They've been doing tires since decades and even more. And back in 2008, they've been looking for another company, starting actually to do AM. And once they had a successful journey with AM, they've been looking for Fives. And Fives is also a French company who are producing a specific machine for industry. So they have created AddUp, and here we are today. So what are we doing? Actually, many things, of course, because we're also producing parts. We have specific staff who are working on the design, from conception to adaptation for the AEM markets. We are running all over the world above 40 machines in both PBF and DED, running above 20 different materials from Inconel, aluminium, maraging, and many others. And we are split over 4 different production facilities in the world. Of course, since we are doing parts, we also need to address the post-processing. So we have a full set of different treatments, like heat treatment, surface finish, and so on. And we are fully qualified, especially in the medical and aerospace domains. So what is the relation with connectivity? Of course, when you start to produce parts in an industrial scale, you need to give evidence and give feedback to your users. Until June 2020, honestly, we were pretty blind about what the machine were doing. We had to wait until the end of the job to actually check. So in June 2020, we started to integrate many different protocols, including, of course, OPC UA. And since that time, every single color which you can see here, there are specific jobs. And inside all of these specific jobs, there are thousands of different layers. So, of course, we are creating many, many data with all of this, which we are using to improve also the performance of the machine. And that's where the connectivity has been pretty important for us. So it's based on industrial protocols like OPC UA. We provide many different production reports also to our customers. And of course, that's compatible with PBF and DED, depending on the technology. So the way we're using this one right now, that's because also we are working a lot on the monitoring solution. So I guess every one of you have heard about the quality assurance topic. That's pretty critical for many industries, including medical and space. And we are working on some kind of synergy of this monitoring solution. I will not detail right now, but you can come to the booth to have a look. And one of the major clients for this connectivity is called AddUp Dashboards. That's the last one, which you can see here, which is a real-time tracking and supervision solution based on OPC UA protocols. And out of these dashboards, the customers can see everything which is happening on the machine, from the name of the guy who was in front of the machine, to the specific name of the job which you've sent, up to every single key process parameters like oxygen, humidity, torques, and so on. And all of this data, we are collecting all of this and gathering this one in the specific reports when we deliver the machine to the customers. So they know exactly how the machine is performing. So yeah, connectivity is really at every single stage of what we are doing by AddUp. And I think that's it for me.
That was it?
Yeah.
Okay, perfect. Yes, thank you very much. And a friendly applause for you, Monsieur. Yeah, before we start talking about a bit more about connectivity, Bas, what would be the biggest challenge that we need to solve in the market to scale additive manufacturing from your perspective?
Yeah, so what we see now, we are all very enthusiastic. I see everyone here, myself too, about the industry. And what we see at customers, they're also enthusiastic, but they need to find the applications to scale. So what we hear from customers, and I think a lot of you can relate to this, is that yeah, they need to find the right applications. They've done some prototyping, some tooling, also found some end parts, but really go into mass customization, the bigger series, that is what is needed, and that is 3Yourmind has this software to identify and qualify the parts, where I started the presentation with. So we think that is the first step. Then you have the big number of parts, and of course, then also you need to manage these parts with machine connectivity and other software solutions.
But when you compare, you're talking about we need to got serialization, you've got many parts,
Yes.
but everybody's talking about individualization. So you want to have the part for every exact person, one part. So how does it fit together?
Yeah, so that's a big trend. That is why I think why 3D printing, additive manufacturing, and also the more customized production technologies, not only 3D printing, but more, will grow because there's a big trend, of course, of mass customization, where you don't need large series, right? The large parts in a large series, but you need customized parts, so smaller series. And then the business case for 3D printing and other on-demand production technologies, becomes viable.
So do you see in your business area a lot of demand for those personalized products?
Yeah, more and more. So we see that in all the verticals we are working now.
Tell us about some examples from which industry sectors do these questions come?
Yeah, so what we see now, for example, we work with energy companies that have smaller series because they don't have that many power plants and windmills and all that stuff. So we see there they need a lot of customized work because they have tweaked also their production plans for their own specific needs in cases. So we see it there. And also in other industries like transportation, there's more and more customization.
Mas, what is your perspective? Do you have these questions as well from your customers, and from which industry sectors?
Yeah, we do. We are especially focused on three big domains, which are medical, space, and tooling. And actually, the customization also comes at the very early stage of these discussions. But one would start in serial production. What is very important for them is to make sure that every single part which will be produced afterwards will be the same as the original one. And this is very, very important. So that's why we are building all of these monitoring solutions and reports and so on. That's because they want to make sure that everything is under control.
Okay. How important is regulations in your daily life? When you mentioned railway applications,
Yes.
I think it's a very highly regulated area because it's all about safety for passengers.
Yeah.
What is it, a daily topic, or is it seldom?
That's a pretty hot topic, actually. That's almost a no-go topic for them. If we are not compliant with all of this, we can even produce a part for them. So, like for the medical, the retention of the information is pretty critical. It can go up to something like 80 years. So, I mean, you have to make sure that the data which you have, they will be safe, they will be available, they will be readable in the next coming years. And I mean, you wouldn't take a flight if you were not perfectly comfortable with the part which was produced. So, yeah, that's really daily business.
What is your experience?
Yeah, so our experience is also that a lot of customers, they always want to start with something very difficult. You know, we're a group of engineers, you put them together, and usually they want to solve complex problems. So,
but we want this open thinking, this open-minded.
Yes, exactly. Yeah, and what we usually do is then say, like, yes, these parts are very interesting to start working on, so it needs a long qualification process. On the other hand, there are also a lot of parts that are already possible to 3D print or use another technology. And it doesn't take that much time to qualify them. So we focus first on the low-hanging fruit parts and produce those. Show the business case, everyone gets excited. And in parallel, we work on the qualification of the more difficult parts. That will come like in a year or sometimes even 2 years. But it is very important what you're saying for the railway industry, for example, that this the flame retardancy standards are met and other standards. But I think the main message here is that in any company we've worked with, there are always low-hanging fruit parts that you can start with right away. So like the first 3 months, you will have immediate result, which is very important to grow the industry. Yeah.
Okay, let's try the hook to the protocols and the connectivity we wanted to talk about. I think when we're talking about regulation and documentation, that may be a very good example that we need this connectivity, because when you're talking about all the lot of data that has to be stored and has to be held for tens of years, how important is to have a connectivity right away from the machine to the data storage?
That's because actually you want also to take decision in real time. So you need to have this machine connected just to either take decision to stop a production or to have confidence in what you are building. But the connectivity is also very important, because what we are doing inside the build chamber, that's only a small portion of the global chain. And there are many jobs and works to be done before, but also after. When I was talking about post-processing, that's a pretty critical stage also, where you can, if you do a heat treatment which is not appropriate, you can just destroy the part. So right now we feel like the connectivity is really focused on the printing. There is, like Bas said earlier, some connectivity also with all of the MES area. But talking about the post-processing, right now the connectivity is a little bit in between. So that's why we are very pushing also, we are pushing very much also the UMATI and so on, to try to aggregate additional data from the rest of the chain also of AM, to make it perfectly integrated for industrials.
What are the challenges to collect these data? You must begin with the sensors, right?
Yeah, so in the machine there are plenty of sensors. So there can be sensors for key process parameters like the oxygen, humidity, torques, and all of what I said earlier. But all of this is pretty easy to manage. It's pretty light. The machine which we are running, I said earlier, like 40 machines, they have generated since 2020 around several hundred gigabytes. So, I mean, that's a daily business. But then when we are talking about advanced monitoring solution, like a melt pool analysis or the recoating quality and so on, then the scale is completely different. So that's something which we are working on a lot also. For instance, with a melt pool, we can create terabytes of data per production, and you cannot store all of this for 80 years. So, yeah.
So, Bas, how do you start with connectivity? What is the first impression? Is it documentation in your company as well, or other aspects for you to start with connectivity?
Yeah, what we see now is the first reason why companies start. It's because it's just more efficient. The processes become more efficient. They save immediate time and money. They don't have these manual emails anymore, like the customer example I gave. So that's the start. So there's immediate result, which is good. Our vision is that it will really help, and that is also what we are building on now, to improve the quality of the parts, first of all, and get the feedback loop from the whole process, not only printing, but also post-processing, pre-processing, back into the digital inventory. Then improve the whole supply chain like that.
Okay. And you can already control your process while it's processing with collecting data or the sensor information.
Yeah, there are some software solutions now out there in testing phase that can do it.
Okay.
But that's still difficult to do it during the process. But even if you can do it, learn from this and implement it for all the parts that are coming next, it's already a huge value.
Okay. And the topic of regulation, that's not so important in your company when talking about connectivity, right? Or is it the storage of data and so on?
Yeah,
is that an aspect as well?
It is very important, of course, because it's IP-related products. So companies want to keep this IP protected. So, for example, how we meet this, we of course have a very safe cloud environments that are under all the regulations. But also some companies, especially the bigger ones in the supply chain of the defense, for example, they need to have on-premise so that the software is installed and not in the cloud. So we also have a solution for that if it's needed for some parts to really be boxed in, then it's possible.
And to get this done, to get the challenges done and solved, do you need partners, or is it just doing all by your own in your company? Do you need the people in-house, or is it working together with maybe the one or the other exhibitor here, or I don't know, other companies?
Now, of course, the solution has to be based on a partnership. So we cannot develop everything by ourselves. So we are relying on the shelf solutions for both the connectivity, for both. We just announced a partnership with a company called Interspectral to visualize, because there is added value in all of this company, and working on the synergy altogether, it makes an efficient solution. In the beginning, when we started AddUp, we had this mindset to make it very open. So you can tweak every single parameters to improve the productivity, to improve the quality, to make downskin, whatever. But it has to go down also to the connectivity itself. It cannot be only an openness inside the machine. So of course, partnership is one of the key points. We were just talking with Bas back on stage that we will be also thinking about a partnership, which we can announce some way. But we also want to connect, and both companies are taking benefits from this partnership.
How important is it for you, this aspect?
It's a fruitful talk already, right? So we were talking about this, So we need partners to grow the ecosystem, to grow the pie together. We are already working with partners, the 3D printer OEMs like Stratasys, HP, Desktop Metal, because everyone needs, first of all, to find these applications, to grow the market. And then, of course, also to connect the printers with machine connectivity, feedback the data. So we are definitely going to start a project. We were just talking about this to make it happen. Yeah.
Maybe let's go through one example. I'm a bit curious. Everybody's talking about the digital twin, and that's a very important aspect of connectivity as well, I think. When you think about the digital twin of your produced product, is it something, it's a key aspect of your business, or is it something you would have to do with an external partner because it may be too complicated or something?
Yeah, there are many different digital twins. You can talk about the parts digital twin. So try to replicate in a digital way the physical behavior of the machine itself. So that's something. But there is also like a digital twin of the machine itself. And that's completely different. But like, for instance, for the digital twin of the machine, we have customers who are sending parts to us, and they want to have access to this digital twin version, to track the production, to know how it's going, to know if everything was made on time, and so on. So this openness relies 100% on the connectivity itself.
Okay. What's in your company with the digital twin? Is it the machine digital twin more important than the product digital twin, or is it equal important?
Now we see there that the application, right, the product, you need to create that, of course, the right information, but it needs to be connected to the capabilities of the machine. And also what we see now is that a machine changes. There are efficiency improvements in the firmware, or new machines coming out. There are new material options, and that there's a constant feedback loop that needs to be sent back in order to analyze again, like, this part is produced in a certain way. Does it make sense with all the new information that we have to still do that, or are there gains to be made?
Where's the hook to simulation? So if you have all these data and your customer with a product and the digital twin of the product should do a simulation of the product in his processes, in his car or in his flight.
Yes, that's also a part of it, the simulation. And also, that is more the real technical simulation. But also, I think it's important that companies start thinking about the whole supply chain and the whole product life cycle. So it might make sense to, for example, CNC or 3D print a model in the beginning of a life cycle. Then you ramp up and you start molding, and then it ramps down again. And then it makes sense to use another technology.
So that would be that the simulation is something the customers come to you and ask for it, or is it not so important right now?
Yeah, we see. So if you're talking about that simulation that I just, that's not really simulation, but it's more analysis in the product life cycle. They come to us. For the more technical simulation, there are other software players that are really specialized in that. So we build integrations with these kind of companies to.
But the simulation is also somehow connected, because like just like Bas was saying, we are doing many different simulations, like the one which will compute the distortion of the part which will occur during the production and so on. But you want to to have an understanding of how the machine was depending on the simulation which you did before. And because simulation is time consuming and it's crazy expensive, so you don't want to simulate every single part. So once you have produced these simulated parts, you want to make sure that every future production will remain within the same range in terms of parameters and anything else, just to prevent from simulating again and again and again. So,
yeah. Now that's also the quality assurance, right? We talked about. It's very important that the parameters need to be the same. And I know I used to work for a 3D printing company, Ultimaker, and then when we changed the firmware, it could result into changes in the production.
That's a nightmare.
Customers don't want that, so then it needs to be visible in the software that something changed. So.
And before you set up, you want to know how something could change.
How something could influence your end product. So,
yeah. But anyway, when the customers are getting back to the versioning and so on, when they will accept a part, it will be under specific conditions like the firmware version which was in it, the provider of the powder and so on. So all of this is locked, and you cannot change anything after, which is a little bit strange because if you want to improve the process, you have to change the firmware also in some way.
Yes.
So there is like a non-going out closed loop. But
yeah, this session is mentored by VDMA, the working group machine. What was it? The machine, additive machine. Just help me. What was the correct name? The center. I don't know. I forget about it. I'll bring it to you later. It's a VDMA from the VDMA working group.
Okay.
And there are some colleagues of you as well working on the topics. And you said you want to use OPC UA for connectivity standard. Is it because of the working group of VDMA, or is it because of other aspects? Asking your customers for this protocol, or why do you choose OPC UA as protocol?
Yeah. Want to go?
Yeah, so it depends on the customer mainly. So there are technical differences between all of these protocols, but basically they are just not collecting, but providing data to additional software. Then we have, at the end, we have a customer, and these customers, they have specific software environments already established, and we must stick to this one. So we cannot just say, okay, take MQTT because that's the way it is. So we have to be like, again, partnership, openness, mindset, but just to propose everything which is available so they can be comfortable with the integration of the machine.
It's the same with you?
Yeah, so we follow the customer needs, obviously, but I think the VDMA and also the partners have a very important job to help standardize, because imagine if you have to make all the integrations to, there are hundreds of different vendors with thousands of different machines, and if you need to make all different integrations, it takes a lot of work. So I think it's in all of our best interest to create standards and protocols to reduce that time and spend that time on something useful to create customer value. Yeah.
And there is a word that often will be read, the UMATI. What is that? Could you explain what UMATI is? It's in connection with VDW, I think.
Yeah, UMATI is it's like a community. So it's a community of machine suppliers and customers, and the idea is to connect all of them based on the OPC UA protocol to simplify the connection to the machine and the tracking of what is happening. So it's not a pure protocol, but that's very handy. There is actually a very nice application which everyone can have a look at on umati.app, something like this, where you can see every single machine connected. And what is very nice is that it can be pure PBF machines or pure post-processing, or just like one solution to rule them all. So that's
So is it a closed group, or can anybody take part in that group?
So I think it can be bidirectional. Right now it's providing data to the outside to track and to read what is happening.
Okay. And are you working with that UMATI standard as well?
Yes, we are also working on this. Yeah. And again, it's driven by customers. So if they tell us, okay, this is what we need, then we start working on that and integrating. Yeah.
But my understanding was that UMATI and OPC UA, the UMATI standard uses OPC UA, so that's not a difference, but it's coexistence.
Exactly.
Okay. Yeah. Okay. Perfect. When we talking about, or when we look a bit into the future and talking about digitalization, what would you think with connectivity, maybe with wireless connectivity, what is possible in the future? What is an upcoming trend? What do you see ahead?
So there are some connectivity which are already existing. We didn't talk so much about the maintenance, for instance, but you know it happens. The machine can fall down and we have to fix it. So there is a connectivity, which is actually a pretty critical one because it has to be ciphered. We are providing detailed information about the part. So we have this maintenance one, but for the future, we are thinking about opening the doors to our workshop so everyone can have a look at the production, the way it's going. Is everything about the software under control, the powder in the machine, just provide crystal clear vision about what is happening directly by the customer. And of course, by the provider. And of course, all of this has to be multi-OEM. So as Bas said earlier, ADAP doesn't want to create our own protocol. So just like EOS, Trump, and all of these companies, everyone is actually working together to give all of these tools to the end users.
What do you see coming ahead?
Yeah, so I see there's great potential now to find the quality information throughout the whole workflow. So not only from printing, but pre-processing, post-processing, and feed that back in this connected system to learn from this and improve. Also, we see that also now at customers already, where they've, for example, printed spare parts and redesigned it in a certain way. That information is looped back by the operators, and this really works well. And then we get information back from the maintenance teams that tell the product designers, we actually have to do far less maintenance, and the part can be in production for years instead of months. And then, yeah, that can help also to really rethink the design and the on-demand production for the other parts. So I think that's the biggest trend now, where we can also capture most of the value.
Okay. When I do have you, we have 2 minutes left. I would like to take a look into the international markets. Where do you see additive manufacturing going fast forward the most? And is it USA? Is it Europe? Is it China? Is it Asia? Mathieu, what is your perspective?
US is going very fast, of course, with a well-established company already focusing and building their projects around 3D prints, not only for the parts improvement itself, but because of what just Corona brings to us, so like lead time issues. And AM is not only perfect to make like nice topological parts and all of this, but also to answer to a crazy rocket launch program every single day. So US is pushing pretty much. In Europe, of course, Germany, with the industrial background, is also like one of the key countries for us. So that's also the two markets which we are focusing right now.
And that's in parallel with your most important markets. So US is your market first.
Yeah, of course.
Okay.
Especially in the US, especially with the medical. We sold the first machine to medical customer in the US. So we are focusing on this one.
Yeah, I can relate to what he's saying. Yeah. So also the US is the biggest market and also growing fastest. I think it's also the mentality that they just adopt new technology and go all in. So here in Europe, we need to step up and step up to keep up. I think here that's the invitation to all of you to visit our booth in 11.1 B58 to work together and do that. It's almost time, right? So I have to pitch it in.
Perfect.
So it's well for us.
What would be your next step when you're leaving the stage? Where would you go? And
I will do a demo of the monitoring solution which we have just launched. So yeah, if you have any question, I would be glad to demonstrate the solution to you. But yeah, just have a nice show.
Okay. Thank you very much to you both, and thank you very much. When I look to the audience, maybe a short applause for these guys. Perfect. Thank you very much, Bas de Jong and Mathieu Roche. I wish you great success at the fair and for the next upcoming days. After a short break here on stage, we will have the next highlight. starting the Discover3Dprinting seminar. And I think there are a lot of people coming here because the seminar is in two parts. The first part will be here on stage for all the visitors and all the participants outside at the screens, and for the guys here in the hall. Thank you very much. We see you later.
Thank you.
Vielen Dank.
Was very cool.
Dankeschön. Nice.
Virtual worlds offer me the freedom to rethink structures in a completely new way. Together with the Formnext AM community, I bring these construction designs to life every day.
Wir selbst als interner Jobshop für 3D-Druckbauteile haben uns als zweite Säule den Druck von konturnah gekühlten Formeinsätzen auf die Fahnen geschrieben. Wir haben seit Jahren entwickeln wir diese Prozesse dafür und wir setzen diese konturnahen Kühlkanäle dann ein, die Werkzeugeinsätze dann ein, wenn wir irgendwo einen Vorteil sehen. Also entweder wir sind qualitätsseitig wesentlich besser, wir können besser temperieren, wir haben vielleicht auch eine Zykluszeitverkürzung, aber vor allem ist es der Qualitätsaspekt, der uns da treibt. Und der Vorteil hier bei uns ist, wir haben die eigene Konstruktion für unsere Warmumformwerkzeuge im Haus. Wir haben unsere Warmumformfertigung in Münster, die wir beliefern mit solchen Teilen. Und das ist eigentlich der entscheidende Fall. Wir können auch die Werkzeuge selbst erstellen. Wir erstellen die Werkzeuge selbst, setzen diese Teile dann ein und erproben mittlerweile sehr erfolgreich Werkzeugsegmente, so dass wir in einen Standardprozess jetzt gekommen sind, wo wir solche kritischen Werkzeugbereiche sehr früh schon identifizieren und dann mit unseren Schnittstellenpartnern ins Gespräch gehen für 3D-Druckeinsätze.
Herzlich willkommen, meine sehr verehrten Damen und Herren, jetzt zu unserem Experts Insight Discover3Dprinting Seminar. Und Sie hören schon, ich spreche Deutsch, ich begrüße Sie auf Deutsch. Das heißt, heute werden wir eine deutsche Präsentation haben und ein deutsches Seminar. Morgen dann entsprechend ein englisches Seminar. So today we will have a German seminar, and if you want to follow the seminar in English, you have to wait until tomorrow. Then the same presentation or a similar presentation of the seminar will be held in English. Ja, noch ein kurzer Hinweis für die Damen und Herren hier im Saal. Das ist ein Silent-Seminar. Das heißt also, Sie können sich ein Headset hier vorne noch bei uns an der Bühne besorgen und eben dem Seminar dann auch noch im Nachgang, wenn dann eben auch die Präsentation hier vorne fertig ist, dann eben auch entsprechend diesem Seminar weiter folgen. Ja, also ich freue mich sehr, dass wir die Präsentation in Kooperation mit dem Aachen Center of Additive Manufacturing, ACAM, durchführen. Und wie gesagt, ist es eben der Startpunkt jetzt für unser Seminar, das jeden Tag hier auf der Messe gehalten wird. Und ich bin sehr froh, dass Lukas Bauch bei mir ist. Lukas Bauch ist heute unser Experte hier. Er ist Consultant and Independent Expert bei ACAM. Und er will uns heute sozusagen oder wird uns heute sozusagen in seiner Präsentation Antworten auf die wichtigsten Fragen von, sagen wir mal, Basic Information zum Additive Manufacturing geben. Lukas, die Bühne gehört dir.
Vielen Dank. Ja, herzlich willkommen zu Discover3Dprinting, unserem Seminar für den Einstieg in die additive Fertigung. Sie sind also bei uns genau richtig, wenn Sie vielleicht schon erste Erfahrungen gemacht haben in der Branche oder auch komplett neu sind. Dann möchten wir eben hier mit diesem Seminar einen schnellen und doch umfassenden Überblick über die ganze recht komplexe Branche geben. Auch wenn Sie schon erfahrener sind in der Branche, lohnt es sich mit Sicherheit, hier zu bleiben und man bekommt vielleicht noch andere Eindrücke aus anderen Gebieten. Bevor ich ins Thema einsteige, möchte ich noch kurz mich und das Aachen Center for Additive Manufacturing vorstellen. Mein Name ist Lukas Bauch, ich bin Berater am Aachen Center for Additive Manufacturing und forsche außerdem an der RWTH Aachen am Lehrstuhl für digitale additive Fertigung, im Bereich der Produktionsplanung für Laser Powder Bed Fusion. Das Aachen Center for Additive Manufacturing, wir sind eigentlich ein Netzwerk. Wir bringen die Bedürfnisse der Industrie zusammen mit der angewandten Forschung und dadurch, dass wir sehr, sehr viele Forscher für verschiedene Themengebiete, verschiedene Technologien, Design, Software hier an der RWTH Aachen haben, können wir sehr, sehr viele Themen bedienen und zusammen mit den Bedürfnissen der Industrie zusammenbringen, gemeinsam mit unserem Mitgliedsnetzwerk in der Industrie Projekte durchführen. Wir haben auch schon eine recht lange Geschichte in Aachen in der additiven Fertigung, die zurückgeht bis 1995. Also es ist schon sehr lange her, dass wir erste Erfahrungen gemacht haben mit einem ersten hybriden Maschinenwerkzeug. Dann ging es weiter hier mit der Einreichung des Basispatents für selektives Laserschmelzen. Das ist mittlerweile die industriell am weit verbreitesten AM-Metalltechnologie. Dann geht es weiter über 2001, den ersten Werkzeugeinsatz und 2008 einem ersten Implantat, das hier bei uns hergestellt wurde, bis letztendlich dann 2015 das Aachen Center for Additive Manufacturing gegründet wurde, um eben hier die Forschung und die Industrie mehr miteinander zu vernetzen. Das ist auch ein bekanntes Konzept bei uns an der Universität am Campus. Unternehmen können sich ähnlich wie Studierende einschreiben und können gemeinsam Projekte durchführen, hier Themen vorschlagen, die bearbeitet werden sollten und dann kombiniert mit der Forschung eben zusammen die Branche additive Fertigung vorantreiben. Auch am Aachen Center for Additive Manufacturing sind wir hier am Universitätscampus angesiedelt. Ich habe es bereits angesprochen, wir vereinen verschiedene Forschungsinstitute, um den gesamten Lebenszyklus der additiven Fertigung abbilden zu können und so für jeden Thema Ansprechpartner an der Uni zu finden und mit der Industrie zu verknüpfen. So viel zu uns, zum Aachen Center for Additive Manufacturing. Nun möchte ich in das Thema einsteigen und einen Überblick über die additive Fertigung erstmal geben. Was ist das überhaupt? Wie sieht die Branche aus? Und dann möchte ich weitergehen, einen Überblick über die verschiedenen Technologien geben, Anwendungsbeispiele geben, um auch zu zeigen, wie werden die Technologien gewinnbringend eingesetzt. Weiterhin möchte ich darauf eingehen, wie wir die additive Fertigung erfolgreich auch adaptieren können, denn sie ist ja sehr unterschiedlich als die konventionelle Fertigung. Und deshalb muss man auch Unterschiede berücksichtigen, wenn man die additive Fertigung selbst nutzen möchte. Weiterhin gehen wir noch auf die zukünftige Perspektive ein und geben einen Ausblick, wie die Zukunft aussehen wird. Einsteigen möchte ich mit einer Definition der additiven Fertigung. Vielen ist sie ja auch als 3D-Druck als Begriff geläufig. Additive Fertigung ist der mehrfachlich korrekte Begriff, den man in der Branche verwendet. Und das ist ein Prozess, in dem Komponenten basierend auf einem digitalen Modell schichtweise gefertigt werden. Also meistens funktioniert das schichtweise, das geht auch elementweise und das ist eben auch die Unterscheidung zur subtraktiven und formativen Fertigung, dass hier Material aneinandergefügt wird und nicht entfernt oder umgeformt wird. Allerdings gibt es jetzt nicht nur einen Prozess der additiven Fertigung, es gibt ganz viele verschiedene. Sie sehen hier ein paar Beispiele. Links oben ist ein Verfahren, das Fused Deposition Modeling, bei dem Kunststoff durch eine heiße Düse extrudiert und selektiv abgelegt wird. Dann sehen Sie hier auch rechts oben noch ein Verfahren, bei dem aus einer Flüssigkeit, einem photosensitiven Polymer, ein Festkörper erzeugt wird, dadurch, dass es mit UV-Licht bestrahlt wird. Oder auch unten rechts ein Pulverbettverfahren. Hier wird mit einem Laser Pulver schichtweise dort aufgeschmolzen, wo eine Geometrie entstehen soll. Und auch, man kann auch Schichten auf Bauteile auftragen mit anderen Technologien. Sie sehen, es ist schon recht komplex, welche Technologien es so gibt. Und deshalb möchten wir später auch im Vortrag einen Überblick über die wichtigsten geben. Additive Fertigung ist jetzt anders als die konventionelle Fertigung. Wie gesagt, werden Elemente schichtweise zusammengefügt, um Stück für Stück eine Geometrie aufzubauen. Und das ist der große Unterschied zur konventionellen Fertigung. Nun ist es ja so, dass das Thema auch sehr oft mit einem Art Hype-Begriff verbunden wird. Und um das mal näher anzuschauen, wie das so ist, haben wir untersucht oder ausgewertet, wie das relative Interesse auf Google ist für die Suchbegriffe 3D-Printing und Additive Manufacturing. Das erste, was hier direkt auffällt, ist, dass in der Zeit, die jetzt hier angetragen ist, von 2010 bis 2021, der Begriff Additive Manufacturing auf weniger Interesse gestoßen ist auf Google, weil es eben der korrekte Branchenbegriff ist und generell mehr der Begriff 3D-Druck verwendet wird. Und was auch auffällt, ist, dass insbesondere im Bereich ab 2012 das relative Interesse sehr, sehr stark angestiegen ist, was diese Hype-Phase in der Branche auch versinnbildlicht. Und damals auch die Rede von Barack Obama zum State of the Union, dass eben additive Fertigung das Potenzial hat, sehr viel zu revolutionieren. Und dann ist hier die Frage, wie ist es jetzt? Ist es ein Hype, unter dem man sich vorstellt, oder ist es die Revolution, die komplett die konventionelle Fertigung ersetzen wird? Und es liegt dazwischen. Man muss genau wissen, welche Vorteile hat die additive Fertigung, in welchen Fällen macht es Sinn, sie anzuwenden und wie macht man das. Und dann ist es eine Ergänzung zur konventionellen Fertigung, aber in vielen Anwendungsfällen wird es auch sicher noch weiterhin so sein, dass Spritzguss oder konventionelle Fertigungstechnologien die bessere Wahl sind. Der insgesamte Markt der additiven Fertigung wächst stetig. Das sehen Sie hier im Diagramm veranschaulicht. Hier ist der Umsatz weltweit, also die Marktgröße in Milliarden US-Dollar angetragen. Als Quelle sind hier verschiedene Reports von Marktforschungsunternehmen verwendet worden. Und für den Blick in die Zukunft, also bis 2026, sieht man schon, dass die verschiedenen Marktforschungsinstitute ganz unterschiedliche Prognosen auch machen in der Höhe. Also alle sagen, der Markt wird wachsen, aber es gibt schon unterschiedliche Prognosen, wie stark er wachsen wird. Und das kommt davon, dass im Vergleich zur konventionellen Fertigung der Markt auch noch relativ jung ist. Es gibt viele radikale Technologien, radikale Innovationen, die auf den Markt kommen können. Je nachdem, welche Annahmen man trifft und wie die Datengrundlage ist und das System, das aufgebaut wurde, um den Report zu machen, merkt man, alle sind sich einig, der Markt wird wachsen, aber man weiß noch nicht im Detail, wie stark. Auch hier noch einen Überblick über den Markt der additiven Fertigung. Hier wurden sehr viele Firmen befragt, aus welchen Branchen hauptsächlich ihr Umsatz generiert wird. Da wurden AM-Service-Provider befragt, auch Systemhersteller und Materiallieferanten. Und den größten Anteil laut dieser Umfrage macht bisher noch Automotive aus und auch Aerospace, gefolgt schon von der Forschung. Und dann die Medizinbranche ist ja auch eine Branche, die sehr viele Vorteile aus der additiven Fertigung ziehen kann. Und Sie sehen hier noch weitere, in der auch die additive Fertigung eingesetzt wird. Gut, nun werfen wir mal einen Blick, wie denn so die additive Fertigung im übergeordneten Prozess in der Produktion aussieht. Man unterteilt das immer in 3 übergeordnete Schritte: den Pre-Process, also den Vorprozess, vorgelagert zum eigentlichen Druck, den Post-Process nach dem Druck und den In-Process, währenddem die eigentliche additive Generierung des Bauteils stattfindet. Und man teilt es nochmal immer in eine physische und digitale Ebene. Im Pre-Process wird in der digitalen Dimension werden die Daten vorbereitet, CAD, CAM, der Baujob wird eingerichtet, die Produktionsplanung muss gemacht werden. Und in der physischen Vorbereitung wird Material zur Anlage gebracht, die Fertigungsmittel werden vorbereitet. Und ja, dann, wenn die Daten und alles bei der Maschine ist, kann es losgehen mit dem Druck. Das Bauteil wird physisch generiert. Und auf der digitalen Seite nimmt man auch noch viele Daten auf, die während des Druckprozesses gesammelt werden können. Zum Beispiel schaut man mit Kameras rein oder mit Vibrationssensoren und Ähnlichem, um live die Qualität mit beurteilen zu können. Nach dem Druck ist es aber so, dass abhängig von der Technologie noch weitere Nachbearbeitungsschritte notwendig sind. Es kann mal sein, dass man Stützstrukturen entfernen muss, aber auch wenn die Oberflächeneigenschaften noch nicht den Anforderungen im Einsatz entsprechen, kann es hier notwendig sein, nochmal eine Oberflächenbehandlung nachzuschalten oder eine Wärmebehandlung, um die Materialeigenschaften und auch die Eigenschaften der Anwendung nach dem Druck noch einstellen zu können. Auch während des Post-Prozesses ist es wichtig, Daten zu sammeln, auch für die Qualitätssicherung, aber auch für die Produktionsplanung und Steuerung, wo sich welche Bauteile befinden. Und ja, danach geht es mit den Bauteilen weiter wie gewohnt. Sie können montiert werden, werden versendet. Und die ganzen Daten, die man in diesem digitalen Prozess sammelt, können ausgewertet werden, um langfristig Vorteile in der Qualität und auch der Produktionsplanung zu erzielen. Jetzt ist es aber so, dass dieser Prozess sehr unterschiedlich nochmal sein kann für verschiedene AM-Technologien. Je nachdem, welche Technologie man nutzt, je nachdem, welche Anforderungseigenschaften man benötigt, benötigt man auch verschiedene Dinge in der Datenvorbereitung oder auch im Post-Processing. Und ja, 4 zentrale Eigenschaften, die additive Fertigungstechnologien gemeinsam haben, ist natürlich einmal das Additive, darauf sind wir bereits eingegangen. Dann sagt man auch immer, dass die additive Fertigung eine werkzeuglose Fertigung ist. Das bedeutet im Eigentlichen, dass die Werkstückgeometrie nicht an eine Werkzeuggeometrie gebunden ist. Und das führt dann zu vielen Vorteilen, wie dass man nicht erst ein Werkzeug vom Werkzeugbauer bestellen muss und direkt eben basierend auf einem 3D-Modell digital fertigen kann. Ja, die Technologie ist auch digital. Wie gesagt, man kann auf einem 3D-Bauplan fertigen und es fallen auch viele weitere Daten an, die relevant für das Qualitätsmanagement sind, die man aufnehmen kann während des Prozesses. Weiterhin ist das ganze Themenfeld recht komplex. Das folgt aus den verschiedenen Technologien, den verschiedenen Wirkprinzipien, aber auch dem anderen Design, das notwendig ist für die additive Fertigung und erstmal auch dem Wissen, das man benötigt, um gewinnbringend Anwendungsfälle zu identifizieren und auch umzusetzen. Hier möchte ich noch auf die generellen Vor- und Nachteile eingehen, wobei, wie das angesprochen, technologiespezifisch ist. Ein großer Vorteil, der eigentlich immer zuerst auch genannt wird, ist die große Designfreiheit, die man ermöglicht durch diese werkzeuglose digitale Fertigungsweise. Man kann sehr komplexe Geometrien fertigen, Gitterstrukturen oder auch innenliegende Kühlkanäle. Man kann Leichtbau-Bauteile besser umsetzen, da man nicht diese Designrestriktionen durch ein Werkzeug vorliegen hat. Und man kann auch sogenanntes monolithisches Design umsetzen. Dadurch ist gemeint, dass man durch die Designfreiheit Bauteile, die zuerst aus Fertigungsrestriktionen getrennt gefertigt und dann gefügt oder montiert wurden, direkt in einem Bauteil druckt und so Montageschritte einspart. Man kann sehr flexibel Designiterationen durchführen, auch im Produktentwicklungsprozess, um verschiedene Prototypen zu fertigen, Dinge auszuprobieren, und auch technische Änderungen kann man einfach umsetzen. Das folgt aus diesen Eigenschaften, die ich vorher genannt habe, hauptsächlich dadurch, dass man keine Bindung an eine Werkzeugform folgen muss. Durch die Designfreiheit kann man auch Funktionen integrieren, wie beispielsweise innenliegende Kühlkanäle, Dämpfungsfunktionen, Wärmeleitfunktionen. Man kann auch dadurch, dass man Skaleneffekte nicht so stark nutzen muss, sehr kleine Stückzahlen fertigen und sogar individualisierte Bauteile. Allerdings, was man ja auch beachten muss, ist, dass die Zeit von einer Idee bis zu einem tatsächlichen Bauteil stark reduziert werden kann, dadurch, dass man nicht erst ein Werkzeug herstellen muss oder sehr aufwendig eine Bahnplanung durchführen muss und Umspannvorgänge planen muss. Das macht eben das Verfahren sehr flexibel. Auf der anderen Seite sehen wir aber bei den Nachteilen, dass bei den meisten Technologien die Druckdauer relativ lange ist. Das heißt, wenn man sehr hohe Stückzahlen fertigen möchte, ist da so der Zielkonflikt zwischen dem schnellen Datenvorbereitungsprozess, dass man auch erste Bauteile hat, aber wenn man sehr, sehr viele Bauteile fertigt, es in die Hunderttausende geht, dann ist Spritzguss einfach insgesamt schneller, um diese große Bauteilanzahl herzustellen beispielsweise. Weiterhin ist die Lieferkette der additiven Fertigung in der Regel geringer. Man fertigt kürzer, man fertigt direkt basierend auf den Werkstoffen, die in die Anlage kommen. Und man kann auch unabhängig vom Standort fertigen, da man nicht erst das Werkzeug irgendwo anders hin liefern müsste. Und weiterhin ist es auch möglich, die additive Fertigung mehr wieder inzusourcen. Das kommt durch einen hohen Automatisierungsgrad und ja auch eben durch diese Freiheit, auch dezentral fertigen zu können. Weiterhin ein Vorteil der additiven Fertigung ist die große Nachhaltigkeit, wenn man sie richtig einsetzt. Wenn man vor allem Werkstoff einsparen kann, bringt das zu einer großen Einsparung von CO2-Äquivalent und auch wenn man eine bessere Performance in der Nutzungsphase erzielen kann durch eben Funktionsintegration oder längere Lebensdauer, wie wir später in den Anwendungsbeispielen sehen werden. Ja, nun möchte ich noch kurz mehr auch auf die Barrieren eingehen, die man bedenken muss, wenn man additive Fertigung einsetzen möchte. Wenn man den Vorteil hat, keine Skaleneffekte für geringe Stückzahlen, ist es natürlich ein Nachteil, wenn man Skaleneffekte für große Stückzahlen ausnutzen möchte, dann funktioniert das nur in gewisser Weise mit der additiven Fertigung. Außerdem sind die Oberflächeneigenschaften oft geringer als in der konventionellen Fertigung. Das erfordert dann noch weitere Nachbehandlungsschritte. Ähnlich ist das mit den geometrischen Toleranzen, abhängig von der Technologie, sind die etwas geringer als bei vielen konventionellen Fertigungstechnologien. Das sollte man auch berücksichtigen. Mal jetzt abgesehen von den qualitätsbezogenen Eigenschaften ist es auch notwendig, dieses Mindset, das man benötigt für die additive Fertigung im eigenen Betrieb zu implementieren und die Fähigkeiten zu erlernen. Denn wie etwas designt wird, wie man Bauteile identifiziert, wie einfach die Fertigung funktioniert, ist sehr unterschiedlich. Daraus können wir Vorteile ziehen, aber es ist auch notwendig zu wissen, wie das funktioniert, um es erfolgreich machen zu können. Zu guter Letzt haben wir noch gewisse Anforderungen an die Gesundheit und die Sicherheit, die man im Produktionsumfeld berücksichtigen müsste. Beispielsweise mit Metallpulver ist der Umgang natürlich ist zu beachten, dass man, wenn man mit offenem Metallpulver arbeitet, Atemschutzmaske trägt, die richtige Schutzausrüstung. Das heißt, wenn man diese Maßnahmen ergreift, ist das in der Regel kein Problem, aber man muss sie eben ergreifen, sonst wird es zu einem Problem. Gut, soweit zur Einführung in die additive Fertigung im Generellen. Nun gehe ich weiter auf spezifische Technologien ein. Es gibt sehr, sehr viele, wie bereits eingangs angesprochen, AM-Technologien. Hier ein Überblick über industriell sehr relevante Metall-AM-Verfahren. Diese sind aufgegliedert nach Wirkprinzipien. Ganz links sehen Sie Powder-Bed Fusion, die Pulverbett-Verfahren. Hier wird schichtweise eine dünne Pulverschicht aufgezogen und dann selektiv durch eine Strahlquelle verschmolzen, eben dort, wo die Geometrie entsprechend des Bauplans entstehen soll. Das kann durch einen Laserstrahl oder durch einen Elektronenstrahl oder andere Wirkprinzipien geschehen. Weiterhin gibt es die Verfahren der Direct Energy Deposition. Hier wird nicht in einem Pulverbett gearbeitet, sondern das Material wird durch eine Düse in Pulverform oder auch Drahtform, das ist auch möglich, aufgetragen. Und Schichten werden auch wieder selektiv abgelegt, um eben die Bauteilgeometrie zu erzeugen. Weiter auch das Wire Arc Additive Manufacturing ist hier noch mit aufgeführt. Das nutzt jetzt nicht einen Laser wie die beiden links dargestellten Verfahren, sondern das Prinzip des Lichtbogenschweißens. Weiterhin gibt es Verfahren der Materialextrusion, die kennen Sie vermutlich auch schon so mehr aus dem Hobbybereich, aus dem Polymer-Metalldruck, aber man kann das auch mit Metall machen, dass man Metall aufschmilzt, durch eine Düse führt und dann selektiv ablegt, um ein Bauteil herzustellen. Hier ist aber noch anzuführen, dass man die Bauteile danach sintern muss, um eine sehr, sehr hohe Dichte zu erreichen. Genauso wie bei Material Jetting. Hier werden Metallnanopartikel durch eine Tinte aufgetragen und dann eben auch durch Hitze aufgeschmolzen. Auch ein weiteres Funktionsprinzip für Metall-AM. Ja, auf diese 4 hervorgehobenen Verfahren werde ich nun auch weiter eingehen und Videos zeigen, dass man mehr versteht, wie diese funktionieren. Hier zu Beginn das Laser Powder Bed Fusion. Das wird auch oft bezeichnet als selektives Laserschmelzen. In der Ausgangssituation hat man erstmal einen digitalen Bauplan, den man aufbereiten muss, und Metallpulver. Und die Generierung erfolgt iterativ in einem Zyklus. Zuerst wird eine dünne Metallschicht aufgebracht. Sie sehen es auch hier im Video. Durch einen Beschichter wird eine dünne Metallschicht aufgebracht. Dann wird selektiv die Geometrie mit dem Laser verschmolzen. Die Bauplattform fährt um die Schichtstärke ab. Der Beschichter zieht eine neue Pulverschicht auf und dann geht es wieder von vorne los, die nächste Schicht kommt und Stück für Stück entsteht so das Bauteil nach oben hin. Bei Laser Powder Bed Fusion ist es nun so, dass man Stützstrukturen braucht für Überhangswinkel. Zum einen, um Temperatur, die hier eingetragen wird, abzuführen und nicht zu großen Verzügen zu kommen. Eben die Temperatur in die Bauplatte, die darunter liegt, abzuführen und auch, um das Bauteil in Form zu halten, sodass es hier nicht zu Verformungen kommt durch die thermisch induzierten Eigenspannungen. Es ist generell möglich, schweißbare Metalle zu verarbeiten. Hier Beispiele aufgeführt. Dadurch, dass das Verfahren industriell schon sehr weit etabliert ist, sind auch viele Werkstoffe qualifiziert. Stähle, Nickel-Basis-Legierungen, Kobalt-Chrom-Legierungen, pures Kupfer und Legierungen, Titan, Aluminium-Legierungen und ja auch mittlerweile High-Entropy-Alloys und neuartige Werkstoffe, die direkt für Laser Powder Bed Fusion entwickelt werden. Das nächste Verfahren, das ich vorstellen möchte, ist Laser Metal Deposition, auch oft bezeichnet als Laserauftragsschweißen. Das funktioniert auch mit Metallpulver und wieder einem digitalen Bauplan. Nur wird hier das Metallpulver nicht in einem Bett abgelegt, sondern es wird durch einen Schutzgasstrom durch eine Düse geführt und trifft dann am Substrat, also dem darunterliegenden Bauteil, auf den Laserstrahl und wird aufgeschmolzen. Das heißt, durch den Laserstrahl wird die Energie zugeführt und es bildet sich hauptsächlich am Substrat dieser Schmelzpool aus. Und dadurch kann man jetzt nicht nur wie mit Laser Powder Bed Fusion Bauteile in einem Pulverbett aufbauen und direkt additiv fertigen, sondern man kann auch additiv Beschichtungen und zur Reparatur mehrere Schichten neu auftragen, um hier bestehende Bauteile wieder zu reparieren und instand zu setzen. Sie sehen den Prozess wieder hier. Hier wird eben, wie angesprochen, eine neue Schicht aufgetragen auf ein bestehendes Bauteil. Diese Technologie gibt es grundlegend auch mit Draht als Zuführung. Sehr ähnlich ist das extrem Hochgeschwindigkeits-Laserauftragsschweißen. Der Unterschied hier ist, dass das Pulver bereits früher im Laserstrahl geschmolzen wird und der Energieeintrag hauptsächlich schon über dem Substrat, über dem Bauteil erfolgt. So kann man sehr viel schneller sehr dünne Schichten herstellen und höhere Aufbauraten erzielen, aber auch dünnere Schichten. Aktuell ist es hauptsächlich noch so, dass dieses Verfahren für rotationssymmetrische Bauteile eingesetzt wird. Das hat den Grund, dass es gar nicht so einfach ist, ein Bauteil so schnell und präzise bewegen zu können, wie diese Aufbauraten möglich sind. Später, im Blick in die Zukunft, werde ich aber noch auch schon mittlerweile industriell verfügbare Technologien herstellen, die das schon umsetzen, dass man mit der Technologie auch tatsächlich dreidimensional Bauteile aufbauen kann und nicht nur rotationssymmetrische Bauteile beschichten kann, was aber auch in vielen Anwendungsfällen sehr sinnvoll ist. So, ja, hier dargestellt ist noch das Binder-Jetting, eine eher noch vergleichsweise neue Technologie, würde ich sagen. Sie ist noch nicht so weit am Markt etabliert wie Laser Powder Bed Fusion, hat aber das Potenzial, viel produktiver zu sein. Und um das zu verstehen, wie das Versprechen eben von Binder Chatting ist, muss man sich auch einmal den Prozess anschauen, wie der funktioniert. Hier ist es so, dass man zusätzlich zum Metallpulver noch eine Art Kleber auftropft, einen Binding Agent, während des Pulverbettprozesses. Das heißt, Sie sehen wieder hier, es ist wieder ein Pulverbett, nur dass dieses Mal kein Laser eingesetzt wird, sondern ein Kleber aufgetragen wird, der dann durch eine Wärmequelle verfestigt wird. So entstehen erstmal recht fragile Bauteile, die noch weiter gesintert werden müssen. Aber der Vorteil hier ist, dass man nicht scannen muss, sondern da fährt einmal dieser Druckkopf drüber und es ist viel einfacher, möglichst schnelle Aufbauraten zu erzielen. Und man benötigt keine Supportstrukturen wie bei Laser Powder Bed Fusion. Der Nachteil ist aber, dass man im nachfolgenden Schritt noch sintern muss, also durch Wärme die Dichte erhöhen. Und hier kommt es zu Schrumpfung, die man kontrollieren muss. Ja, so viel zu den Technologien. Auf dieser Folie ist nochmal ein Überblick über die generell verarbeiteten Werkstoffe gegeben. Es gibt noch weitere, aber das sind so die industriell relevantesten. Nickel-Basislegierungen, die sehr korrosionsresistent sind, auch sehr gute mechanische Eigenschaften haben und die auch härtbar sind. Kobalt-Basislegierungen für sehr auch hoch beanspruchte Bauteile, weitere Legierungen wie Titan, Aluminium, Werkzeugstahl, Edelstahl und auch Kupferlegierungen. Mittlerweile ist es auch möglich, reines Kupfer zu fertigen. Das war lange ein Problem, da hier der Laserstahl sehr stark reflektiert wird, aber das bekommt man mittlerweile technologisch auch in den Begriff und auch gerade für die Schmuckbranche auch Gold und andere Materialien, die hier eben für Schmuck in Frage kommen. So, nun zu den Polymertechnologien. Hier gibt es vergleichsweise ähnliche Wirkprinzipien wie in der metalladditiven Fertigung, aber die Prozesse funktionieren eben doch in Details anders als mit Metall, da eben der Werkstoff auch anders ist und andere Ansprüche hat. Man hat wieder das Wirkprinzip der Powder Bed Fusion. Hier gibt es verschiedene Wirkprinzipien wie das selektive Lasersintern, das sehr ähnlich zu Laser Powder Bed Fusion ist. Es wird auch Polymerpulver schichtweise aufgetragen und durch einen Laser verschmolzen. Auch Multi-Jet Fusion ist als weiteres Pulverbettverfahren zu nennen. Hier wird wieder eine Pulverschicht aufgezogen, aber dann werden zwei verschiedene Flüssigkeiten aufgetropft. Ein sogenannter Binding Agent, der Wärmestrahlung gut absorbiert, und ein Detailing Agent, der die nicht so gut absorbiert. Und bei Bestrahlung durch Infrarotstrahlung härtet eben dort das Bauteil aus, wo dieser Binding Agent aufgetropft wurde. Und der Detailing Agent führt dazu, dass man genaue Konturen fertigen kann. Dann gibt es weiterhin Verfahren der Materialextrusion. Das Fused Deposition Modeling ist hier vielleicht auch schon vielen ein Begriff, da es sehr schon im Heimgebrauch eingesetzt wird und auch in dieser ganzen Do-it-yourself-Community schon sehr viel auch weiterentwickelt wird. Hier wird ein Polymerfilament durch eine Düse aufgeschmolzen und in Schichten bahnweise selektiv abgelegt. Ein ähnliches Prinzip nutzt dann das Granulat-FDM. Hier ist der Ausgangswerkstoff dann kein Filament, kein Polymerstrang, sondern Granulat und wird durch eine Extruderschnecke dann durch diese Düse geführt, und man erhofft sich dadurch höhere Aufbauraten und eine höhere Produktivität und auch Vorteile in der Materialbereitstellung. Weiterhin gibt es das Material Jetting. Hier wird ein Polymer und eine Tinte aufgetropft und durch UV-Licht bestrahlt, sodass diese aushärtet. Und weiterhin gibt es die Verfahren der Photopolymerisation. Diese nutzen jetzt auch flüssige Ausgangswerkstoffe, das heißt kein Pulverbett, sondern eigentlich ein Flüssigkeitsbett. Und man nutzt Laser und einen Fotoprojektor, um diese auszuhärten. Im Weiteren werde ich dann noch weiter auf diese Verfahren eingehen, hier offline und dann auch eben noch offline hier weiterführen. Das heißt, wenn Sie gerne vorbeikommen möchten, den Vortrag noch zu Ende folgen möchten, haben Sie in den nächsten Tagen noch die Gelegenheit dazu.
Ja, wunderbar, Lukas. Vielen Dank schon mal für diese grundsätzlichen Informationen über AM, damit wir auch wissen, worüber wir reden hier, wenn wir, sagen wir mal, noch frisch im Thema sind. Und es ist ja eine Technik, die, sagen wir mal, wirklich brandaktuell ist, wo man erstmal wirklich reinkommen muss. Und es ist ja auch sehr kompliziert, die vielen Verfahren. Und es sind ja auch viele Begriffe, sage ich jetzt mal, die muss man erstmal auseinanderhalten. Also vielen Dank für diese Seminararbeit. Ja, liebe Zuschauer, vielen Dank auch an Sie draußen fürs Zuschauen. Wir machen jetzt im Livestream eine Sendepause. Wir sehen uns dann wieder pünktlich um 14 Uhr. Da geht es dann weiter mit unseren Pitchnext Sessions. Das wird sehr, sehr spannend auch, weil hier ist dann eben das, was der Lukas in der Theorie erzählt hat, wird es dann eben in der Praxis gezeigt werden, was die Firmen, junge Start-ups sich eben überlegt haben, um die Welt des Additive Manufacturing mit ihren Inhalten zu bereichern. Hier im Saal, wie gesagt, geht es weiter mit dem zweiten Teil des Seminars. Vielleicht auch noch der Anreiz für den einen oder anderen, doch noch auf die Messe zu kommen, der uns gerade im YouTube-Stream verfolgt. Also hier in den Hallen passiert natürlich nicht nur an den Ständen viel, sondern eben hier auch beim Seminar. Ja, dann würde ich sagen, vielen Dank und wir sehen uns pünktlich um 14 Uhr wieder.
joyride, a hit and run. I thought I loved you and you thought I was fun. I'm moving on down the road. Watch me as I go, watch me as I go. Should I look both ways before you cross me, baby? 'Cause I don't break for boys. I'm moving on. For miles, 67 fastback, oh, it's just my style. We're headed down the road. Just enjoy the show, watch me as I go. Should've looked both ways before you cross me, baby, 'cause I don't break for boys. I'm moving on. I'm moving on. Got nothing left to say. Let's be on my way. Best of luck. I'm moving on. I'm moving on. I'm moving on.
Hello, ladies and gentlemen, and welcome to one of the highlights of this year's Formnext, the Pitchnext event 2022. The trade fair is once again full of innovation, trends, new machines, new materials, and much more. Driven by the big players in our industry, but also by now established startups that have stood on this stage at some point in their development and pitched their innovation with full excitement. For some, it was a starting point. For others, it was a clear validation of their idea, new food for their energy that drives these young companies and makes them successful. And all of this in front of an audience that came to the leading trade fair of additive manufacturing to experience just that. Established companies that are constantly developing and young companies with fresh ideas that are trying to revolutionize our industry, additive manufacturing. This event underlines Formnext's DNA of always keeping its finger on the pulse of time, which is the reason why it was obvious from hour zero to not only offer startups a stage, but also to actively promote them. In addition to this event at the AM4U stage, Formnext supports young companies with an attractive offer so that they can present their products or services to the world in the startup area. This year, you will find the startup area in Hall 12, B81 and Hall 12-1, B101. Another important pillar in the promotion and exclusive access to the startup area in this Pitchnext event is the Startup Challenge. Here, companies can apply with their idea and innovations, and the winners receive a free stand in the startup area, as well as an article at 3dprinting.com. For the past 2 years, there had been another important prize to win, which is also awarded here at the part of the Pitchnext event, namely the AM Ventures Impact Award, which was created for startups that particularly have a large impact on the topic of sustainability. For an event as important as the Pitchnext event, it naturally needs partners who make such an event possible in the first place. We would like to take the opportunity to give a big thank you to the partners. First of all, of course, to AM Ventures for giving out the AM Ventures Impact Award, and that's quite more important, for actively and constantly supporting the Startup Challenge itself. Next thank you goes to VoxelJet, who are printing our awards later for the Startup Challenge. For the first time this year, and this is worth an announcement and a big thank you, we will also give out a financial prize. This comes from HZG Group, who are sponsoring us for the first time and is a respectable €1,000 for the winning startups. Thank you very much for this prize money. Last but not least, a huge thank you goes to 3dprintingindustry.com for supporting our winners with a feature on their website. As you all can see, it's all about quality, which is why we do need to have an excellent jury, of course. Let me briefly introduce you to this jury. And they had a really hard time to select the winners, as we have so many good participants at this Startup Challenge. Stefanie Brickwede, at first, is head of additive manufacturing at Deutsche Bahn and also managing director of Mobility Goes Additive. And as we had her in the panel discussion this morning, I can confirm she is heavily driving the development of additive manufacturing. Then we have Dr. Christian Arndt, CEO of the Fraunhofer Center of Network Additive Production, Dr. Peter Meyer, Professor of Material Engineering from the Technical University of Munich, Alexander Oster, Director Additive Manufacturing of Autodesk, Michael Patch, Editor-in-Chief of 3dprintingindustry.com, and of course, Arno Held, Managing Partner of AM Ventures. Thank you to all of you for the, again, very difficult decision to choose our winners. One question remains for all of us: what is actually a startup, or who do we consider as a startup here at the Pitchnext event? The rules are relatively simple. A startup must not be older than 5 years, have a maximum turnover of 10 million euros, and not have a shareholding with a turnover that exceeds 10 million euro as well. In addition to the participants of the Startup Challenge this year, we have also startups from the area of the Federal Ministry for Economic Affairs and Climate Action, as well as the winner of the AMTC Pitchnext event, Fortius Metal, here on stage. Let's finally get to the program. There were no less than incredibly 20 exciting startups waiting for you here and at the screens, which we have divided into the categories of hardware, materials, and software. Afterwards, after the pitches, at around 4 o'clock, I have the pleasure of discussing the topic of startups, financing, and startup culture with 4 really important people of our industry, before we get then to the award ceremony for the Startup Challenge and the AM Ventures Impact Award at around 5 p.m. So let's get started. Each pitch will get 3.5 minutes, and I'm the nasty timekeeper, honestly. And you will have the opportunity to ask questions, and you at the screens as well. You can use the comment function, and I can see your question right here on the monitor, and I can ask them to the startups. So, first startup for the Pitchnext event from the hardware sector is the company Alpha Powders, represented by their CEO, Dominik Sybal. They are one of the winners of the Startup Challenge, and I'm excited to hear about their solution. Dominik, if you are here, the stage is yours. Big applause for Dominik, ladies and gentlemen.
Welcome, everyone. My name is Dominik Sybal, and I am co-founder of Alpha Powders. We are here to join Industry 4.0 revolution. We founded last year with an ambition to become the manufacturer of affordable, high-quality powders for powder bed printing, 3D printing sector. quickly we realized that the task is very difficult and very demanding. We came up with an idea to develop a technique that would allow to improve quality of polymer powders generated in low-cost manufacturing techniques, such as cryogenic grinding. Also, we realized there is a need for severely increased capacity of materials for production of powder materials for 3D printing sector. In order to achieve that, we came up with novel spheroidization technique, novel approach, more unique, more useful, more versatile, more stable than any other known technique for polymer powder spheroidization till now. Technique allows you to improve quality, that is sphericity, of not only cryogenically ground polymers, but also flakish dust waste materials generated by various industries. We want to make change now, so we decided to offer the solution to AM sector in order to allow all companies dealing with polymer powders to improve their products. The first product that we are offering is Sphero Nano. This is a desktop small spheroidizer meant for improvement of quality of powders developed by various R&D centers in different companies. We are starting pre-sale tomorrow, so feel free to contact us. If you want results already, we are open for in-house trial spheroidization. Because the solution is quite versatile, we offer it both to polymer manufacturers and 3D printer manufacturers. Also, we offer it to recycling companies. In order to secure lead times for Sphero Nano devices and facilitate distribution process, we are starting close collaboration with Amazement company. Sphero Nano will be devised with add-ins that may be quite interesting for you. It will have special package for processing of high-performance materials melting above 180 Celsius degrees. It will also have open system software that will allow you to perform research and finely tune spheroidization and rounding properties. My name is Dominik Zdybał, and I am CEO of Alpha Powders, responsible for strategy and innovation. My past experience includes co-founding of Progressive Space. Together with me, Alexander, CTO, expert in polymer processing and polymer technology, and Karol, business advisor and our insight into VC world. Together with this interdisciplinary team of founders, we gathered even more interdisciplinary team of employees that allows us to achieve our goals. Thank you for your attention.
Oh, no, keep it. We have probably some questions. So whenever you have a question, please raise your hand. I will see it and ask it. I have a first question. Dominik, I mean, you are going to pre-sale, so it seems that you're already very advanced. So
this is This is non-binding pre-sale. So basically, we expect to be offer a binding sale next year this time. Right now, we want to start not binding. However, we already offer in-house spheroidization using our Sphero Nano prototype. It still needs some work. It still needs investing into it. However, we are able to do small batches right now.
And what do you need as a startup? So while presenting it, cash. Anybody has cash with him? Yeah. No, oh, sorry, not yet, but probably afterwards. So there's a question from the audience online. How do you see the potential for combining your systems with computation and material discovery?
Sorry?
You have it there?
Yeah, here. Yeah, basically what is interesting here, you can modify your polymer powders with additives added to the powder before the process. This is quite a game changer because usually when you want to design new material for 3D printing sector, you need to start with compounding, pulverization, or solvent method. That makes it very long lead time process. Here, you can add additives to the powder using simple dry blending method, put that to the device, and create highly spherical, stable product right away. That may be important for people who are working with materials, for example, of increased electrical conductivity, or special magnetic properties, or special surface properties. There are actually infinite possibilities of modification of surface of the particle. Also, you can modify the bulk.
Great, thank you. There's another question, please.
All right, so as far as competition is considered...
Let us quickly repeat the question for the people online. So what is your competition? How do you differ from your competition?
All right, so basically, when we consider competition, we should consider every company that is producing powders, and we should consider neither of them. Because when you consider this technology as a crucial link in powder manufacturing, every company that produces powders could be regarded so-called secondary competition. If we consider primary competition, there are some techniques known. For example, Japanese invention, I believe Japanese invention, it's called Nara. It's not melt-based, it's abrasion-based. There are known approaches from lab scale, like Downer reactor. Of course, there are approaches using wet methods, like co-extrusion. These methods are, of course, good, but they have some limitations, and our system overcomes these limitations.
Great. Thank you so much, Dominic. Congratulations for winning the Startup Challenge.
Thank you.
Dominic, applause,
Thank you very much.
please. Can leave the micro, or take it with you, yep. So coming to another winner of the Startup Challenge this year, much faster, much cheaper, combined with a high demand. This sounds very promising, at least from me. Let's take a short dive into microprinting and how photosynthetic will change the market with their approach. Dr. Magdalena Kurup, I hope I put the name correctly, responsible for business development fundraising, will tell us what we need to know. Magdalena, good to have you here. Stage is yours.
Thank you for this nice introduction. Hello, everybody. My name is Magda. I work at Photosynthetic, and today I would like to show you only one use case of our flexible micro 3D printing technology we developed at Photosynthetic. So nobody likes injections done by a conventional syringe. And moreover, this technology is more than 115 years old. The inefficiency of this method of injections drug to human body has been widely explored during the pandemics. So the queue you can see on the picture of people waiting to get vaccination. So in fact, there is a painless technology which can replace the conventional syringe. It's called microneedles. And basically, it's a patch with microstructures of tiny little needles we can put on our skin and transfer the drug via the skin. In fact, the main problem of this technology is that there is no production method able to meet the large-scale manufacturing. Also, the current methods lack the quality and reproducibility. So the simple solution to this seems to be the direct 3D printing, which is quite simple. It's one step, is direct, and also seems to be fast and inexpensive. Moreover, offers the reproducibility and scalability towards the massive large-scale production we need for replacing the syringe. So at Photosynthetic, we have been working on a novel approach. It's called volumetric. So instead of using a single light beam, we use 1 million light beams. It gives us advantage of the speed, so we can increase rapidly the speed of micro 3D printing, giving us the possibility to scale towards large manufacturing. The technology is well patented. Currently, we have 3 patents, and we have been working on this since 2019. For the moment, we are finalizing our MVP, and very, very recently, we printed the first structures. You can see prints of the first microneedles. This is a first trial, and we are very happy to show you this. We are very proud of these pictures. We currently have some launching customers and partners. Currently, 3 customers who are paying, 3 customer leads, and we identified more than 50 prospects within the microneedles market. Just one slide to show off a little bit. We have been recognized both by public and private sector. We recently received the Eurostars funding for the project with a total budget over 1.5 million to prove the feasibility of the production of microneedles. We have been also awarded some startup competitions and publication in conference in the past. In terms of the business model, our biggest ambition is to actually become a new manufacturing standard, including microneedles, with a revenue over 50 million euros. Within the next 5 years, we would like to capture 10% of the market. So to finish, I would like to ask you to join us printing the future at photosynthetic.nl and explore other possible applications of the technology. Thank you.
Big applause. Thank you so much, Magdalena. There's a question from the audience, as far as I heard in my ear. There was one question. No, then we have here on the monitor. So what is the primary challenge that must be overcome to 3D print at the micro scale?
So if we look at the conventional microscale 3D printing, we see that in terms of the microneedles, we have problem of defects and also large-scale production. So basically, yes, speed, large-scale production.
Very good. I think there's another. Is there another question? Okay, perfect. Magdalena, thank you so much. Congratulations.
Thank you.
See you later at the award ceremony. So directly another winner of the Startup Challenge, and this is just occasionally, we didn't put them at the very beginning. So Valerio Di Pompeo and his team at Sphere Cube promise a revolution in high-performance composite materials. We will find out exactly how this takes place in the next pitch. Valerio, I'm curious if you reveal some details to us.
Thank you for the presentation. The material have shaped the history. One example is a clay. The clay has shaped with turning machine to create some tools for it and drinks. Then, to improve the material and the high performance, two or more material has combined to create the best performance on material, such as composite or metal alloy. Hi everyone, my name is Valerio Di Pompeo. I'm CEO and co-founder of Sphere Cube. And we want to reshape the future by 3D printing technology for high-performance composite materials. Actually, the problem in the composite sector is to create the part is necessary many steps to the process, up to 15 steps. It's necessary molds, and the process is mainly handcrafted. This is increase the time to market and the cost, and reduce the flexibility. To resolve that, we want to use the 3D printing in order to improve the high-performance composite material, the automation, less mold, adding material in order to increase the complexity of the geometry of the part. The market size is quite big, and we want to, in 5 years, reach about 33 million of euro, and the early evangelist is about in aerospace sector that we are validating, and is about 2,000 euros about. The idea is, and we are developing a software to improve the mechanical performance about our solution, optimize material such as filament and thermoset resin, and the 3D printer. Thank you very much for attention. See in our booth in level 12, B81, and we want to meet in order to have some idea about the POC. Thank you for attention.
Great, Valerio. Thank you so much for the presentation. So how far are you with your product? That would be my first question. How advanced is it already? When can you start?
Yeah, the mechanical performance, specific mechanical performance, not use the mold that in high performance composite material is necessary, and reduce the steps of the process in order to reduce the time to market and the cost.
Great. Thank you so much. There's a question from the audience. Let me repeat that question. Very good. The question was, what is your business model? So.
Yeah. Actually, we are support the company B2B with consulting and selling parts. And the market, our goal is B2B, and we are validating the aerospace and racing sector. But the idea is to improve the sector, such as biomedical and naval and sports sector.
Awesome. Thank you so much, Valerio. It was a pleasure to have you. A great presentation. See you later at the award ceremony. Thank you so much.
Thank you very much.
So I like names very much, so I'm very interested in the next company because the word free in their company name has definitely something to do with their innovation. I'm curious to see what 3D printing is changing and which application they will approach first. Michael Rieger, CEO, will lead us from 3D printing to 3D printing. Michael, stage is yours.
Hello, thank you everybody. My name is Michael. I'm one of the co-founders of 3D printing, and we print with robots, bigger, more stable, and with less effort, even on complex surfaces. As you all know, there's a common modeling pattern, one modeling paradigm, with horizontal, even and flat layers building up from one direction. And this is due to the reason is that there is a limitation of the systems restricted to 3 linear axes usually, and the software that is only adapted to this kinematic. And the drawbacks that comes with it is in modeling direction, you need the support structures, as you know. You have the problem that you only can print on horizontal and flat surfaces usually, and most of the part characteristic like tensile strength and surface quality are defined by this modeling paradigm. And our approach is we are using a robot with 6 axes, and we are bringing this kinematic and this modeling freedom to the modeling process, and we are overcoming this modeling paradigm with variable modeling patterns with freeform layers. Here you see a video of our booth and our prototype and the robot moving the process head and building up the model with freeform layers. And by doing that, we have the potential to reduce or to avoid support structures and have the possibility also to print on curved surfaces, not just on horizontal and even layers, faces. And we can also combine different layer orientations in one part, and by that, optimizing and affecting the part characteristic, like the tensile strength or the surface quality. And right now, we are already in contact with several partners. For example, with the MedTech, application cases are prothesis and orthesis, also from the automotive industry with prototypes and pre-series and many more. And maybe also your business case, your use case can benefit from that. We are always searching for new application cases and use cases to identify more of them, which use case can benefit from our technology. So we would be happy to discuss that with you. Meet us at our booth in Hall 12.1.
Awesome. Big applause for 3D printing. Thank you so much. Awesome presentation. Do you have a robot with you to showcase?
Yeah, it's at our booth.
Awesome. You should see that. Is there any question from the audience so far? Anyone? I think we don't have. Go ahead. Feel free. It's a pleasure, by the way. The question was which materials they can print.
So right now we are printing with a material extrusion process, the common plastics material, but we can transfer this kind of modeling process also to metal-based processes like laser metal deposition or wire and arc additive manufacturing, and we are working on that.
And there's another question from the online audience. How does your system improve on the Stratasys robotic composite 3D demonstrator? If you know it, I don't know.
Yeah, we know that. How does the system improve?
I think, so, where's your system better? I think this is the question, isn't it?
Yeah, okay. It's about the software and about the strategy of modeling. And we believe the strategy of modeling with the features presented, the 3 ones, this is what we believe is better than other solutions we see on the software side, because for our solution, our modeling, as a user, you don't have to set any modeling direction or so. It's totally, the control program is totally calculated automatically.
Awesome. A last question from the audience. Will you have a low-budget version for this kind of 3D printer technology? I like this very much, to be honest.
Maybe later on, but so far it's an industrial additive manufacturing system, of course. Maybe not meant for each and every 3D printing personal printer, to be honest.
Awesome, awesome. Awesome presentation. Thank you for answering the question. Michael, please, an applause. Honestly, I've always the highest respect, in particular for startups that want to make a difference in the medical field, as they sometimes have to overcome even greater hurdles. At the same time, with their products, they have a great influence on the most important factor in our lives, health and the related joy of life. How Plasmix contributes to this, their CEO and founder, Konrad Schneider, tells us. Konrad, good to have you back again. Stage is yours.
Hello, my name is Konrad Schreiner. I'm the founder and CEO of Plasmix. So who's ever here had an ill-fitting shoe, high heel, ski boot? Anybody? I suppose there are a couple. But you know, if you or I have this problem, we just go out and get another pair of shoes. However, there are people who are not so fortunate. There are 108 million people out there who do not have prosthetics at the moment. There's a massive undersupply. And this is due to 2 factors. First, this human object interface, the thing which actually fits to your body, it takes approximately 8 to 12 weeks to produce and costs on average $2,000 US. However, we change this. We bring down the costs and the time. We can produce the same thing in 3 days by producing on site. But how do we do that? Well, we combine our unique technologies, being induction-based nozzle and our machine learning, with our software together to produce the best quality part possible with FDM 3D printing. And this is a demonstration of how our quality control process works. Basically, we analyze layer by layer, and then we compare it against what the optimal solution would look like. Yeah, it's going to finish. And then we can create a report to show, okay, we are actually up to spec or we are not. We recently launched our nozzle, which is induction-based, the first one in the market. It's really groundbreaking, and we have our patents are also tied into this 3D printing nozzle. And this is not just an easy feat. It's actually a pretty hard problem, NP hard problem, to be honest. But we have the great team for that. We have material scientists. My co-founder, Stefan Spohr, would be in this category. But we have a team of another 15 people strong to facilitate this, as well as advisors. However, if you think about certified production on site, wherever this may be, then you can produce not only prosthetics, but you can produce other products, like, say, insoles or other orthopedic devices. And you're not bound to produce in-house, on-site, and sell elsewhere, but you can basically sell the machine and then locally design and produce your IP, and sell it globally. Yeah, this is what we do at Plasmix, and I'm really happy to have your questions.
First, an applause. Excellent presentation. Thank you, Konrad. Come a little bit over to me, please. So my first question before we ask probably the audience, because I'm following up this last year, I'm really highly interested in your solutions. If you compare now the prosthesis, the one that is like produced in the 12 weeks period of time and years, is there also an improvement in usability and user experience? Because it's quite important for the one that is getting it. Is there a difference with using 3D printing?
There's little a man cannot do with their hands, but it's going to take ages, it's going to take time, and it's going to take money, therefore. So, but we have an integrated approach where we can combine also softer and harder materials in one print. So it's very easy to combine everything in one print, and making the things available is for somebody who is not having a foot, it's really more important to have it.
So it's right now it's more about availability and speed, and not about the real quality comparison between the original method and this one.
We have been specializing in multi-material printing, so we already have 3D printed circuitry inside those objects, but this is just like 2 more steps ahead. It's more important to deliver tomorrow than it's to have the most intelligent prosthetic there is.
Awesome. In my opinion, very important. There's a question from the audience.
Really good question.
Can we repeat the question for the audience?
So it's basically about the process control and the report. It's not only the process control and the report, but we are actually, the report was more or less a side effect of what we're actually trying to accomplish, and having a full cycle machine learning loop. So basically, we're feeding that information back into the slicer, which is cloud-based, analyzing it there, and feeding it back into the G-code of the next layer.
Awesome. Thank you so much. Konrad, it was a pleasure to have you back here again.
Thank you very much to have me again.
See you probably next year. No? See you. Bye-bye. Thank you. Big applause. Serious production in metal 3D printing. I assume each and every one of us has asked this question, is that already in place? Do we seeing that? So far, still not really implemented in my point of view. So Vaikun wants to overcome a few hurdles and move into previously unreached market segments. Definitely exciting. Let's take a look at the realization with Jonas Gall, CEO and founder of Vaikun. Jonas, stage is yours.
Thank you for the introduction. Sorry?
Perfect. Yeah.
Okay. So I'm Jonas from Valken, CEO and co-founder. And actually, I'm always triggered by metal 3D printing because I see a lot of potential in it. But I also see a lot of hurdles yet. And that's basically what we try to solve with Valken, because we want to bring metal 3D printing towards serial production in an economical way. And to do that, we first have to look at a couple of hurdles that we identified. And actually, we focus initially at aluminum, because aluminum today is somehow understated. There are so many applications on aluminum, and to be honest, printing aluminum is kind of a pain in the ass for a lot of technologies. Second thing is hardware. So far is still expensive because the use of lasers. So we want to bring that down. Also, that comes to the productivity, because if you have a fast machine, it can be more expensive. The problem is, most of the technologies today are quite slow with an expensive machine. So that's not really beneficial for serial production. Another thing is the feedstock as well, because a lot of technologies use high costly feedstock, which is not necessarily necessary to come to serial production. And the technologies that use powders, a lot of people say additive manufacturing is good to reduce a CO2 footprint, but if you look at what it costs in terms of energy and CO2 footprint for making powders, for example, you would be amazed how sad it would be for additive manufacturing. And the next thing is safety. As you see on this picture for powder bed fusion, they're wearing masks in order to avoid health issues, but also it's sensitive to explosions, these kind of things. And the next thing is automation, because your process itself can be efficient, but if you have to do a lot of things, pre-processing, post-processing, it might affect your capabilities to go towards serial production. So how are we dealing with that? So here you see a movie of our process, and basically it's FDM 3D printing, but instead of using polymers or powders in a polymer binding, we use direct molten metal that we deposit in a controlled way. And in that way we can actually print aluminum quite efficiently, because actually the fusion energy is coming from the printhead itself. So as you know, aluminum is highly conductive, so it's like filling up a bath with the tube plug open. Here we actually use all the energy inside the printhead, deposit the material, so the only extra energy we need is to have the fusion. It's quite simple technology as for FDM. The only thing you have to do is melt the metal inside the printhead. That can be quite straightforward. So the productivity is basically the same as in FDM. So we have demonstrations of a print nozzle of 7 millimeters. We have gone very much slower, so we can have the same resolution as classic FDM printing. For the feedstock, as we print everything in a nozzle, it doesn't really matter what we feed towards the printer. At the moment we use wires, but that can be anything else. In terms of CO2 footprint, if you take aluminum chunks, you don't have to do the whole process to go towards powders and the extra energy that's needed to do so. In terms of safety, we don't have splattering of plasma stuff or powder that's flowing around. So in that way, it can be basically in open air. And I will come to the next video I have here that demonstrates really the automation capabilities. As we print it basically in ambient atmosphere. We can simply change the hot swapping after printing, as the process is not affected by thermal stresses. We can use very light build plates to print our parts on this. So the part being printed is the one I have here. So that's how we are going to encounter.
I need to do the timekeeper. You're already far over the time.
Okay,
sorry.
I'm so enthusiastic that I
probably just one last remark and then.
So where we are in the landscape of the serial production towards the complexity, it's the empty space we want to close towards larger series, but also more complex parts. And to give a reference, if you compare ourselves to milling, we see from the business cases we have that about when there is 70% chipping or more, then our technology becomes more interesting, even with post-processing included. And for die casting, we see that we are more economic, up to 3 to 5K of parts, depending on the application and needs. So that's all I wanted to say, and I have to leave.
It was still a great presentation, right?
Yeah.
But we need to work on the timing, that's for sure.
Yeah, you're right. Yeah.
Thank you so much, Valkun. Thank you so much.
Thank you.
Great for having you. And we can visit you at your booth and ask our questions there.
Yeah, exactly.
Thank you so much.
Thank you.
Applause for you. Sorry for that. Everybody has the same rules. So we're coming to our last startup in the hardware sector. So real-time monitoring of the mechanical properties of transformed materials. That's what Mach3D, I hope I put it correctly, promises on their homepage. Matteo Vittori, is it correct? I hope so.
Perfect.
Thank you so much. CEO and founder tells us how they make it happen. Matteo,
thank you for the nice introduction.
You're welcome.
So people, I saw you a bit sleepy, so I would like to help you with your food coma, just with a quick walk throughout industrial production. My name is Matteo Vittori, I am the CEO of Mach3D. This is an FFF additive manufacturing production. This is an SLS MJF production. This is an SLA production, and this is a metal additive manufacturing production. Then we jump in the space in the International Space Station, where they have an additive manufacturing lab. What do they have in common? They are transforming raw materials into final product with a single-step process. Moreover, there are no facilities to perform material testing directly there. Material testing is a key to detect anomalies into materials that have to move to industrial productions. Today, material testing starts from specimens that are tested onto complex and dangerous machines that generate curves from which then engineers are able to extract the mechanical properties. You can do this in outsourcing with long time to response and fixed cost, or in-house with a huge investment for mechanical testing solutions, laboratories, and qualified personnel. Today, traditional material testing solutions for cost, complexity, and timings are not ready for industrial production and not accessible for small, medium enterprises. Mark3D is a smart material testing platform with 3 magic features. Its size, extremely compact, allows Mark3D to be placed everywhere in every company. Thanks to our patented fixture, the test is made easier, safer, faster, but still accurate. Thanks to the cloud, results are immediately shared in the company, can be correlated with process parameter, and then we can enable optimization and industrial process monitoring and correction. We are a team of engineers, 2 founders, mechanical engineers with a PhD in material testing and non-conventional materials. Then the team is completed with marketing skills and software skills. We have a mixed business model. We sold in one-off our hardware. We generate recurring revenues from the cloud platform and the artificial intelligence features. Mark3D will be a network of sensors collecting data that are feeding our data pool, on which artificial intelligence could generate more and more values for our customer and then for us. We are in the material testing market that suffer huge of the entering barriers we stated. In Europe, in additive manufacturing and plastics, we count more than 100,000 companies. The 60% of them is ready to invest in material testing with a budget comparable to the Mark3D budget. This makes for us in Europe a 1.5 billion market ready to be achieved. We differentiate for the ease to use and the maximum load to cost ratio, and for our cloud, we have now a validated, patented, and certified hardware, the first industrial and academic application, first customers, and first market traction. We want to enter the market in Europe for the next 3 years, while completing our product. We need a 1.5 million euro ticket for doing this. This is Mark3D, the revolution in material testing.
Awesome. Thank you so much.
Thank you.
Just in time. I really like the last one, because this will be my next question, what you really need, because it seems already everything very advanced.
We have everything clear. Yeah. We just need the money to do our project.
Very good, very good. Any questions from the audience so far before I ask my question? No? Do you have already customers in place where they are using it with their machines, beside the ones that you have your first customers? Yeah. So can you give us an example how they use
we actually have made 2 rounds of beta testing. The first round was supposed to give back the machines to us. The second round, we just have been able to sold the machines at the end of this testing period. One customer is manufacturing resins for additive manufacturing. The second customer is building small metal parts and is using Mark3D at the end of the manufacturing process. And the third customer is an academy that is using for research and teaching.
Very good. Awesome.
Thank you.
Thank you so much, Matteo. It was a pleasure to have you here. Mark3D, big applause. So, ladies and gentlemen, those were our startups from the hardware field. Again, please, a big round of applause, because I think I did a really good job at their presentations. And let's now move over to the topic of materials and applications. And we will start with another winner of the Startup Challenge in the first place. And secondly, not only that, they also won the AM Ventures Impact Award. And for me, it's absolutely clear why they did this. We are talking about Lattice Medical, who are dedicated to a very important topic of our time, and are making a real contribution, in my opinion, to improving the situation of many women in the world. Julien Payen, I hope I put it correctly, CEO of Lattice Medical, explains how they achieve this and what is so important about it. Julien, pleasure to have you here.
Thanks. Hi everyone. It's a real pleasure to be here today to present Lattice Medical. So Lattice, we have developed a patented and unique technology to regenerate human soft tissue by combining biomaterials and 3D printing. The first application of the product concerned the breast cancer and mainly the breast reconstruction. Do you know that 1 woman on 8 will suffer from breast cancer in the world? And today the main treatment is still the surgery. We remove the breast tissue. It's called a mastectomy. And we have only 1 woman on 5 having a reconstruction. Because in one hand, we have the silicone implant bearing long-term problems, and autologous surgeries, really long, 10 to 12 hours, or iterative. Our vision is to replace the silicone implant from the breast surgeries. How we do that? We introduce Matisse. Matisse is a tissue-engineered implant with 3 features. The first one, Matisse, this is the product, enables the regeneration of adipose tissue, the fat tissue of the breast. The product is fully degradable over 18 months. It disappears, like a Suturian. And the surgery takes only 1 hour. I have a short video to introduce the concept. In that case, we have a woman. She had a mastectomy on the left breast. We use the same entryway. We don't add new scars. The surgeon will harvest in situ a tissue, what we call the flap, in the intercostal area. And this flap will be inserted into Matisse. Matisse is in 2 parts. The bottom part is called the scaffold to fix the tissue. And then we close with the chamber, can have different shapes and different size thanks to 3D printing. And once implanted, the tissue regenerates inside, and slowly the implant disappears, degrades into the body. After all, the patient gets back a new breast with its own tissue naturally. The company was created 5 years ago. We have raised already 10 million euros to achieve very big milestones. The first one was to prove the efficiency into in vivo animal studies. Here, in this example, you have the Matisse implanted black dots, and we follow the regeneration with MRI. And you see in this example, only 90 days to regenerate the tissue inside. And we run a very long-term study during 2 years. And the full size is reached between 3 to 6 months. We pass with our process the whole biocompatibility to prove that the process, the material, the product is safe. And we have created a printing farm to produce, so we produce from the biomaterials to the end-use sterilized product. With this factory, we use very common printers, Ultimaker systems, but we have run all qualification and validation process following the ISO guidelines. And we produce the filament and the product. And finally, everything leads to the possibility to start the first in human. We have implanted the first patient this year. She's really well. She's happy about her reconstruction, and we are really happy about her. And just to finish, wow, it's not the colors. We raised a Series A recently to cover the clinical trials in 8 centers in Europe, involving 50 patients. We are assessing the FDA to do the same in US. And we have a plan to mount an industry, so to scale up into an industrial scale, start the clinical trials in US and commercialize in Europe in 2026 after the clinical trials. Thank you very much. We have a booth in the B81 Hall 12. Thank you.
Very impressive, Julian. Thank you so much. Really a pleasure. Are there any questions from the audience before I ask my question? There's one, please.
No, it depends on the size.
Can you repeat the question for the...
how long it takes to build the product. Depending on the size, it goes from 15 hours to 30 hours. And the idea for the production system is to have 200 printers like this.
My question would be, Julian, how difficult was it to overcome the medical regulation? Because this is normally something that is really a big hurdle if you want to come up with such a product.
You have to apply the rules. The rules in Europe are moving, and it's really hard. And a lot of companies in medical area are going into US. So we have to follow the rules, but find the right place. In the development, you need to be innovative, but not too much. If it's too much innovative, it's too long and too difficult, too expensive. And you have to not forget that it's for surgeon, it's for patient. It needs to be surgically affordable and also in terms of price.
Awesome. That was, by the way, a good tip for other startups in this sector. Thank you very much, Julian. Great applause for you.
Thank you.
Winner of the Startup Challenge and the AM Ventures Impact Award. We will see you later at the award ceremony. Thank you so much. Great. So some of you already know them from the AMTC 2022 in Munich, where they won participation in the Pitchnext event with a very good pitch, in my opinion. Faster, higher, stronger. Join me in welcoming Fortius Metals and their CEO, Jeff Lynch. Jeff, good to have you back.
Fortius, the name comes from Citius Altius Fortius, the old Olympic motto for faster, higher, and stronger. Hello, I'm Jeff Lynch, CEO and founder, Fortius Metals, based in Boulder, Colorado. We sell wire and we sell parts. So we have our own wire factory, and we also have 2 robotic cells capable of manufacturing large parts, one in arc welding and one in laser welding. So we think that large format metal 3D printing is the next big wave. You can see on the right there this video from a company called Relativity Space, which has fantastic marketing showing what our industry can do. That's about a 3-meter diameter tank being printed. In addition to the traditional benefits of 3D printing, like more complex shapes, reduced part count, we think big parts are a big deal because of radically reduced lead times. So if you're making a big part using traditional fabrication techniques, you're looking at 18 to 24 months lead time with custom suppliers and very expensive tooling. We can do this in just a few weeks with 3D printing. What makes Fortius Metals different is our metallurgy. We weld the unweldable. In the top, you see an image of an aluminum weld. This is 6061, which traditionally cracks and is unweldable. We solve that problem, and in addition, our welds, our materials, are often stronger, sometimes twice as strong as the wrought equivalent. So this is an example. We control that through metallurgy. On the left, you see what's typical, the long, skinny grains that are, have a tendency to crack. We solve that by adding grain inoculants or refiners, which we'll call pixie dust for today's conversation. That creates massive grain nucleation, creating fine, equiax grains which add strength. And any leftover pixie dust precipitates out, further inhibiting cracks. Fortius Metals, we believe we have to solve the whole customer problem. That means in addition to our advanced alloys in nickels, titaniums, aluminums, we're also process experts, both in arc and laser, and we support electron beam as well. We also help our customers design for additive, and we help solve for distortion control. So our company, our technology has already been commercialized in the market. Fortius Metals spun out of another successful company called Elementum 3D, who's been selling these alloys in powder form for powder bed fusion. Elementum focuses on powder, Fortius focuses on wire. It's a great collaboration. We already have a range of great customers because of that heritage. And then in addition to 3D printing, our welding wire can drop into any factory with traditional welding. That's a big deal because we think we can help things like electric vehicles. Stronger welds means lighter frames and lighter chassis, which means extended range for EVs. So thank you. I look forward to your questions.
Awesome, Jeff. I know I can rely on you what the timing concerns. Awesome presentation. Any questions from the audience? There's one. Can we repeat the question?
Yeah, the question is, how much funding are we looking for? So we're just about to close our seed round, and I'm probably looking at a Series A in 2024. And hopefully that gives us enough time to get traction to have a very large round.
Very good. Any more questions here from the audience or from you at home? If not, let me ask one quick question. I mean, we are talking about the automotive industry, especially EV. How far is that away? Because I'm from automotive industry, I'm interested, when can we use your wires in automotive production?
So materials businesses are fantastic and a little bit challenging because things take time. So we have a very, I think, sober view that we need to start today to get these into our automobiles in 5 and 10 years. The first adopters are often commercial space. They're going to market now. And to get human transport and all the testing and all the qualification, we're starting now to make those vehicles safe for the next platforms.
Very good. So there's one question from the online audience. What is in the dust?
So that's our proprietary technology, essentially ceramic grain inoculants that have an in situ reaction. And I would love to talk further about that offline because we don't have enough time here. Upstairs in booth D54, we're hanging out the Elementum 3D booth today.
Visit Jeff there. Jeff, thank you so much.
Thank you.
Great having you. So one of my favorite topics, to be honest, is circularity, and it's undeniably one of the most exciting topics of today. Rudolf, Jonas, and Jörn think so too. They are tackling the issue with a recycling fabrik, and Rudolf tells us how. Rudolf, please, stage is yours.
"3D printing and plastic waste." Together with Jörn and Jonas, I found the Recycling Fabrik to create circular economy in 3D printing processes. Because plastic waste is one of the largest problems in our world, even in 3D printing. We identified the problem that even in 3D printing, old prototypes, misprints, and so on are mixed up with most common waste and is getting burned anywhere. We developed a solution, a circular economy, to collect this 3D printing waste directly from customers and 3D printing users. We have a regranulation and post-processing that guarantees high-quality granulate that you can use in our extrusion again to get high-quality filament that is ready for new 3D printing. For companies, we developed special services. When you have larger amounts of waste, it is possible to get back your own material as recycled filament or granulate for your own 3D printing. Also, when you are in prototyping like medical development, we can guarantee data protection compliant recycling. So there's a priority in process. And all this without any waste disposal costs. We pay and organize the shipping. So it's free waste management. And for all this, we need you to get 3D printing more sustainable, to get corporations. So stay connected and find us in Hall 12-1, booth 101E. Thank you very much.
Awesome, Rudolf. Applause. I have one too, to be honest. How is that financed?
It's quite good.
Now, where do you make your money with? That would be my question.
We make our money because with the whole process. So we do everything by our own. We have the machines for grinding, for granulating, for extruding. So nothing is outsourced. So we have our hands on the quality and the control of the material.
So finally, you get the waste. Let's say I have a company, I give you my plastic waste from my prototyping. You reuse it, by the way, and then you sell it back or you sell it to another customer with your new filament, right?
Yes, and even when you are sending us waste, you will get a reward from us. When it's sorted by material type, you will get some points that you can use in our online shop as a discount. So you can save up to 25%.
Bringing us to the next question, sorry, I don't forget the question of you. There's one online question which I really like. How do you deal with a change in polymer properties after each melting and cooling process? And can you ensure that the material is good enough to be used again?
That's quite a good question. So we have quite large material batches, like 300 to 400 kilograms. And we say to our customer they have to sort by material type. Due to the high waste stream that is growing every month and every time, we never well, it's not that common that we get back the same material and recycling the same material. And we have some kind of homogenization. And due to this, it's quite common that we get the same properties of the material every time. And we can test this with some material tests.
Very good. Then we take your question. So just to repeat the question for the audience.
Yes.
So is it more expensive to recycle? Yeah.
When I just want to make money, I will produce new filament. But that was not the goal. The goal was to create a sustainable alternative to new material. And due to this, even the material is not that high price, because we said it should be a product that everyone has a real alternative to buy new or recycled material.
Awesome. Thank you so much, Rudolf. It was a pleasure to have you here. They can visit you at your booth and go into circularity. I really appreciate that. Thank you so much. So they had been winner of last year's Startup Challenge, and that makes it even more interesting as we can see their progress. Please welcome Azul3D, represented by David Woodlock, Head of Growth. David, what have you brought us with you? I see. Oops.
Hi, everyone. I did not present last year, so it doesn't count as a second try. My name is David Woodlock. I've been in the industry since about 2016, the first 6 of those years at HP, bringing production applications to market. I moved over to Azul3D because I saw an opportunity here to move printing into new levels of throughput from a first principles level that are tied to physics. So about 6 or 7 years ago, there was this huge step change in the industry. And that was kind of a move from point-based processes to area-based processes. You saw that on the thermoset side with resins, and you saw that on the thermoplastic side. This was SLA getting really disrupted in a lot of industries by DLP, DLS, carbon, et cetera. And SLS really getting challenged by HP, multi-jet fusion, and some of these new high-speed sintering processes. And the reason to go point-based to area-based, higher throughput, but also consistency of mechanical properties throughout a layer as you get better fusing, entanglement within that single layer. But you start to run into physics. You're printing so fast, you're just dumping energy into the system continuously. And that starts to become the limiter of your throughput. It's like running injection molding without cooling lines. You're slowing down because you have to wait for heat to naturally dissipate out of the system. So it doesn't matter how fast you can print because you're putting too much energy in without taking any energy out. And there's a few rules of physics in there. What we're doing is we think we're targeting a brand new space in the whole 3D printing ecosystem by being able to actively remove heat from this system. So while DLP can go really fast, it's fundamentally limited in scale. And while laser systems can go really large, they're fundamentally limited in speed by being a point-based system. We're trying to go after this fourth box where we can take the best advantages of both of those into a new architecture. And this is the fundamental invention that drove the formation of the company. And what you're seeing here is a layer of oil that sits above the projector membrane that continuously flows across that membrane. And it does a few things, but the one I'm going to highlight here is it continuously pulls heat out of the system. So we're no longer fundamentally limited by the amount of energy that we're putting into the system. That means we can now print at speeds not limited by keeping a stable thermal experience of the plastic. So projectors, membrane, layer of oil, resin sits on top of it, we're able to pull parts without influencing that oil. So as you can see here, what we're doing is we hit a stable bed temperature at much higher speeds for much taller builds without increasing the heat. At the top, you can see a printer with no oil. You can see a printer with moving oil. And then you can see moving oil with cooling to that oil. We're refrigerating it on the outside of the printer. And this is what's going to allow us to do high throughput, really fast, really tall builds with the consistency of mechanical properties and other surface finish, dimensional accuracy, things that are going to be required into production applications that would take advantage of the speed. The other thing that we're doing is we've developed a material strategy to take advantage of this architecture. And so we specialize in low viscosity resins. When you take that liquid-liquid interface and you add on low viscosity resins, we can actually refill material under the part fast enough that we pull continuously. We do not turn off the servos. We do not turn off the projectors. This is great for speed, but it's great for better mechanical properties because there's no longer any layers. Truly no longer any layers. You get full entanglement layer to layer across all of the parts because of that continuous pull. We do custom materials, again, targeting production applications, knowing people have different requirements. We formulate materials specifically for your need to be able to take advantage of our system. First public customer, Wilson, taking over the pickleball world, which is the fastest growing sport of all time in the United States. Thank you.
Thank you so much. Great presentation. Questions from the audience? There's one. Can we repeat the question quickly? Sorry.
Yeah, what's the business model, and do we sell printers or do we contract manufacture? We lease printers and we sell material. We will do some part production as needed to get the business off the ground and get parts in people's hands, but it's not the end business model.
Thank you so much. Any more questions? Then thank you so much for being here. Applause, please. So I hope you have enough energy left because we are now coming to our last session where we come to startups from the areas of software and services. We are going to start with 3D Spark, and they want to answer quickly the question, which component can be printed? Ruben Moyd, co-founder and CEO, will guide us through the topic. Ruben, the mic is yours. Please.
Thank you very much. Hi, everybody. I'm Ruben Moyd, one of the co-founders of 3D Spark. And when it comes to the adoption of 3D printing, unfortunately, my presentation was not changed. Can we switch to another presentation and I switch the presentation? Is that possible? It's not possible? That's quite different. Okay. So when it comes to the adoption of 3D printing, we see different challenges. Number one, with 3D printing service providers, like MedShape, actually, a great company. Go check them out here. Their head of sales says costing, quoting is a big challenge, very annoying and time-consuming for them. And why is that? Because every morning he opens his inbox and has a lot of RFQs, so requests for quotations. That's exactly what he wants. It's great. But it means a lot of manual analysis. So forwarding CAD files, drawings to his technology experts. They check for printability, so feature sizes, distortion, for example, and feedback that information, as well as some metadata, some information they get from the CAD files, like bounding box, volume, and then he feeds that into his Excel tool to do the quoting. So that process works. It's, however, a bit lengthy, involves a lot of tools, and it doesn't scale. That's one problem. Next one is with larger OEMs, like Alstom, for example, world-leading manufacturer of trains, like TGV, and they set themselves the goal to reduce cost and lead time on a global basis. And they identified 3D printing actually to be one good solution for that. And in charge of that is Orion Fussell, 3D printing program manager. And he quickly realized that to meet those high set targets, he needed to get as many people as possible, as many employees as possible, of 75,000 employees, involved in the process in 3D printing. And once he started doing that, a lot of questions started pouring in, like, is my part printable? What's the best process? What's the best material? And obviously, how much will it cost? And so just far too many requests. And on the other side, management always asking on a monthly basis, what is the current status of the project? Are we saving costs? How much cost are we saving? How much lead time are we saving? And so it became very quickly clear that a software was needed to answer for all these requests. And that's why we created 3D Spark, the comparison engine for components. And what you drop in is CAD files, drawings, metadata, and what you receive is printability checks, instant costing, process comparison, and soon a CO2 footprint calculation. And that to give a transparent basis for decision making, right? And we're very happy that Alstom, for example, has saved 1.8 million euros in cost and more than 20,000 days of lead time with the help of 3D Spark. And I'm not sure if there's a... Also, that slide is missing.
That's the best way to do it, honestly. Awesome. Still an awesome presentation, believe me. I think we got the point. So you mentioned Alstom. Are there any customers or applications where your software already helped in finding the right parts to print?
Yeah, so in this case, the railway industry, we identified more than 600 validated use cases. Again, they were printed with various different technologies, and with that we were able to save these 1.8 million euros in cost. And on the other side, the service or the manufacturing service providers, they do their quoting with our software.
So if you mention an railway, are you then rather focusing Deutsche Bahn, for example, or the producers of trains?
Both. More the producers, but I may say Deutsche Bahn is also a customer of ours, actually. And they also use our software because they do both, actually. They do sourcing, so we help with the sourcing, make or buy decision, for example. But also they produce themselves since recently. They have their own printers, so they also need to do their own quoting, actually.
Great, great presentation. Any questions from the audience? If not, I say thank you so much. It was very spontaneous and still very good. Thank you so much. Ruben. Quality assurance remains eminently important, especially in 3D printing. We heard a lot about this already today. And the whole thing is developing quite rapidly. Fully automated, retrofittable, and remotely controllable is what many companies want. Additive Assurance is tackling the issue and presenting its solution here at Formnext, and more importantly, here at the Pitchnext event. It's a pleasure to have you here. Welcome, Martin Jung, CEO of Additive Assurance. Martin, please.
Thank you very much, and good afternoon, everyone. My name is Martin Jung. I'm one of the co-founders of Additive Assurance, and we provide quality assurance for laser powder bed fusion. Now, laser powder bed fusion is rapidly moving from a case where it was printing individual parts and prototypes into a case where you're making many of the same part in batch or serial production. As an industry, this is incredibly exciting that we're at this tipping point now after these many, many years of production and development. But the difficulty now becomes, how do you identify the non-conformancies inside a batch? The methods of quality assurance for additive manufacturing are still somewhat limited by our traditional techniques of inspection. So this is what we're working on directly. Apologies, there's been a bit of a formatting issue here by the looks of it. But in situ monitoring enables us to unlock the value of additive manufacturing through inspecting every layer, layer by layer, to identify any anomalies that occur in your parts. The benefit here is that if you can do this across a series of parts, you can quickly establish metrics that enables you to determine quality specifications for your entire production series. And this is really unlocking that next stage of capability. We've developed a proprietary methodology that is a long exposure-based technique that's both data efficient and also very fast to analyze these parts and results. So how do we do that? We've developed a sensor package, analytics suite, and a methodology to deliver this back to the customer. So it's an all-in-one encompassing package that we sell as a subscription service to the end user. It's on the market today, by the way. So how we do this, we have a retrofittable sensor package you can see on the left there. This enables you to capture detail of the process down to the micron level, greater than 30 microns per pixel across the entire powder bed. That enables you to identify those small anomalies in that laser powder bed fusion process that is so critical to establishing quality specifications. On top of this, we've developed machine learning-based algorithms to identify those fluctuations and categorize them in terms of the type of defect that may be occurring inside your part. And finally, we developed a cloud-based platform, to identify and deliver these indications back to the user so that you can do so with confidence and deliver this to a production floor without having PhDs running the machines, which has been previously quite common. So our optical-based methodology, it's a long exposure-based technique and can be mounted externally or internally. We're working with a few OEMs to do this internally currently. This external mounted system, though, can be applied to any of the major vendors that are currently on the market today. So come and speak to us later if you want to learn more about this. The other benefit is that it is agnostic to the number of lasers and has no impact at all on your machine warranty. I'll leave it there for now, but I encourage you to come and visit us over at Hall 12, where we can dive into more detail about how you can actually use process monitoring to establish that confidence across all of the parts. I'd like to encourage you to come over to Hall 12, Level B. Thanks.
Thank you so much. Awesome. Okie dokie. I'm really excited about the next presenter because it's very similar, at least. Welcome. Finding anomalies in the early stage of printing is one of additive monitoring. You are now called Phase 3D. You just renamed, I heard that.
Yes, that's right.
That's why you have this cool jacket, by the way.
Thank you.
Looks awesome, yeah. You are Niall O'Dowd. Is that correctly pronounced?
Yes.
Yeah, is Irish or what is it?
Yeah, it's Irish, yeah.
What is the correct pronunciation?
My name's Niall O'Dowd.
Okay, great. So you explain us how it works. Please, stage is yours.
Yeah, good afternoon, everyone. Thanks for attending. Excited to share some information. My name's Dr. Niall O'Dowd. I'm the CEO and founder of Phase 3D, and we're doing in-situ monitoring for additive manufacturing. So, as I bet we can all agree, I believe AM can really dominate complex manufacturing. It's an awesome platform for part repair, weight and cost savings, as well as building complex, impossible to manufacture parts just several decades ago. But there are several hindrances preventing even wider scale adoption of metal powder bed fusion and other metal AM processes. The part rejection costs, lengthy and costly post-inspection and post-processing can hold back adoption for aerospace components or automotive components that need to be produced fast and efficiently. Certification and qualification can be impossible in large, dense parts that can't be non-destructively tested. But I believe in-situ monitoring can solve these problems. For example, using an in-situ monitoring solution, we can find process anomalies and part defects during the process, which mitigates a lot of the cost and pain felt from part rejection. Also, because we can inspect the part as it's being made, it doesn't matter how large the part is or how dense the part is if we have access to those internal surfaces. So Phase 3D has invented an in-process monitoring system called Project Fringe, which can attach to any powder-based AM printer, detect defects throughout the printing process in every layer, and it allows users to plan strategically with real units. What makes us special is that we do layer inspection with real units, height mapping, so that users can define thresholds and statistical uncertainty without use of a black box or AI, ML interpretation. So we're able to collect objective data during the printing process. Our data set is much smaller because we know the nominal condition using our height-based thresholding and signal processing. And we're also able to simply retrofit any printer just outside the build chamber to not impact warranty or any kind of gas flow or process parameters. This philosophy has really seen a lot of recent traction. We've been selected to do production environment development for the US Air Force, as well as funded by the Advanced Manufacturing Office in the US, as well as a collaboration with NASA Marshall Space Flight Center, where we're working on certification and qualification for their liquid engine printing process. I'd also like to announce the early adopter program. In January, we're starting a 6-month program where we're looking for contract manufacturers to test and benchmark our system under a data sharing contract where we can reduce a lot of the license fees. Really excited about this program, and I encourage those of you who print parts and want to limit part rejection and improve certification processes to come reach out. We're exhibiting in Hall 12 downstairs.
What a timing. Thank you so much. Excellent presentation. Are there any questions from the audience? There's one, please.
Yeah. So the measurement is done during after the powder coating. So we look for defects like recoder streaks, hopping, short feeds, and then we do the measurement again after the melting or the sintering, looking for protrusions, hash spacing defects, spatter particles that combine and land on the part. So that two-stage process allows us to look for powder-based defects as well as the melted layer defects, and look between the difference in height between the powder layer and the melted layer to look for any kind of solidification, anomalies that may contribute to lack of fusion or keyhole porosity.
Awesome. Niall, thank you so much for being here. Faith 3D, very excellent name. Good luck and very much success. And for any other questions, please join them at their booth. Thank you so much. Niall.
Thanks, everyone.
If we are talking about online demand printing, it's one of the great advantages of additive manufacturing. But at the same time, it requires a lot of time and resources to offer the service. This is where Marklix wants to help and offers a software as a service solution for this. Pierre-Jacques Lyon, I hope I put that correctly, CEO, will show us what is included in the solution. Please.
Thank you. So hi everyone, my name is Pierre-Jacques Lyon, and I am the co-founder and CEO of Marklix. And with Marklix, we are building a coating and planning solution. So our soft is completely white branded, so a service bureau can use it to take orders online. And some of them integrate it directly on their website. So they can allow their customer to upload 3D files and get a direct price and pay for their parts. So you can put a part, get a first test to test printability. Then you can pay, or you can also ask for an invoice if the service bureau don't want to show their prices. The pricing method we use is completely custom, so it's the pricing method of the services. We don't force the pricing method. That's something very important. And to do so, we integrate in the software a slicer, a nesting tool, and everything that is needed for the service bureau to do so. We are also working hard on a planning module that it's a second step after getting orders from clients. It's to manage the production, and some clients want also to know where the parts are, if the part is already produced or shipped, etc. We are a startup based in Aix-en-Provence, in south of France. And I co-founded this company with Thomas Boulier, that is actually the CTO of Marklix. We are followed and trusted by Bracken Darrell, that is Logitech's CEO since the beginning of the company. And we've launched this first product of quoting in May this year. And we already have clients in Spain, France, Belgium, and also India. So we have a real traction and interest for our software. We are also some partners like IBM. We are reseller of IBM, so we can do on-premise also, and complex cloud integrations. And with the Access Orcas that have a security solution directly integrated into our software. So today we are focused on additive manufacturing. That's why we are here. And next step for us, it's also to do the same thing with traditional processes like machining or metal sheet work. Many thanks.
Thank you so much, also for the timing. There's a question from the audience, and please be so kind and repeat the questions for the online audience.
So the question is if we have a fee on the pricing or only a subscription. So it's only a subscription. It could be monthly or annual, and we adapt. We have different packs depending on the customer and the needs.
What would be interesting for me, what is your competition actually on the market? Are there other software suppliers that offering the same solution or pretty much?
Yeah, we have some competitors. For example, 3Omine, MFG, or Digifabster. What differentiates us from us is, first, we are moving to other technologies. For the moment, only Digifabster is doing the same thing, but Digifabster is not integrating a planning module. And also, I can't tell, but the best thing to do is to try every solution, and some clients are more happy with these competitors, others with us, depending on the interface and the user experience and some secret sauce we can have.
And you have showed in your presentation what would be the next steps. You're working on the production planner, for example. What do you need as a startup right now in order to proceed?
Mostly funds, because it's always running after time to develop everything. We have an amazing team of PhDs and engineers, but we need time also to discuss with the customers and to build the products they want and not only what we want.
Very good. Excellent. Thank you so much.
Thank
Big
you.
applause for you.
Goodbye.
So if it comes to parts identification, this is one of the key challenges, and this often suffers from insufficient digitization. Select AM offers a software solution here to identify as many parts as possible at once. And Niklas Kretschmer, CEO and co-founder, introduces us to this topic. Niklas, stage is yours.
Yeah, thanks so much. So I'm Niklas Kretschmer. I'm the co-founder and the CEO of Select AM. So as mentioned, we focus on part identification, meaning finding the best business cases for additive manufacturing to really unlock the full potential of additive manufacturing. What we do is described here. So we provide, in the end, we provide information to companies on which parts to focus on. So taking a lot of data from those companies screening down the data, and then handing over the data to OMS systems to get it finally printed. What is the problem of it? I mean, there's a lot of lost potential that we see because a proper part identification approach is not in place. You see 4 examples here. So often when we come to companies, we see that the data is not fully digitized. So often you don't have a CAD model or there's not all relevant information available. Secondly, the non-accessibility of AM in companies. So it's not linked to services or they don't have their own printers in place. So we can also fix that. Knowledge gaps related to additive manufacturing. Not in every organization you have a great knowledge in there, and our software can really support you in providing necessary knowledge because we default the software is data and also process agnostic. And also today the high cost when identifying parts. So today it's done really manually. You see an example here. So often a single part is uploaded to a platform with certain materials and machines, and then you get the feedback that this part is not printable. Then you get to go to another platform and so on. So that's really time consuming. We can do that all automatically with many, many parts at once, giving you the best recommendations for AM to use. So what is our solution? It's shown there. We hand over a template and if available, also some CAD data. And then we crunch that data from different aspects. So technical assessment, is this part printable? From a technical side, all the technical requirements that are in there. Economically, if you have a printer in-house or you are using certain services, we can make or buy decision making there for each component and see if that's interesting. Then also from the redesign point of view, is it feasible to start a redesign process? Is it interesting to go into topology optimization or not? And finally, the supply chain assessment. So is that a problematic part from the supply chain? And we will figure out for you if it's from that point of view interesting as well. And then once you did that assessment for many, many components, then finally we connect you to an OMS system, and then you will get your parts printed and get all those benefits that are out there in additive manufacturing. So we just launched a software basically 2 months ago. There's a free trial you can use for 500 components to test it for. And as you can see, here's some economic assessments. So make a buy decision making on the upper right, and down there it goes also into redesign. So we visualize the potential redesign potential of your part, and then you can, and then a designer can grab it from there and start the actual topology optimization process. So what is our mission? What is the vision after all? I mean, there's so many components out there that haven't been screened yet for additive manufacturing, and we have really a tool in place that can take 100,000 components, crunch them for different AM processes, different materials, and then we tell you which ones to focus on. So that is what we do. Because today, the adoption is still very poor, roughly 2.2%, and there's so much more potential with additive manufacturing. We are moving towards an AI, so this whole thing gonna be fully automated and smarter than what it is today. And in the end, we will connect that system to ERP systems and later on to more OMS systems. Thank you.
Great, thank you so much. There's a question. So what is the go-to-market strategy of Select AM?
Yes, so as you can see, we have this free trial option. So everyone who's willing to test the product can do that. And also we're evaluating to work with resellers, software resellers, that they will resell our product. So those are the main approaches. And of course, I mean, first time for us to be present at a trade show, also to get out there and to talk to a wider audience.
So that would lead to my question. What is currently your target group on the first step? I mean, of course, you're looking for trial users, but I'd rather bigger companies, smaller companies. What kind of companies are looking for such a solution?
Yes, so right now we have a handful of paying customers out there, and that's mostly really large companies, OEMs, with sometimes millions of components. And then what we see is also larger AM services, so those which are printing the parts. And finally, this is also interesting for redesign bureaus.
Very good. Awesome. Thank you so much. Any more questions? If not, they can visit, of course, you Select AM at your booth. Thank you so much for being with us. Big applause for you.
Thanks.
Great to see you. Bye. So, coming to the next winner of the Startup Challenge, they tackle the issue of post-processing in metal additive manufacturing, and their solution is to reduce errors, risks, and costs. The CEO of Rivelin Robotics, I hope I put it correctly, introduces us how to do it. Welcome to the stage, Robert Busch, CEO of Rivelin Robotics. Please, welcome, and congratulations.
Thank you. Guten Tag. This year, Rivelin launched net-shaped robots. Net-shaped robots are for metal and for post-processing. Rivelin is the first company to fully integrate all of the post-processing steps. If you don't want the expense of a bandsaw or an EDM, you can get a Rivelin robot. If you don't want loads of guys moving supports, or you don't want to spend months of making reliable, consistent support for your builds, you can get a Rivelin robot. If you don't want a measurement step at the end of the line, but you want one in the line, you can get a Rivelin robot. And if you don't want batch finishing, but you'd rather targeted finishing for things like thermal insulation, flow efficiency, and fatigue, you can get a Rivelin robot. If you want to see it in action, you can check out our website, our homepage, rivelinrobotics.com. There's a video on the homepage. Essentially, our robots take a powder bed fusion part, for example, with supports on the platform, to a finished state. Automated, reliable, repeatable. And that's because Rivelin's robots cope with variability. There's 3 star cases. All are different, but one final output. We use a combination of machine learning and traditional deterministic control theory to achieve this. And it's important to stress that Rivelin NetShape doesn't need CNC programmers, and it doesn't need specialist robot programmers. You fixture it, and you hit the go button. Anyone can program. It's that simple. And this is what differentiates us from traditional casting automation. It's the lack of needing a predefined toolpath or a specialist robot programmer. So we get the repeatability of casting automation, but we get the flexibility of manual labor. So you can deploy robots faster and easier than ever before. Our secret weapon is our team. Ian Halliday has been a pioneer in additive for 30 years, and then the 2 Davids come from Rolls-Royce additive manufacturing and Rolls-Royce robotics, respectively. So why have the likes of GKN Aerospace, Oerlikon, and the Ministry of Defense invested in the support removal and targeted finishing solution from Rivelin Robotics? Well, they understand the pressing need to incorporate metal additive on their production lines, while also overcoming the challenges of post-processing by hand, such as lack of traceability, a lack of repeatability, spiraling costs, limited manpower, and risk to personnel. So keep calm and let a robot do it. Thank you.
Awesome. Thank you so much. I'm always keen on getting to know applications. So is there already an application in place where you implemented your system?
Yes. So at the moment, the customers that I spoke about, we're doing process validations. So they have particular parts, challenges. They tend to be support removal and finishing. And normally for scalability challenges, they can't get the personnel, or quality issues, or sometimes even cost. And we're going through those work packages, trying to prove that our system does in fact deliver what we say it does. And the outcome, if we succeed with all of them, is a deployment of a robot onto their line. Of the ones I said, Oerlikon, GKN, and Ministry of Defense, 2 of them are targeted for next year, if we go well, and the 3rd one for 2024.
What about the robot? Is that something you co-develop, or is that something you work with the common robot producer together?
This is a good question because lots of people ask this. Yeah, the robot is Japanese, Yaskawa.
Yeah.
We don't develop the robot. Our main, let's say, addition is the software. It's being able to control the sensors in closed loop and being able to program without actually needing to program. So just giving recipe steps.
So, and let me ask another question because I'm highly interested. So is there, like, if a company has already corresponding robots? Do they need to buy the robot you are recommending, or is your software working with any robot out there?
We're providing a solution. So we sell our solution with a Yaskawa.
Okay.
It's not tied to Yaskawa. We could use a Fanuc, an ABB, a KUKA.
Yeah.
But we're selling a solution, and so we like to partner with companies like Saint-Gobain, Yaskawa, because we can provide a better solution that way.
Very good.
So
Sorry
yes.
that I was asking all the questions, but it was super exciting. Thank you so much. Any questions from the audience? If not, I say thank you. See you later at the award ceremony, and it was great to have you here. Thank you so much. Big applause. So maximizing AM performance is the goal of Magnitude Innovations with their software as a service solution. If you look at their partnerships, in my opinion, they have already convinced important market players. I'm curious to see if they can do the same today with you here in the audience. And Matt Tusch, who is founder and CEO, will try to do that. And I'm quite excited to see what kind of solution you brought with us. Matt, stage is yours.
Hello. Yeah. For the record, this is the first time I'm ever doing this.
Okay. Go ahead.
So there's a lot of pressure. Is the
thing
gonna
can
go
just
on?
go ahead.
No pressure. So hi. So my name is Matt. I'm the founder of Magnitude Innovations. We have a software, Optimal, which is not loading. So I'm just going to freeball it. So
click. You have to click.
Oh, do I?
Yeah.
Oh, sorry.
Easy.
So I get another 10 seconds for that. So what we've done is we've created the first and only actually operational excellence software for metal additive. To date, we've raised over 330,000 euros through investments and grants, as well as we've been bootstrapping the rest of the way in terms of doing consulting for the industry because we have a lot of experience with that. So the team, the core team, are the three people here. I've been in the industry personally for 10 years. I've worked at NASA, EOS, with Siemens as well. And we founded the company 6 years ago, and we've been working on the software for 4 years now. So that there's a lot of work that goes into that. And we have a pretty awesome team that advises us, including people from the industry. And yeah, and so the problem that we're trying to solve is, and this is something that most people don't believe us about, is that the efficiency of metal systems is less than 50%. And it's a huge problem, obviously, because if you look at any other industry where something is used for manufacturing, 40% efficiency is quite ridiculous. For 10 systems, that's about $2 million that are lost every year. And you're probably not believing me and asking yourself, why hasn't anybody else addressed this? Well, number one, because they don't know. There is no other way. There's nobody else that has actually measured the efficiency of production in metal AM. And for the most part, while we were doing this, people thought it was impossible. So our solution focuses on this idea that you're trying to run a system 24/7 at the perfect speed with perfect output. In each one of those dimensions, there's huge problems that lead to this kind of a reality, right? And so there's a lot of variables that go into this, and it's not that people are not competent to do this. The problem is they don't have the time. So what our solution does is it quantifies the efficiency of your production. It automates all these tasks that you have to spend on every day trying to figure out what is the strategy for today, what are we building, how are we going to optimize it, and then without requiring any tribal knowledge, doubles the productivity of your systems and also saves you a lot of time. So some of the key highlights are that like project managers save about 20 hours a week in terms of all the analysis that they have to do. Machine operators save about 5 hours. The team, in terms of review meetings, saves about 30 hours a week. And we've reduced inventory costs by about 1.5 million. And again, this is an example of 10 machine systems, or 10 machines running in production. So with regards to other companies that are in this space, we focus exclusively on operational excellence, not MES, not ERP. And then with regards to that, we have a huge advantage. But also from other companies that focus on OEE or efficiency, they're not in the industry. And so their solutions are very superficial, right? And you need a lot of knowledge in the industry in order to get to that conclusion of what to do. So with regards to the industry, we're focusing on having 1.2 million in annual recurring revenue by 2024. And obviously, the market is huge and it's growing. So I think there's a really great potential for that. And yeah, going to take your questions. I'll cut everything else short.
Awesome. Awesome. Thank you so much.
Thank you.
What is your Yeah, big applause. Worth it, definitely, definitely. What is the payment model you have right now?
I skipped that slide, but what we do in essence is...
Sorry for that.
No, that's totally fine. What we do in essence is we charge a minimum amount because of the fact that it's not just software, right? We're not just delivering you software and then we're going home. We actually go into the factory and help you implement operational excellence, which is a huge process, right? You have change management consultants for this. And so that's the other half of our team, which actually goes into the factory and helps you every week, every month, for the first year, to actually analyze what's going on and to save you that time so that then you can actually do your job better. In other words, delivering products to your customers, and then actually have the time to work on everything in more peace, right?
So there's a high part of consultation already also included, right?
In the beginning, yeah.
In the beginning, and the next thing would be, wouldn't it then be possible to like get a ratio of the savings, for example, as a payment?
Well, that's the thing, right? Like we're actually tracking efficiency, so we can tell you exactly what it is, and we've actually discussed that with our customers. Yes.
Great, great. Sorry, that were my questions.
That's a really good point.
Yeah. Any question? There's one from the audience, and please repeat it if possible.
Yeah, so I've been in the industry for 10 years now. I've only focused on metal. And if you say that you're going to focus on all these other things, you're lying. Because it's very complicated, right? There's a lot of things that you got to figure out. And so consciously, we don't do that right now, right? Like, once we have a team of 50 people, absolutely. We already have the algorithms figured out. We've already been discussing with people that are on the polymer side. But we're not doing that because we want to deliver good value to our customers, right? And that takes a lot of hand-holding to get them into that step, and just speaking from experience.
Awesome. Thank you so much, mate. This wasn't never the first time. It was awesome. Thank you so much. And yeah, you can visit them at their booth. Thank you so much, and a lot of success for
and you will get limoncello if you give us feedback.
That sounds good.
I think that's a good sell, right?
Yeah, absolutely. Thank you so much. So, I remember the pitch last year very well, so I'm excited to see how their approach has evolved. Did you know that you can deduce quality based on sounds? It's still amazing, sorry. Still unbelievable for me. For Automation Acoustics and its CEO, Anthony Lele, it's a product. Anthony, let's share your idea with us.
Thank you very much.
I'm excited.
Well, it's great to be here again, as I said, from last year. So we've had a lot of progress from what we're doing. Acoustics, anomaly detection. It's quite simple, but very complex when you get into it. The human brain is incredibly good at saying, I know what that sound is, when you're trying to train algorithms to look for that, identify that, and diagnose it, and then provide that in real time. We're talking about a whole new complexity. So this is what we do. We listen to the sound of your process. Just like a really good operator knows when something doesn't sound right, we do that with software. So because every sound creates, well, every process unique sound, a new feature, and you can associate that with a problem, that's what we focus in. We focus on these technologies of thermal spray, cold spray, laser-based direct energy deposition, both in powder and wire, and a lot of wire additive arc. Because as I mentioned earlier, these are the areas where those skilled operators often are listening up to the wall, they're listening to the sounds, they're trying to understand and pick up those nuances so that they can adjust. And that's what we focus on. But where these processes tend to exist now are in these closed rooms. They're very loud and you can't work within those spaces. They've got lasers and they've got dangerous powders. So getting that operator to get really close and understand what's going on is getting harder to do. So trying to create, again, that idea of what the human person is doing and building that story and understanding into data that's valuable and actionable is what we focus on. So we're a piece of the puzzle. Acoustics isn't to replace everything, it's a piece of the puzzle. It's part of the information set, just like we look and we smell and we hear and we do all these things, we even feel the machines we work with. Acoustics is part of that, and it's often regarded as the missing piece of Industry 4.0. So we look for different things associated with things like feedstock and consumables, when things are wearing out, and machine condition. These have been a really interesting thing that we've been focused on, but everyone thinks the process is good, but sometimes the machines start to drift as well. Well, what do? We use it in a way that allows for decision making, and we use a lot of AI-based techniques, machine learning, etc., to do that, but filtering out things, extracting out the things of relevance, comparing it against what you want it to be, that's really what we do. But being able to bring that together really quickly, but most importantly in real time, is how we do it. So a lot of people say, what do? Well, we take this sort of complex noise and we turn it into a very simple data stream. And those simple data streams are just relevant features that you want. We don't worry about the other things. What are the 2 or 3 things you really want to know? And then we present it. And this is a really interesting point because you've got to make data actionable in real time. So our operators, we create real-time graphical interfaces. And these interfaces change based purely on the acoustic features. So if you're working with an operator who doesn't quite understand what's going on, you can actually see and they can train them. They can actually start to believe and understand how that sound correlates with this process. So you're empowering, training, and getting a really good workforce to get faster at what they do. But the data, of course, still goes into the background and used for your own information. So these are typical kind of screens we use. We use our operators. They're the smartest people in the room to help train the process, train the algorithms. And that's really good. It helps with what we do. So automation acoustics, there we are. A real-time digital simulation. It's really powerful. We do for production consistency. You know what quality is. We're not determining that. We help you get it consistent for traceability and reporting purposes. All yours.
Awesome. Again, thank you so much. Anthony, big applause, please. I'm still, you know, I must admit, if you're not an expert and you hear that, it still sounds amazing for me. So I will ask the audience whether they have questions or not, because I'm not capable of asking one. Any questions from your side? It is amazing, isn't it? So please visit Anthony and his team at their booth, because I think it's worth it, and I will do probably, and try to understand it finally.
Wonderful. Thanks very much, everyone.
Thank you so much. Pleasure to have you here. So, yeah, coming to the last startup of today, and this is Christian Waldvogel, because he is founder and CEO of Sverine. I hope, and Christian, I never know, tell it for me, please, the correct pronunciation of the name of your company, Sverine. It's kind of difficult, isn't it? Yeah, okay, I tried to do it. I'm getting better and better, I tell you. So, you're working on a seemingly difficult task, at least from my point of view, reducing material usage while maintaining strength.
Or maximizing strength.
Oh, that is like somehow contradictory, but I'm looking forward to your speech. Stage is yours.
Hello, everyone. Thanks for being here. Oh.
That sounds crazy.
That doesn't look right. Well. So let me just talk to you about this orange thing that kind of like peeks out in the bottom right. That's a sample we do. The original one is to be seen at our booth. We invented a new algorithm to generate minimal surfaces, like the gyroid in a way, but adaptable to whatever you want it to be. So our algorithm creates an ideal geometry depending on the geometry that it surrounds, be it a ball or some complex thing, and adapting its density, the amount of material it contains, according to your inputs. They may come from a simulation or from a design aspect or whatever. So you can see here that you can do gradients, you can enlarge things, the density, you can make it smaller, and you can make complex shapes as the one you see in the center here, which is a satellite bracket that we developed for the European Space Agency. Now, the main difference between what we do and classical triply periodic minimal surfaces is that we have a geometry that reacts equally in all directions. It's an anisotropic material. It's an isotropic material which has properties that are scaled linearly. Take half the material, you get half the strength. The geometry does not have an influence anymore on how strong the material is, but just the amount of material that is placed by our algorithm. We have 4 products that we are launching. We have an infill service, that's a web service that takes no input, just a model. You can see the bunnies on the top right, within which we can automatically fill this structure that is maximally light and using the least material possible. We have a configurator software where you can actually build density fields that are then being translated by our cloud service into this minimal surface geometry. We have an engineering version of this software, which will launch next summer, which will allow for the integration for simulation data. And we have the generally applicable API to which everybody can grant access and create their surfaces themselves. Yeah,
that's it.
Sorry, a bit thrown off by the chaos.
You never say sorry because, I mean, sorry for that you haven't had the right presentation, but you did it quite well. So I think we got the point. Any questions from the audience? Sreen? If not, I ask a question. I mean, I have seen the nice bunnies as an example, but what are current applications that you already improved or optimized with your software? Do we have one for us that you can mention?
We did a part for a wafer inspection machine, which is about 70 centimeters large, in which we could save 42% of the weight while keeping the mechanical and vibration requirements alive.
What are the main industries you are tackling with your solution in the first place?
At the moment, we're working with high-tech industries, aerospace and medical, but this is actually something that is aimed at everybody. So we are also addressing the maker scene, as well as industries of normal. Everybody that wants to kind of start using AM could do it with our system because it is printable without supports, even in SLM. So you can print efficiently without having to choose your best orientation.
Very good, very good. Any questions from the audience so far? If not, Christian, thank you so much. Very spontaneous, very good. Thank you so much. Big applause. Yeah, let us give again our hands to all the startups for their courage and the interesting insight into work. What a marathon, right? 20 startups. I hope you enjoyed it. Was quite amazing from my point of view. Before we get to the award ceremony and hand over the Startup Challenge Awards and, of course, the AM Ventures Impact Award, I first want to talk to 4 amazing people about the startup culture and the financing. But before that, we are going to have a short round of highlights to take a deep breath and to be concentrated for the next session. See you in 4 minutes. Stay tuned. Thank you.
To create the perfect dance step, I must invest both creativity and passion. But beyond that, what counts is my determination for absolute precision. And this is the resolve I bring to the AM community in order to rethink and change vehicle concepts.
Dahin zu kommen, dass wir solche großen Werkzeugsegmente mit Kantenlängen 390 mm drucken können, prozesssicher über mehrere Tage auf der Maschine, mussten wir zum einen die richtigen Werkstoffe aussuchen, zum anderen aber auch Prozessparameter für die Maschine entwickeln. Dann haben wir eine Sache nicht angesprochen, natürlich diese gesamte Bearbeitungskette, die danach folgt, also die Wärmebehandlung abzustimmen. Ich muss eine Wärmebehandlung durchführen. Das war damals, als wir angefangen haben, noch ein ganz unbeschriebenes Blatt. Mittlerweile gibt es schon öffentlich zugänglich auch die ein oder andere Quelle, wie es auch gehen könnte. Und für uns war das aber eine Herausforderung damals. Also wir haben 2005, mittlerweile 7 Jahren damit ganz explizit bei Audi angefangen, seit 2010 ja auch mit dem InnoCut-Projekt, mit dem Fraunhofer IWU schon an dem Thema gearbeitet. Und das ist eigentlich jetzt so die Essenz, dass wir sagen, wir haben diese Entwicklung so vorangetrieben, dass wir zum einen kostenseitig, aber auch in reproduzierbarer Qualität fertigen können, unsere Einsätze, dass uns das dann der Serienbetreiber, der Serienwerkzeugbetreiber dann auch abnimmt.
Step into the light, I'm alive, I can see your love shining. You put it on the inside, so no matter where the darkness, you been shining like lightning. I surrender, you fight my fight. Darkness ain't ever gonna take my life. I'm so give you my praise, that's right. I'm so give you my praise, that's right. I'm so give you my praise, that's right.
So, ladies and gentlemen, we had some very exciting startups at our Pitchnext event today, again this year, and a real firework of innovations and future technologies for you. But it comes even better. From the very beginning, startups have played an important role at Formnext, as they're also an important pillar in the development of our industry. But in addition to the startups, there are, of course, other pillars that are important, and without these, innovations would not be possible. One of these pillars are the investors, who can be a decisive factor for the success of the startups, not only because of their capital, but in my opinion, often also with their know-how and experience. We want to get to the core of this relationship and the resulting opportunities, but certainly also conflicts with our next panel we're entering now. And I hope you all agree with me when I say that the panel lineup is promising many answers to our question. Joining me at the AM4U stage, please welcome with me to my left, Terry Wohlers, Head of Advisory Services and Market Intelligence at Wohlers Associated, powered by ASTM International. Terry, it's a pleasure to have you here.
It's great to be here. Thanks.
Great.
Appreciate
Next to Terry, Arno Hell, Managing Partner of AM Ventures. Arno, good to have you.
Thanks.
Then, I've seen you already today. Stefan, it's a pleasure to have you here. Stefan Ring, CEO of AM Flow. And last but not least, our sponsor also for the Startup Challenge today, and an expert in the field of investing, Frank Carsten Herzog, Managing Partner of HZG Group. Frank, pleasure to have you here.
Thank you.
Guys, fantastic. Terry, I need to start with you, not only because you came from Cape Town. No, I'm kidding. So
no, I did.
Yeah, I know that you did. It's hard to believe, but yeah, I'm just jealous. So you certainly have the longest experience in this round here if it comes to startups, development of the industry, and I mean you have such an overview of the development of this industry. From your perspective, over the last years, decades. I don't know how long you can look back, actually. How this relationship between investors and startups has changed over time.
Yeah. So what you just said was a polite way of saying you're very old, right?
I think we're pretty much the same age, aren't we? No.
Yeah. In my dreams. Well, how's it changed from near the beginning? So it started in 1987, 88 timeframe, and then, just in the last 10 years, it's grown by, an order of magnitude in terms of the amount of investment that companies are providing. And, it goes from, personal investment, self-investors, to seed angel funding, to venture capital, to all types, some of the institutional investors in the publicly traded companies and everything in between. And so and what's exciting, I guess to me personally, it's gratifying actually to see how different it is, because back then people were begging for money and often not getting what they need to, and in some cases not what they deserved. I mean, some had some really interesting ideas and intellectual property, but it just wasn't available because who's ever heard of this, if you back up 30 years ago. And today it's coming from the likes of people in this room, and it's, if you have a good idea and you're persuasive, the sky's the limit. I mean, companies can raise tens, even hundreds of millions of dollars over a period of time. So it's very different, and it's all good today compared to the way it was.
Yeah, I think so. I mean, at least the transparency, of course, is fostering as well the speed and the development and the chances of investing in startups today. Arno, I mean, latest at the AMTC, we discussed the insight from your intensive work and for startups. I mean, you are surveying so many startups all the time. This is also a lot about success and failure, and I remember we discussed the failure rates in the startups. How do you assess the importance of venture capitalists for the startups, for their success rate?
That's a good question. In my opinion, you can't value this contribution high enough. So don't get me wrong, you can start a company your own. You don't even need venture capital money to make it big and successful, for sure. But venture capitalists, or especially the people behind the venture capital, have made a lot of very painful and expensive lessons themselves, which they can share with a startup, and therefore also reduce the risk of failure dramatically. Because normally a typical venture capitalist has an entrepreneurial track record, has made a lot of mistakes in the past, and can help startups to avoid these mistakes. And a venture capitalist, a well-connected venture capitalist, can also bring in important people into startups, not only key employees, but also advisors to the board, or key customers, for example, to help a startup growing much quicker than without this outside support. And therefore, from my perspective, venture capital is certainly an accelerator for a startup in many more ways than just the financial way.
I mean, we want to talk as well about culture, startup culture, and you are at least already more than 10 years in the industry as well. So how do you perceive, comparing with your early starts in this industry with today, how the culture in the startups has changed? What is the perception from your side?
It has changed quite a lot. So I started in this industry back in 2007. And there were big companies around. In fact, I think when I started, EOS was the world market leader with 180 people and 50 million revenue. That was enough to be the world market leader in industrial additive manufacturing. All the companies got bigger. There were more industrial companies that joined the game. But what I realized when I was working in strategy and business development, that it was extremely hard to found a startup because hardly anyone at that time wanted to invest in this new kind of technology, and especially in hardware. Most investors were looking at software businesses to fund, and they had no idea about new materials. Deep tech as a term did not exist back then. So the startups back then were very scientific, very geeky, and I think when you look around and look at the startups that are here, this is real flourishing, blooming culture. The startups dimension is one example. Look at their booth upstairs in 11.1. Many other companies. AM Flow has built a place where people want to work. They are attracting great talent, not by paying the biggest salaries, because most startups cannot afford to pay extremely high salary, but they are paying with a great culture and generating a place where I want to spend my entire day. And that's quite remarkable about small companies building culture.
Brings me directly to Stefan. What a handover, by the way. Stefan, we talked up front a little bit about the responsibility of investor, not only for the startup or its own stakeholders, but of course they need to gain money, but indirectly always for the development of the entire industry. What is your opinion on this, and what does the work of AM Flow has to do with it? Because there's a combining factor.
Yeah. So first I would say that the investors playing a really important role in the further development of the industry. So today already a really successful industry, but also we are not there yet. And we cracked, I think, the easy problems. It's about the more complex issues out there. And that's just not possible without the funding, the bandwidth, the coaching, the culture to get there. For us as AM Flow, as a company, we have a vision on, for instance, we focus on getting the cost price per part lower and also maintaining actually production local, whether it's in a high wage or a low wage country. And this is why we are trying to automate really labor intensive process steps. But because additive is really complex, normally if you automate, first question is, what's your standard product? Standardize a little bit more and then bring in the robotics. Name of the game of additive, every part coming out of a printer is different. So that's a really complex problem to solve. And their venture capital can help because, well, more than half of our teams is consisting out of mathematicians. And we spend quite a little bit of time to crack actually the problems dealing with the infinitive variety of parts. And we are there. And that's the step changes that the whole industry is solving, whether it's software, materials, the printers still themselves, all the processes around. We're also not thinking about printers anymore, but production lines and actually now at factory level. And with all this improvement, we are still small compared to mass manufacturing.
Yeah, absolutely.
And that's the environmental promise and also the responsibility, besides also making money as a venture capital fund. I think that's the dilemma. You see where it needs to go. You also need to make money for your investors behind your fund. And yeah, looking at that timing. I think that's an incredible dilemma.
Later on, I have another dilemma for you that we can discuss. But first, let's come to Frank. Frank, I mean, you're kind of both in one person because you are a successful founder in additive manufacturing. And today you are investing in startups with HZG Group. Compared to your beginnings at the turn of the millennium roundabout, how has the startup culture changed in your view? What are the startups all about today?
It's a good question. So I started a little bit earlier. And if you compare that time when I started, internet and email started as well. So I think there's a big difference to today in getting information and collecting information. Getting involved, getting in networks, for example. When I started, I think the word startup didn't even exist. So I didn't know what a startup is. What did I when I found out that there's new technology, there's something promising, and I needed money. So typically in Germany, you You ask yourself, I go to the Sparkasse, maybe they give me some money. But okay, I learned, even that I was a student, that a Sparkasse is not a good idea for some coincidence. We had 2 very successful company owners in our family. So yeah, it was clear to go to them and ask for money. And they gave it, and we could start. I think is a big difference to today. The density of information you have nowadays, the possibilities you have nowadays to network, to get information about what's going on in market and so on. I think this is a huge difference. And I think that coming back to culture, I think people live in a highly dynamic situation. Every day something changes. I think they live in a complete different environment, but what never changed. So I'm coming around. So we are screening companies, we are visiting companies, young people. The inspiration, the excitement, the motivation, I think is still the same. When I found it out, you can completely melt material, and people with their new ideas find out it's a way for them, a track maybe to a market. So I think excitement, inspiration, motivation, I think is the same and has to be the same.
How do you say no to some of those?
Sorry?
How do you say no to some of those the people, that young, energetic people who have what they think is a great idea?
Yeah.
But you may know.
Terry, this is very difficult, especially for a person like I, who is excited very fast about things. But we have a team when we are screening companies. We have a fund. This fund has parameters. This allows us to go to invest in companies and not to invest in other companies. So we have rules, of course. Yeah. And then, of course, we have experience from our own story and have a feeling about the potential of a technology, for example. And yeah, and then we also decide what we believe in as investors and what we maybe not believe. But we still motivate young people. If they are convinced about their ideas, please follow up your ideas and your inspiration. I think we motivate them. If we do not invest, that doesn't mean that their idea is bad. I think this is very important.
So you still encourage them to continue
Absolutely.
to work.
Absolutely, absolutely. Yeah.
Just might not be a fit at this situation.
Yeah, yeah.
But another question, when we're digging now into culture, we have just stated that the excitement and inspiration is still the same. What about the expectation? That would be interesting for me, because if you look at the startup there, today we had 20 startups pitching, and now that we have the transparency for you, we have the transparency on the other side. Are they like expecting to get money easily? How has that changed? I mean, I remember when you need to go to the Sparkasse 20 years ago, you needed to have quite a good business plan to get money. Is it easier today to get money, or what does it do with the mindset of the startups?
I think the easy money has gone. I think the times where really a crazy amount of money was spread into startups, I think that's gone, and I think it's good, because the investment have to be sustainable. I think I'm boring if I tell you, when I invest money, I want to get a little bit more back.
Really?
Yeah. So that's the approach, and I think investing from our perspective has to be organic. It has to be healthy.
It's a good one. Stefan, you take the question of long-term development of things. I mean, Arno, you have a fund, but you're responsible for a fund. And if I would be an investor, which I'm not, but if I would, then I would, as Frank said, I would expect an ROI, and not in 10 years and 15 years, but as soon as possible. How is that affecting each other in terms of you as the deep expert of the industry know that you need to have a certain time to develop the industry and get closer to industrial production. And on the other side, you have investors that are saying, sorry, Arno, at a certain point of time, I want a little bit more of the money back that I gave you. How's that stressing you, or how's that affecting your business?
Well, I think as you indicated earlier, it's a lot about expectation management. Yeah. Yes, I'm also a venture capital entrepreneur. I borrow money from my investors. I give them a promise that I invest in good cases that will bring a return at some point in time. This is clear. But I think that's exactly the reason why competent investors, specialized funds like HZG and AIM Ventures are extremely important for this industry, because we, as industry insiders, know that hardware development takes much, much more time and money compared to software development, for example. Yeah. We know the innovation cycles. We can assess technologies certainly differently than an outside investor that is just starting in this industry, because we know how difficult this work is and how much time it takes. And therefore, we are also competent enough to tell our investors how long it's going to take. From my experience, I've developed hardware myself. You can't do it under 6 years. And everyone that comes to me with a different statement that they are going to develop an industrial machine within the next 2 years is not necessarily having a realistic view on their development. So I think if you spend a lot of time in this industry and you know how R&D and additive manufacturing innovation works, you can assess these cases very well, and then it's also on us to communicate it to our fund investors. And typically, the good thing is, we are not in the cowboy age of venture capital anymore. This was until the financial crisis, 2008. Things have changed dramatically, or even it was a lot more regulated with the bursting of the dot-com bubble shortly after the millennium. Now we know a fund has a runtime of 10 years plus 2 or 3. So this is our action radius within which we can invest and support companies and divest, or maybe even continue supporting our investments. But this is a sufficiently long amount of time to find the right startups and make them successful.
Case in point, you said we can just jump in, right?
Go ahead. Yeah. That's why we're here.
Good. Yeah, so case in point. So a company today I bumped into. So they've worked 5 years behind the scenes. There's a company from Turkey, I don't even recall the name. It's on this, in this hall. And 5 years, they rolled out the machine today for the first time, and it's based on an industrial robot. So they had, and it's a wire-fed directed energy deposition system. So it's not rocket science in the sense it's not the first time it's been done, right? It turned out good parts, but that's, you know, a young entrepreneur might say, oh, I can do that in 12 to 18 months. No, it takes 5 years and a team of good people to get it done. And so, yeah.
Yeah, I mean, this is proven by experience, and but sometimes there might be a new way. I don't know. Could happen.
Well, right. But history shows that.
Does it also not depend on the importance of the subject? Because sometimes you definitely can accelerate with more resources, but then the topics should be really critical and really having an impact altogether. Also, looking at a 10 years time limit, if you would say, hey, develop your equipment in 6 years and you only have 4 years to build out your sales, then it's also going to be really critical in the end of your fund that in the last 9 or 10 years, everything needs to happen with your whole portfolio. And how is that for, if you look at software, sometimes the time span of getting clarity whether it's a good idea is way shorter. Machine is, I would say, a little bit in the middle. If you develop for medical, you're going to invest like 15 years, easily, and then you're going to get your first return. So there must be also within the VC fund specializing in a certain industry, other bandwidths in time. Probably also the investors behind the VC. I think if AIM Ventures, it's not a secret that also EOS, for instance, Langer family is, for instance, investing. probably if some really good ideas come to the market, it's also beneficial to not only the Langer family, but also EOS as a company. So how do we think about that? Is that 10 years time span of a VC long enough or exactly right? Or especially when problems get trickier?
Well, I would say a competent investor can anticipate that it gets tricky and things always take longer and much more money than initially anticipated. And therefore, of course, we accept when a young, not so experienced founder team tells us that they're going to develop the technology within 4 years. We know that we have to expect 6 to 7 years until something is mature enough. I'm not saying that you don't have to start to build your entire company after 6 years.
Yeah.
You have to build sales and an entire business structure around your business from the very beginning, and you can sell prototypes and R&D projects. But typically from the idea of a certain industrial hardware to really having a validated, stable, and scalable hardware platform that is capable of producing industrially acceptable quality parts. This is 6 years at least from our experience. And of course, let's say an experienced VC considers that in their planning, that things take longer. And the good thing is that there are consecutive funding rounds with co-investors where you team up, and people understand that you have to somehow make sure that the runway doesn't end too early for a startup, because that doesn't help anybody. But I think, just what I said earlier, it's extremely important that you have the right and competent investors who understand this game, and therefore you see a lot of purely medical-focused investors who are used to these extended innovation cycles, because they take at least 10 years to get a medical certification. Or to the same extent, you will not find a defense-focused investor in our business, or any one of us is going to invest in a defense businesses, because these are separate or completely different ecosystems with other rules and other time spans and requirements. So that was also the reason why we said we are not going to invest in anything else outside of additive manufacturing, because this is the industry that we understand. Here we are competent and we can provide value, and outside of our industry we are just the guys with money but no competence, so that doesn't make sense.
Yeah. So I would like to confirm the 6 to 7 years, that's true. So we have the same view, but investing in a company is the one thing, and once you are invested, I think the work starts. And I think this is one piece of our business model, that we bring in our experience from my own story, with people experience from 3D printing. I think this is a period which is really very important, that you are VC who is able really to support young companies in that period where they bring their product to the market, where they start, where they have the first machine to show on a trade show, for example. And then a lot of challenges begin. So they are not ready to go. The infrastructure of the company is just starting to build up. It's a lot of human resources question, how you set up that company. I think it's always a challenge how to sell the products, which sales tools you're using, production, where to produce machines, what happens when you have to build 100 machines, who are the suppliers, supply chain, and so on. I think the most, very important, maybe most important, is this period after investment. How can you support these people that they concentrate on their core competence, technology, ideas, to build that and get them done, the other things which have to be done a lot easier. So, and I think this is what we are doing, and have the network and also the competence. And yeah, the question is to make them successful, those young companies.
But you mentioned all the work. My question would be again, I mean, we have, in my opinion, that's a little bit what we discussed, Stefan. We have an industry where there's a strong dependency between the sectors of materials, hardware, software. They're all depending each other. So we just mentioned machine development or getting successful could take 6 to 7 years, if I understood correctly, okay? So on the software side, you mentioned, Arno, it could be much faster. So I'm an investor and I'm looking for a return on investment. Do you always consider the big picture? Or is it more like looking really for ROI opportunities? What is the balance between these two? Are you looking for, if we invest, let's say, in this software solution, we will then have an impact also on the machine and material in 2 to 3 years, which helps us again? Is that always like a holistic approach in your work?
It's maybe like with every startup. Of course, you need to consider, you need to have a bigger picture, something like your North Star that you are striving towards, which gives you a lot of guidance. But like with all startups, sometimes I think people put a little bit too much effort into developing a strategy and they completely ignore the real hard work that is ahead of them. Because it's so easy to do strategy work, because you don't have immediate consequences. So it's really nice to paint all these nice pictures and generate really, really nice looking slides. They are important. They satisfy your investors. They show that you have a structured thinking. It is very important. But what's even more important is the real hard work on the basis. And then a good friend of mine, a mentor, once told me success is 5% inspiration and 95% perspiration. The sweat, the real hard work that hardly anyone sees.
Said that. Albert Einstein, right?
Okay, so then he quoted Albert Einstein. So he was even more clever.
Did he? It's 1% and 99% for Albert, but in any case, that's
yeah, but always worth quoting Albert Einstein. But please go ahead.
Yeah, but the fun fact about this is, if you come to the point where you ask for applications, I think it's sometimes really you have an idea, you build a machine, it's good for something, but the broader approach on what you can do with it, where the markets are, I think this is also sometimes a weak point in these young companies, and it's clear they don't have the experience, they don't have the networks. So also here, it's as an investor, it's very important that you have a little bit a scope, a view of what applications are maybe possible on that machine. So we decided ourselves to build up a private research, development, and application center. And we even buy the technology of our portfolio companies and apply them in our center and get companies to the technology and try to find out where maybe further markets are, or we help to further develop things, details, and so on. I think this is very important if you think of accelerating the technology, making it faster and maybe earlier successful, for example. So we are a little bit, and Arno as well, with his company, a little bit a catalyst for our portfolio companies. So we try to accelerate them and make them successful.
And maybe coming to your question, how important is it that it fits in the big picture? Of course, for me, as an investor, I match a new investment opportunity, of course, with my bigger picture, that I also have a balanced portfolio. But in the end, once the contract is signed, the investment is made, and we have assumed our seat on the board and assigned an investment manager, the startup doesn't care about our bigger picture anymore. It's really about hard work and making this company successful, right? So our big picture as a fund investor shouldn't be present in the daily interaction with the startup. It's really only focus on this investment as if it was my only one that I want to make successful. And yeah, I think this is how we should work. This is how it should work.
Terry, one question for you. I mean, we were talking all the time about VCs and investment. I mean, there are more companies to invest, like family offices or even the industry. Has that changed over time? Is there more interest today of, let's say, larger entities in investing in startups? How do you perceive that? How has that changed?
Well, yes. I mean,
or is it dominated by VCs, the whole?
Well, I would say largely VCs are where the money comes from startups, but not entirely. I mean, there's government money as well. In the United States, we have programs that can help accelerate where you're at. There's incubators at universities and other institutions, and so there's a number of methods and options for startups to get going. If you have a rich uncle or brother or father, that always helps too. And
but Terry, what I find interesting also when you see stuff happening in the States, could you make a statement that sometimes software is overvalued and hardware is undervalued? So if you see some, let's say, investments and also some takeovers, especially lately in the States, and also some really big spec deals and so on, you saw some really strange valuations. Some service providers being valued way higher than others. Some hardware developments not being too much valued, and some software crazy amounts being paid for in the end proving not always valuable.
I can think of one, actually, one that happened last year, a German company, I won't name them, but was it overvalued? I don't know. I guess time will tell. But but continue.
It's interesting to see also for the industry, because if you think back, and you can think back, I think the furthest, in the beginning you had the printers, at least you were able to print at least. At some point you need a software system to deal with all your customer orders. Then you need to add value on your parts with all the finishing equipment. Then you need to start thinking on factory level. But somehow, if you linger too long with the last step, you get a lot of investment in the latest success, but not really that next step necessary for the whole industry.
Yeah, we're just seeing, I mean, the software space is incredibly exciting right now, what's going on, with the MES, the manufacturing execution systems, and some of the design tools that are being developed from startups, as well as some of the big four, like Autodesk and Siemens and the rest of them. And in companies like Ansys and a number of others. I mean, just a lot of activity, and software now plays a role in so many. If you look at the entire process chain, the workflow, it's hitting in so many areas and so critical, and it can really make the difference too. From a mediocre solution to something that works very, very well. So I'm glad to see the likes of your companies invest in these efforts, because they need the help. Can I ask a question of the audience? Yeah. So how many people are looking for investment that are here?
Oh my God!
Wow, yeah. So more than half. So
a few.
So if I could ask our investors here, what are you looking for? Like, what gets your attention right away? Because you probably get a lot of people coming to you, and what does it take to get your attention? And
when we look to possible company, I think really on first place, I think it's the culture, it's the team. When we look at companies, I think this is the most important. Technology is second place. I think with a very good team and a good technology, I think you can achieve a lot. I just come back to what happens after the investment. I think you have to take a lot of decisions, a lot of important decisions. You can do a lot wrong. And I think in that period, to have a very good professional team, I think it's a lot. It's a lot. And technology really is second. Of course, we want to be inspired by technology. We want to be excited about the technology. And the best thing is if the team and the technology is superb, So, but team is number one, Culture, skills, professionalism.
And the need to cope the pressure that they get afterwards with their daily work.
Because as
this
an
is-
investor, you have to accept crisis. It's not a track which is that way. It's something like that. And with a good team, you can go through crisis a lot easier. And if it's collaborative, I think it's also attractive and important for investors because it is important to collaborate, to work together. And therefore, it's important to have good teams.
And on that note, what is extremely important to me, I mean, we are looking at hundreds of startups every year, and we invest in about 1% of them. What we are always looking for is, if we have a great team, no doubt that's the number one box that needs to be checked, the ability to listen, to work together with the investor. Because we've seen a lot. And one mistake that we very often see, especially in first-time founder teams that are majorly technology-driven, we have engineers or technologists that are extremely convinced of their technology, and they have sometimes the attitude that this technology is going to sell itself. I don't even have to talk to the customer. They will call us, and they would want to have the technology. Doesn't work like this. Doesn't work like this.
Yeah.
We've seen it so many times, and we see it over and over and over again, that the ability to listen to your customers, your advisors, your investors, to build also a strong sales team that can sell the great products that you are developing is extremely important. And
how do you judge that for instance, sales, say, we are actually in that phase, say, so we've built our technology, but now in the ramp-up phase, really getting more sales in. But when you first judge, let's say, a funding application, there probably is no sales team yet. Or you have the founders, but maybe it's not going to be the founders selling the product later on, for that could be a completely different skill set. How are you able to get that out of, let's say, a pitch deck or maybe a few hour meetings? That's difficult to judge the team at that point.
It's not a pitch deck only, it's several visits.
Yeah.
You visit a company, you make tests, for example, you're benchmarking. And I think I wouldn't invest in a company only from the pitch deck or just seeing one or 2 hours. No, I think the important thing is to understand what they are doing, to understand how they are doing, and what culture they have in their company. And I think we are always a minority investor because we want to push the founders, the inventors. They are the boss. They had the idea. We want to make them successful. But on the other side, vice versa, it's important that they accept that there are people who are experienced, who have gone through several things, which were not only sunshine, and to be able to listen and not to be resistant for advice. This is exactly what you said, Arno. Listening to experienced people, to listen to their opinion, but to take their own decision. I think this is the right thing.
I mean, I agree totally with you, Arno. The things that I see when I consult startups is often that, especially if it comes to the sales point, they not really have a feeling of what the customer is really wanting in the whole approach, or what the price is to be expected. Price is always a big topic because they go into the market, they think their product is awesome and great and needs to be sold without doing any sales at all. And price is the last point where, for how much we're going to sell it? This is quite the question I always experience. And then I ask, what is the customer willing to pay? Oh, we never ask ourselves. So this is really something that I experience very often. And this is, again, I think, and I did this with Arno several times with my business, to be honest, because we challenge each other. And he asked me, what do you want? What kind of price do you want to achieve? And we discuss about the customer expectation. And this is what you need to have. You need to have a counterpart, a mentoring part, a sparring partner, right?
Guess what happened to me when we showed the M3 Linear first time 2001 at the Euromold show. We were so enthusiastic to get this machine done. We get just the paint and put it on the booth. And 2 days later, Daimler, Chrysler arrived and said, what does this machine cost? Oh. Really?
Yeah, no idea.
Yeah, we had some idea, but we were so focused on getting the technology done that we hadn't really a clue how to sell a machine. And then after the show, we really hurried up to compensate that because we had to earn some money to survive. And that's the situation also nowadays. Startups sometimes entering in such a situation. And I think then it's good to have experienced people with a good culture beside and to give them advice. And for example, now I would know how much such a machine should cost. At that time, okay, we had to hurry up to find it out. Yeah.
A question additionally, Frank. How can you support a company playing the global game immediately? Because 3D printing, although a big industry, a multi-billion-dollar industry, but still, if you come with an innovation in this industry, probably your clients are going to be global. And that's complex. If you're starting a startup in the States, at least you already have a big market. That's different probably in Europe, although in Germany it's already a huge market. We are from the Netherlands, that's a tiny market. So how are you supporting over there?
To be honest, so that's the privilege having sold machines worldwide. So we still have our reseller network everywhere. I just met Dr. Kim from South Korea today. We have in Japan, in the US. We have our network and we reactivate. We just say, hey, look, we have this reseller in Japan. If you are interested to go there, we have all the good experience with them and we connect and they find out if they can work together. And so that's how we support the young companies if they want to go global, for example. But in the first step, if you get such a machine done on the market, I think really it's not the case that you immediately go global. I think you have to go step by step to develop your market. I think the US market in respect of machines and health and safety topics, it's a lot different to Europe. I think you have to take a lot of things in mind to deliver a machine which is developed and sold here to the US. So it's never an approach which is from one day to the next globally. I think it's a step-by-step process. Yeah.
But it could be difficult sometimes. When we launched our first solution, actually BMW, Midwest prototyping, Materialize and Shapeways come up. Two of them being US immediately. So there we were with our first product. And
that is the question, which people you get on board. Terry, you know Oliver Edelman, who was a long-time salesman at 3D Systems. He joined Concept Laser very early, and we got a very, 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 very skilled sales guy. And he built up the whole sales infrastructure worldwide. And this is also one topic for young companies. I think there's sometimes, or very often also, a weakness in sales. And the most important thing is to sell the product and to have the right tools in your hand to sell products. And for this, I would spend money in really very, very good people in this department.
I think people do underestimate the effort in sales. You know, like you say, they think, oh, this is I developed it. It's a beautiful piece of work, and people just be breaking down my door to get it, and they'll pay us double than what we want because they want it so badly, and be first in line, and then they find out that doesn't happen, and so then they say, well, we need to hire a salesperson. Really good, experienced salespeople are hard to find. They're not just out there, and so you have to find someone maybe like what you did, someone who's experienced at 3D Systems, and then immediately they have the network, the know-how, the skills, and so forth to get it done.
There's a funny story when we sold the M3 to Daimler, and this Mr. Edelman joined the company, and we shared work. I said, I do the technical part because I had no idea of sales, and he said, I do the sales because it's my expertise. So we entered the room with a purchasing guy, and Mr. Edelman did not arrive. And then I had no clue to sell this machine. And so I repeated how the advantages of the machine and what technology this is. And then Mr. Edelman entered the room and he made everything round. We saw the machine, but the guy said, it's good that you have come because Mr. Herzog doesn't want to sell a machine today. So I know I have the experience to start a company, to have really superb technology, but I had no clue about how to sell such a machine. Now I can do it, but at that time not. And it was very good to have skilled people next to me who had the tools to make this successful. Yeah.
Awesome. I think we delivered already a lot of inspiration, tips and tricks, hopefully, for the whole range of people looking for investments here in this audience. I hope you enjoyed so far. Are there any questions you need to ask right now from the audience here?
Sorry? Yeah. So you mean if I would have sold that machine in this special moment or not, and why this guy could do it? Yes. Yeah. Because there was a negotiation which was a little bit complex. And this is the tools you have in it. You give something, you get something back. So the technique of negotiating, I didn't have. I had no workshop for it. I didn't learn it because I was always concentrated on technology. I could tell him about everything about laser, the wavelengths, and how big the particle size of the powder is, and what materials you can machine. But the know-how, how to negotiate what you give and what you get back, and how you bring that order over the border, I think I didn't have the skills, the knowledge. Now I have it because I had to do it several times afterwards. But this is what some startups missing a lot, and it's clear where should they have the experience from. And then it's very important. This is a very important step that you, at this point of time, you get professional people next to you, even that you have pay maybe a lot of money for them. I think if they are good and do a very good job, they are more than worth it. No.
Arno, you have a last statement.
Maybe adding to this from my own painful personal experience of the past 2 years. I raised 100 million euros from about 30 investors. And to win 30 investors, I had to pitch more than 300 times. And the one piece of advice that we give to our startups that are going into fundraising mode is a mistake that I made. Don't pitch to the accounts that you want the most at the very first one. You need sacrifice accounts. You need to practice your pitch. You need to fail. You know, the mistake that I made when we started to raise the fund, I went to the 10 most important accounts in Germany as the first 10 appointments. And I burned them all because my pitch was really bad. It was awful. My story was not honed. It was not very smooth. I failed so many times. I ran into closed doors because I made a lot of mistakes. But let's say after 50 pitches or so, I really got a feeling what triggers investors. And after 100, it started to be a lot of fun. But for all of you who are raising money, who are starting to pitch, do not pitch to the most important investors as the very first appointment. Look for 10 accounts that you can burn, where you practice your pitch to become perfect. And then go to guys like HZG and us and give us the good story so that we understand it immediately. And it's exactly the same with selling. Don't sell to your most important customer when your pitch is still lousy.
And even if you have a large experience, I would recommend, that's what we both do all the time. We're challenging each other, even with a large range of experience at many years in selling. After a while, you get experience. It's always good to ask somebody who has probably a different opinion that you might not like at all, and this is sometimes the case, but it's always worth having the discussion, because it's a mirror for you that you have to look into, and that did I consider every factor in order to be successful? This is quite important. There's one last question from the audience, and then I need to close the session. Okay, so I repeat the question. So the first one is, where do we have regional-wise the most VC money going to? So either Europe, Asia, or the States, yeah, or the US. And on the other side, the recommendation of either going, which startups are going either to governmental investments or VC investments. I don't know who wants to, I mean...
I can try and make it extremely quick. So when, in terms of startups being founded, it's about 40% Asia and 30% North America, 30% Europe at the moment. Money-wise, the distribution is completely different. Most of the money, because there's much higher prices and much more money flowing into startups, is in North America. And then in Europe, a little bit less in Asia, but that's also mainly because we do not have a clear enough visibility of the Asian market. That's that one side. Going for venture debt, only when you're in a really strong growth phase. If growth doesn't happen and you are in a venture debt program, you are in big trouble. So wait as long as you can until you accept venture debt, because it's debt. It's not equity.
Maybe get seed money from the government. And then once you're into some kind of, like you say, a growth phase, then go after, you know, a Series A, B, and so forth.
Yes. Series B, the earliest, and then after that.
What my experience is when I started company was when we found out that it can work, you can fully melt the material. So we were applying for government money, and we received. And yeah, our VC was the uncle and the father-in-law. That was when we really had an idea how the product should look like and how we want to go to the market, I think. This is maybe some orientation for you.
Maybe to add, government grants are also really okay. It's a lot of transpiration, but it straightens your thinking on what you're going to research and how you're going to bring it to the market. And it's really helpful. And it's also one of the succession points you can put on the table.
I tell you what, I need to close the session, but I'll tell you something. As a moderator, you should not exaggerate, but I'm super excited. I loved it so much, and I hope you did as well. It was, in my opinion, a fantastic discussion, because we had a discussion. So thanks to the four of you. Couldn't be better seated here at this panel discussion. Thank you so much. We are not finishing the overall Pitchnext event, I promise, because we are now going over, and I beg you all to stay, because this is a really important moment. We're going to hand over the awards for the winner of the Startup Challenge and, of course, of the AM Ventures Impact Award, which in this case is one in a person. So please stay, give 100 times applause for the startups, because they well deserved it. So I would go over to the wall now and we hand over the prizes. Your prize money as well, Frank, would be highly appreciated. So head us over there and we will go into the award session, okay? Thank you so much. A big applause for the four guys here.
Thank you.
It was a pleasure to have you, really. Okie dokie.
Riding a motorbike you restored yourself is a unique and defining experience. Every single part of the system is important, no matter how small it is. I support the AM community with this same passion by finding and creating the best materials for functioning production concepts.
Wir stellen keine Bauteile, keine Sichtbauteile her. Der Steckverbinder, der verschwindet nachher irgendwo im Automobil oder in der Werkzeugmaschine oder irgendwo. Aber die Oberflächen sind natürlich Thema. Wir müssen auch sehr, sehr maßhaltig sein. Und in puncto Qualitätsansprüchen, da entscheidend oft die konturnahe Temperierung überhaupt die Machbarkeit, überhaupt über die Herstellbarkeit. Und da kann die additive Fertigung mit konturnaher Temperierung eben ganz, ganz stark weiterhelfen. Wir arbeiten schon seit vielen, vielen Jahren, setzen wir Formeinsätze mit konturnahen Temperierkanälen ein. Es liegt halt eben in unserer Firmen-DNA, dass wir eben technologisch mit vorne mitspielen. Teile, die sehr im konventionellen Spritzguss sehr viel Einfallstellen erzeugen würden, wo man wenn man die Wärme nicht homogen rausbekommt, und da sind wir eben mit konturnahen Temperierungen sehr viel besser unterwegs.
Wir haben halt generell das Problem, dass wir ein bisschen unterscheiden müssen. Der Werkstoff, der gut für das Herstellungsverfahren ist, sprich für die additive Fertigung, der sich gut verarbeiten lässt, um Formwerkzeuge insbesondere herzustellen. Und die Anforderungen, die zum Beispiel der Einsatz dann an den Werkstoff stellt. Gerade Stähle, die einen relativ hohen Kohlenstoffanteil haben, können später mal hohe Festigkeiten, hohe Härten zeigen, aber lassen sich schlecht schweißen in der Regel und lassen sich dahin schlecht für den Prozess qualifizieren oder im Prozess verarbeiten. Von unserer Seite gehen wir anlagen- und prozesstechnisch ran hauptsächlich. Also das Thema Temperatur, Vorheizen der Maschine im Bereich 500 Grad dann mit hohen Vorheiztemperaturen zu arbeiten, hilft dem Problem entgegenzuwirken, eben Rissbildung aufgrund der hohen Abkühlraten, die wir im Prozess haben. Es sind andere Sachen wie Mikroligieren, sowas, das heißt minimale Werkstoffkorrekturen im Prozess oder vor dem Prozess möglich.
So, ladies and gentlemen, this was the Pitchnext event 2022 here at the Formnext on the AM4U stage. And I'm super excited to hand over now to Arno and Franco, who will hand over the awards to the winners. Let me ask for the first winner here on stage, which is Alpha Powders, please. Big applause.
Alles gleich.
You will get the 3D printed award from Voxeljet and, of course, 1,000 euros from HZD Group. And afterwards, we're taking some additional pictures in front of this wall, but great. Thank you so much.
Oh,
big applause.
Don't spend it all in one go.
Thanks a lot.
Here's your award.
Thank you very much.
Awesome work. Next startup to be awarded is Lettuce Medical. Big applause. Fantastic presentation.
Congratulations.
Thank you. Thank you.
Well done.
Congratulations. Thank you. Very good. Yeah, good. Thank you. Thank you very much.
Here's your award. Well deserved.
Thank you very much.
Thanks.
Congratulations.
Awesome. And And our third winner of this year's Startup Challenge is Photosynthetic BV. Congratulations.
Congratulations.
Oh, yes.
Here you go.
Anna, by the way, do we have the award? Is there AIM in Adventures Impact Award?
No, it's part of the... Who's getting it?
The first
Rivelin.
one. Let us,
Yeah.
we get them back, okay? So, next one is Rivelin Robotics. There he is. Congrats. Great work.
Congratulations.
Thank you. This will pay for a lot of apple vines.
Be careful with it.
Yeah.
Awesome. Congratulations. And last but not least, last winner of the Startup Challenge, Sphere Cube. Congratulations.
Congratulations. Well done. Well deserved.
Well done. Good. Congratulations.
Here you go.
And then, as I just mentioned, or already mentioned, let's at least get them once back to stage and give a big round of applause for the winner for the AM Ventures Impact Award. Once again, Lattice Medical. We could not cherish you enough. This is awesome.
Congratulations.
This is so highly appreciated. Thank you for that. Great work.
Thank you.
So let's have a group picture over there. And from my side, thank you very much for being our guest. Stay tuned. We are now doing the
So
afterwork.
you know that...
session.
You know about the Impact Award,
And
right?
we're not
Were
doing
you
the
informed
afterwork.
already?
What are we doing now? Antje, tell me. Okay, there is some program to come, and we are going to take pictures over there. So thank you from my side. Thank you so much, and enjoy the rest of the program here at the AM for you. Thank you. Dann gehen wir hier ab.
Ashamed, think something new under the sun. You can't take back them things you already done. No. You blame things that you do on somebody else. No. But they all see is you need help. But still you try so hard to cover up your games. Got you thinking, don't nobody see that all this time, it ain't nothing changed.
Vom Produkt her geht es darum, ja hochwertige Oberflächen zu haben, beispielsweise Glanzoberflächen mit einer sehr homogenen Ausstrahlung, also einem homogenen Brechungsindex. Und das heißt, für das Werkzeug, das dem die Form gibt, am Ende auch eine optimale Temperierung am Ende beispielsweise im Spritzguss, um dann auch diese möglichst gute Oberflächenabbildung ohne, sag ich mal, Unterschiede im Glanz abzubilden zu können. Im Werkzeug dann wirklich, wie kann ich Sachen abbilden, die ich heute noch nicht abbilden kann mit konventionellen Verfahren. Also beispielsweise, wie kann ich eine Temperierung, also eine optimale konturnahe Temperierung abbilden, indem ich beispielsweise einen Kühlkanal Layout verwirklichen kann, dass ich gar nicht bohren könnte. Also ich kann ja nicht um die Ecke bohren, ne? Aber manchmal wäre es gut zu sagen, ich könnte um die Ecke bohren, ich habe einen Kanal um die Ecke, um dann genau diese Stelle optimal zu temperieren.
Wir haben auch ganz bewusst eine Auswahl getroffen und auch ganz bewusst eine Materialauswahl getroffen und auch die Maschine mit der TrumpfDruckprint 5000, mit dem wir eben diesen hochwertigen, auch den Standard-Werkzeugstahl 1.2343 verdrucken oder drucken können, der auch in der konventionellen Welt sehr verbreitet und sehr akzeptiert wird. Wobei die Reise ganz klar auch dahin geht, die geht weg von diesen Standardwerkzeugstählen in der additiven Fertigung. Das finde ich wichtig zu bemerken und es ist auch richtig, das zu tun, weil die additive Fertigung, die muss nicht mit den konventionellen Stählen oder Werkstoffen konkurrieren. Hier ergeben sich auch in puncto Werkstoffen völlig neue Möglichkeiten.
Wow, time runs fast. I think now it's time to make a wrap-up of a very successful first exhibition day here at Formnext 2022. And I'm very happy that I have some very special guests here with me on stage. And I'm very happy, Petra, that you made it again after a very, very busy day, a very busy exhibition day, that you made it to our stage here, Aim for You stage in Hall 11. Petra Harburger, she's president of Mesago, and she is here with some special guests from the international business. So I may introduce John Fay. He's Deputy Senior Commercial Officer at US Commercial Service. Rick Klein, he came here directly from, you're here since Saturday.
Yes.
You said to me.
Came in from Tokyo.
Yeah, from Tokyo. You came since Saturday in Germany. Yep. He's president at Gardner Business Media. Yes. And Duff Woods, he came from London, I learned. Yeah. President AMT. AMT is the Association for Manufacturing Technology in US. So,
Richtig.
We can switch to German if you like.
That is good for me.
I think we're in the minority, although I think
that would make my job a bit more easier this evening.
But our job's not to make your job easier.
Yeah, right. This is not what we're here for, right?
Yeah, I understand totally. So you get my first question in English, Petra, no problem. Yeah. We want to have your impressions of your first day here. You had tons of discussions and conversations. What is your first impression?
Well, look at my face. What is my impression? I think I had a wonderful, a magical day, actually. And
what was magical? What was magic?
I don't know how many people I talked to, but I saw so many happy faces and so much relief in getting the family back here on not only here on stage but on the show floor. And I guess it's just what we live for. It's our passion, bringing people together. And if you see that this really works, and you saw so many intense discussions on the booths, and even outside, people just met, and it was just, I just said, it's like a big family gathering. It's quite a big family, but no, I think it was just what we are here for, and I just have a good feeling after the first day, although there are 3 more to come, but the first day always is a good introduction.
If you compare to last year's or the last years, is there something different, or is it, feeling like coming home and everything is as it was before? Or
well, actually, I just had a meeting with one guy coming off stage, and he said, like, oh, driving here is like, it's even better than Christmas. And I said, like, woo, that's really great to hear that, yeah. No, I think...
It's not because of the radio program, isn't it? It's just because of the feeling coming home?
I think so, yeah. Okay. And, no, but I think it is a little bit of a combination of having the family back again, but I think we all experienced the last 3 years were tough, and not being able to meet up in person, not being able to feel this, and I guess this was just one thing that everybody's so relieved and happy to do it again, although we had this big opportunity and the luck. We had a Formnext last year. It was smaller, but still, we didn't have this very long break. But still, it's different because, nobody's wearing masks anymore here. So I really have this feeling we overcame this COVID thing, and that this is really now belonging to our lives somehow, but no longer influencing us so badly. So this is just a relief, and this is for me also. I always said we're back for good now. It's not really changing anymore.
It's a mix of these, the pandemic is maybe a little bit more over.
Yes. Not a little bit more. It is over.
Yeah. Don't talk to our health minister.
No, you're right. We should have invited him. That would have been interesting, by the way. So, no.
Let's skip this different topic. And, let me move on to the international affair.
Definitely.
Formnext is clearly heading international. And I want to have the opportunity when I have you here on stage. What is the main goal behind Mesago or Formnext going so international? And maybe you give us or the audience a picture how international Formnext already is.
Well, I mean, what we do is we service the industry, and we look at where the industry is really based at. And I mean, this is why we have such nice company here on stage, because obviously the US is one of the biggest markets if you look at additive manufacturing. And I think this also leads us wherever we go. It's not like I mean, I love to travel, it's not that, but I think really looking at what serves the industry and to see where can we really bring a benefit to the industry. And this is partnering up with the right ones, but definitely also looking at where is the industry heading. So
but
where is it heading?
Well,
so where are you heading? Where is Formnext internationally?
I think the US is the next target. We'll have a nice roadmap to look at, but starting next year in Austin with the format, but then really heading for the big thing in 24 where we really want to go to Chicago. We already are actually in China, which is, I'm happy our Chinese colleagues are here, which is wonderful. We also didn't see them for 3 years, and we have a very successful show there in Shenzhen, which is very national at the moment, more Chinese oriented. But no, I think we have plans, but I think we do this step by step and really look also for the right people to partner up with, because I think the first thing now was also to re-strengthen our mother event here in Frankfurt, which is now, I think, back to really almost the size we were in 2019, and then we'll take it from there step by step.
And one sentence to Japan?
Japan is a very interesting market, definitely. We also have colleagues there. We have a wonderful little event there, which it was actually the only event that took place in 2020. They managed it. It was a small forum. But yeah, definitely, unfortunately, we were not able to go there. But yes, this is also something we build up step by step. So yeah, I think the most important markets we cover now, and let's see what happens next.
John, as commercial, I want to say it right, commercial counselor responsible for the German market, can you give us some insight about the development of the AI market in US? Petra mentioned it's a very important market, but maybe you can tell us a bit more detail?
Sure. I mean, a lot of the work that we do is to bring U.S. companies to foreign markets. And I work in the embassy in Berlin, and we have colleagues throughout in all the embassies across Europe who are doing the same work across the world. I think one of the things I've noticed at the show today, in my impressions, is that the industry seems to be moving towards more sophisticated manufacturing processes and more advanced materials, larger products. And I think that this actually plays very well for U.S. industry, because we do well when we're talking about advanced manufacturing, sophisticated manufacturing, and I think that's where additive manufacturing and the strength of the U.S. market kind of converges.
But there's so huge a market in U.S. Why do companies from U.S. come to Europe or come to Germany? What is the impression that they need this market? So, it's a huge market. They can stay there and have a lot of customers by their own.
Like the Chinese do.
Like the Chinese, exactly. These are the biggest markets.
It's an interesting point, and I'll let my friends over here talk about that a bit more as representatives from the private sector, because I'd like to hear what they have to say. But it's something we struggle with, I think, sometimes in our capacity as commercial officers and specialists promoting U.S. companies overseas, is that the U.S. market is big. It's a great market. In fact, it's a great market to invest in as well. And I'd recommend any companies here that are thinking about expanding their operations look at the U.S. market as a natural next step for expansion and investing there. But the truth is, the United States is a huge market, but it's still only 5% of the world's population. And so the rest of the world represents opportunities that are just on an unbelievable scale. And I think we are always pushing U.S. companies, not just in additive manufacturing, but in every sector, to get out. And yes, the U.S. market's great, but go explore the world, because the opportunities there are vast. They're almost endless.
Before Rick and Doug answers, I thought you would say, because here's the technology better or something like that. But
well, I mean, there are great opportunities to partner with firms in other markets as well. And I think actually U.S. companies are stronger when they partner with foreign companies. A lot of the work that we do in the embassies is not so much just helping companies sell. We're helping them find, yes, distributors, but also partners. And those often become solution partners that they partner with and go and tackle third markets. So it's a little more complicated than us just saying that there's great technology here or they're very wealthy customers. I mean, especially in this sector, it's a very complicated ecosystem.
Okay, is it really so complicated from the point of view of your readers and users, Rick?
I think that there's certainly complexity to the market, and you've got a lot of multinational companies that are based in the U.S. that are doing business globally already. So having companies come to Germany to service the European market by coming to this show, they're serving both U.S. and European companies. There's also the fact that there's so much development of technology in this space that's coming out of the U.S. right now that they want to bring to Europe, and they want to be global players as they're trying to grow their businesses. And really in the capital equipment market and in the materials market and in the software market, so much development in this space is coming out of the US.
Can one say you need a footstep in the European market to become a real global player? Is it right?
I think that's for sure, yes.
Okay.
And it's, most of the development in additive is happening either in Germany and Europe or in the US. It's not quite so much coming out of Asia like in a lot of the other sort of capital equipment markets that we serve. Much more development is coming out of Europe and the US.
Okay. We talk about Asia a bit later. First, I want to know from Doug, I think you have some insights about the strategy of the US companies. Maybe you can share from your members the strategy, the goals. Where are they heading and why are they heading internationally?
I mean, one of the nice things about American companies is there's a level of innovation that's kind of just built in with a lot of people in the United States, right? I hate to say it this way, but we're not afraid to fail. So we'll try things and try things. Edison tried 10,000 times before he got that light bulb thing straight. We're comfortable pushing the envelope and testing out what can happen in an innovative area. And there's no shame that goes along with it. It's part of the process. And I think you develop an entire generation of entrepreneurs when you can think like that. And luckily, we also have the financial markets that allow that, encourage that, and support that. And so that combination really helps. And so the university structure helps. I mean, over here, the Fraunhofer Institutes, you've got some really great things that are done here in Germany to do that. We were late in catching up in that game and figuring out how to put an innovation center out there to connect the dots between the two. But that combination, I really think, has been fantastic. And as John pointed out, we have a really big market already, so it's easier for many of our new companies to get started and have sufficient market just in the United States. But the reason they come to things like Formnext, it's in as much they want to be able to prove that they can sell their products in Germany and Europe, because that's pretty difficult sometimes for smaller, medium-sized American companies. It's as much this event. This event is the premier event. If you want to show off that you're great in anything from materials all the way through to service bureaus and everything in the middle, for additive manufacturing technology, you want to show it off here. And I think that's why you see as many American technology companies here at Formnext, and why we've partnered in the United States, because this model is the model you want to use for being able to bring that technology to the marketplace.
But Petra, when we hear something like that, is then the strategy of internationalization not a weakening point for Formnext in Germany? So
it's a discussion I think we always have we had at the very beginning, because you always think like you cannibalize your own event.
Something like that, yeah.
Which never happens, actually, as far as we experienced it. Because if the market, wherever you go, is big enough, then there is always more opportunities for everybody to come. But as you said, Doug, I think the one thing is you have this mother event where everybody reunites, where you see it's the international leading event. But then still you have markets where there's additional, I would say, business being done, and also different businesses. So I think as far as we experienced, and maybe I have a very good example. For example, we do the SPS, this automation show, and it's in Nuremberg. And the first real brand event we did was in Italy. And I mean, looking at Germany and Italy, and it's even the northern part of Italy, it's Parma. And you look Parma and Nuremberg, and you would think like, well, we will have less visitors from Italy. The contrary was the result. We had even more people coming from Italy and more people going to Italy. So
What,
it
like
sort
a
of
marketing-
nurtured,
a
yes,
marketing effect,
It nurtured
something.
well, I think at the end, the brand, the event got stronger, and everybody knew if you go there, you know what to expect. And I mean, at the end, we have to deliver. This is also something. I mean, if you have a certain, I would say, level of what you want to show, then you have to deliver it. But there it worked out well. And as I said, it supplements each other. It doesn't really cannibalize each other.
And you're not going to do one of the exhibitions. They all have their personality, let's say.
Yeah, well, it's really adapted to the local markets, I would say. And local does always sound so small. I mean, the US is not small, yeah? But I think you have different needs, you have a different culture, you have a different mentality. And so business is being done differently in the different cultures. And I think this is something you always have to keep in mind.
So it's not only about size?
Not at all. No, and it's about doing this with the local people. As I said, we partner up with them and we'll do this. Originally, my colleague Konstantin would have sat here. Unfortunately, he couldn't come, but we'll have people in the States who do business with our partners in the States. We do the same in Japan. We have Japanese colleagues. I mean, not only that I don't speak Japanese, but it's like they just do business differently, and they want to talk to Japanese people and not to us. So I think it's localizing.
And the event is differently?
Yes, it is.
So you have other booths and other lectures,
different
other
colors
different
as well. I mean, if you go to China or Asia, you can also look at manga comics. They just look very different from what we like. Yeah, that's it, because they like different things, yeah.
Yeah, and they are used to different things.
Very true.
Yeah. Doug mentioned earlier that there are some reasons for the companies to come here because it's a special event. I want to pick out one of these aspects because you said the American companies they are very special in doing business, and they are special in they don't look at the failures, they look at the chances. That's what I got from your speech. And I want to point out the digitalization. We had a speech this morning with connectivity, and I think we have a lot of, it's not really coming fast forward with digitalization. Is it a problem here in the German market as you see it from US, or how do you judge it?
That's really interesting. So again, not to kind of talk bad about how we do things in the US. We used to be really dynamically the drivers of what was happening in machine tool technology as an example in the United States. And then we kind of slipped away from that and kind of got off focus and got in some different areas. And Germany really became kind of one of the premier locations for able to doing that technology, right? What the good part of us kind of missing the boat and kind of letting that one slip away a little bit, we're a lot better now, is we started focusing more on software, electronics, semiconductor, interoperability, so really getting things with the internet and those types of technology, which are now the key drivers of what really is digital manufacturing today. So we've been able to play a pretty quick catch-up game in the United States. Well, we lost a little bit of space. We really figured out what we were really good at doing and adding that automation and digital content, which is core to what you see in additive technology. Additive is really brought about to the greater spans of users across the globe, how digital drives manufacturing, right? It's the epicenter for that, and that stuff we're actually pretty good at.
Rick, if you have a tip for the German spectators here, when we're looking from US, what would be a topic we have to look at? What must we work on? Is it digitalization, or do you see other topics to get more success here?
No, I think digitalization is the key, and I'll tell you something I've seen a lot of at this event that really is a great. Well, it's something we saw in mass at the Jimtov show that Doug and I were both at in Tokyo, which was automation. And to see the amount of automation that's going on here at this additive event is really impressive, and it really highlights the fact that additive is a technology that is now about high volume manufacturing and is becoming a mainstream technology for really the industrial world, and that is really the reason why we at Gardner and AMT are so excited to be bringing Formnext to the United States, because it is about industrial additive, cradle to grave, beginning to end, And there isn't an event like that. There's not an event like that in the United States now, but we will be bringing that event with our friends here in Germany to the US market.
Yeah.
So.
Okay, so we have an announcement here in the hall. So it's very.
This is what an exhibition is about.
We talked about that actually this morning, and we slipped this morning. So and we made it on point in the evening. But let me come back to the question.
Yeah.
I want to know if that aspect you mentioned. Do you talk about the machine, the processes in the machine, or are you talking about the whole process chain around the process?
It's the whole process chain, and that is really the unique thing about Formnext is that it looks at the entire additive process, the materials, the software, the hardware, and the service bureaus, the whole value chain that is tied to the additive community. And that's what we're really excited to be bringing to the US.
And to get a progress, we have to look more into this digitalization. And this morning we had the topic, we have to look more into connectivity and then take the data from sensors and so on, and do some AI on this data to have a better performance in AM.
As Doug talked about, the Americans' willingness to try things and fail, it can help you fail cheaper. Using this technology, because you don't have to get prepared to make 1 million of something and get all of the tooling and all of the other investment that's required to do that. You can fail faster and fail cheaper, which is that's good. It's a good way to run business.
Fail early,
yeah.
Then you fail cheaper.
Yes.
Yeah. that's all saying. Yeah. So I think. The announcement already brought it. The preview that we are coming to an end of Formnext today, not this year. Fortunately, we have 3 days left, but today. What will you do tomorrow in the morning at first? What is your first step into the exhibition? What is your first appointment?
Actually, tomorrow morning, I think I will be here because there's a really interesting talk of 2 people I really like a lot. So I will just sit there and look at them. That's what I'm going to do at 9 o'clock.
It sounds as we have prepared that one.
Yes. We haven't.
But really,
But we didn't.
But we didn't.
No.
So quick answer. Where is your first appointment or your first goal tomorrow?
Tomorrow, well, actually, I'm going to speak on behalf of the U.S. government and not myself because I go to another trade show. No offense.
It's okay, don't worry.
I have to go to Medica tomorrow, but I want to mention that we will be bringing our Undersecretary for International Trade, Marissa Lago, to the Formnext show. It's the first time we've ever had an Undersecretary for International Trade come to the show. And it makes sense that she's coming because this is a very important sector to the United States. So. And
we'll tell the whole story to her as well.
Yeah. Rick, you're first?
I suspect I'll be probably rehydrating first thing tomorrow because this event lends itself to some after-hours work as well as work here on the show floor. So.
Okay. We accept that. Yeah. And yours first?
Yeah, I'm an ultra-marathoner, so I'll be doing more laps of all the aisles, making sure I don't miss anything, and I also get my training in for the day. So that's my plan.
Perfect. So I wish you all a successful day tomorrow here at the exhibition, and that by doing the hydrating business, I don't know. And the hydrating is it?
Yeah.
Dehydrating, yeah. No, rehydrating.
Yeah.
So, no,
rehydrating. Yeah. Getting
sorry
water
for
back
it was a long day for me as well. I need some water.
I think you talked more than we did almost.
I need a bit of water. Yeah, dear ladies and gentlemen, dear audience here and at the stage, and the audience at home at the screens, thank you very much. Thank you for being with me at the end of the day. And
thank you for having us.
Yeah, sure. And thank you at home at the screens for being with us with our live stream that ends now. But tomorrow in the morning at 9 o'clock we will be on point here at our stage. And if you watch us at the YouTube channels, then you can watch us there again tomorrow. And if you miss the one or the other, no fears. We are recording everything, and you can have a look at all the recordings in the Formnext Mediathek. Okay, thank you very much, and come back home safely, and yeah, stay tuned.
Bye-bye.
go. Watch me as I go. Should I look both ways before you cross me, baby? 'Cause I don't break for boys. I'm moving on. For miles, 67 fastback, oh, it's just my style. We're headed down, down, down the road. Just enjoy the show, watch me as I go. Should I look both ways before you cross me, baby? 'Cause I don't break for boys. I'm moving on.